laid out different because I have at home. I've got a PreSonus Air 12. It's got a software. I never use the software because that's actually got a panel on it. So, but I played with the software. This is all computer controlled, right? You can look at this thing. It's just a little patch panel and a place for the laptop. It's designed ground up using the software. So that that's yeah, pretty much. It's got everything up there. If you look here, there's one sense tab here. You got the channel, you get compressors and all that stuff. They've got all the effects there. I assume there's probably VST to support it too. I don't know if that. You're getting the audio you're getting is the main channel, so that's yeah. I don't know. Okay. I don't, so that's why I said I don't know what it is.
Good morning, everyone. This is CactusCon, track 1, first talk of the day, with Ryan Thompson, Clearing the Fog, Detection and Defense Against Cloud Persistence. Thank you.
Thanks. Appreciate the introduction. I also appreciate all of you. 9:30 is a hard time slot to hit on day 2, so thanks. It's also a pretty competitive time slot. I know there's some other good talks going on, so I'll try to set the scope for what I'm going to talk about, and if this isn't the right talk for you, you can probably still catch the other ones. I want to make sure we're in the right spot. So first off, who am I? I have worked in the cloud space for about 5 to 6 years, in various capacities. I've done threat hunting, detection engineering, and then even the sexiest of the 3 up here is auditing, obviously. And so I've been in this space for a while, predominantly in the AWS space. Currently, I work as a senior cloud security researcher for a pretty major security vendor, trying to figure out how you hunt in the cloud across the control plane, across hundreds or thousands of customers, which presents its own challenges. So, what are we going to talk about? Well, more importantly, what are we not going to cover? I want to make sure we set expectations right out of the gate. We are talking about persistence, but when I talk about cloud persistence, I'm not talking about this host happens to live in the cloud, how do I persist on that host? Nothing host-based here. We're also not going to talk about how do we defend against these things. We'll talk a little bit about detection near the end and some ways that you can reduce your blast radius, but we're not really defense-focused talk. I'm not going to tell you what policies to put in place or what service control policies you need. And the last piece is we're going to be talking about a lot of API logs. We won't really be covering log parsing or ingestion. That's on you to figure out how you want to review CloudTrail logs or audit logs from Azure. That's 100%, you kind of choose your own adventure there. So what we will cover is going to be persistence mechanisms specifically for the cloud control plane. So quick raise of hands, how many of you are working with Azure or AWS? I assume it's a pretty good number, okay. And really what we're talking about is somebody's gained access either through the console or through access keys to your environment. How do they persist in that environment, that control plane space? And the other piece is we're going to be talking about hunting and monitoring strategies for these various types of behavior. So this is what I hoped this talk would be about. Equal parts AWS, Azure, and GCP, but as these talks evolve, you realize sometimes that's not going to fit into a 40-minute talk. Sometimes you realize these cloud technologies are too far away from each other. So here's a much more realistic view of what today's talk is going to cover. So if you're here for GCP, you're out of luck. Their identity is too far different than the rest of the other two. And then Azure follows a lot of the same behaviors that AWS does, but this is kind of where my experience lies. It's a great representation of my knowledge as well. So we're going to focus on AWS, pivot over to Azure, and show the equivalent. So here's what our schedule looks like today. We're going to briefly talk about the cloud, just a quick primer. We're going to talk about permissions in the cloud specifically, because that's crucial to maintaining persistence. Everything is a permission. We're going to go over some real basic persistence mechanisms. At this point in the talk, you'll probably be like, yeah, okay, creating a user is obviously a persistence mechanism. But don't worry, we're going to get more advanced in that next section, and then we'll wrap it up. So starting off with the cloud intro. For those of you who aren't super familiar with the cloud security space, I'm going to cover the 3 most common ways that people get into the cloud. And so first up, you have an instance breach. So what's happening here is you have a server or some kind of infrastructure out on the public internet. They gain access to that box, and on that box there are credentials. They then use those credentials to pivot into the control plane. And so this is pretty common. We're not going to get into all the different ways that you can breach that box or how server-side request forgery plays into it. Just know that is an avenue. The next one, also a very increasingly popular one as more people move to these software as a service and start putting their code and a lot of their secrets in other services, sometimes in an insecure manner, is leaked credentials. So maybe they put it in a GitHub. Maybe they uploaded a script that was supposed to be for dev. It actually went into a public repo and it had some AWS API keys in there. It's absolutely going to get scooped up and used. Last but not least, session hijacking. So I'm logged into the console through my browser. My browser has an exploit, and they're able to pull session cookies for my credentialed login and leverage those as temporary credentials. This is honestly the least common out of the three, in my opinion, but absolutely an avenue. So we're going to assume this breach. One of these three things happened and an attacker has landed in your environment. How do they want to make sure that they can persist there? So in order to persist in a cloud environment, you don't create a cron job, you don't create a scheduled task, you don't maybe have I don't know, some kind of run command that runs at the beginning of each login. You do it through permissions. So let's chat about that for a second. This is a very simple question, you would think. And this question came from one of my fellow researchers. They are not working in the cloud space. I was showing a demo, and they asked me the simple question: does this user have admin? And if you've worked in the cloud, you know this is a very complicated question to answer. It's not like it is on the host side. It's not like somebody either has root or they don't. Permissions are granted through policies. So whenever you're accessing the cloud, you're doing it through one of two ways, generally speaking. One is the AWS console, or in this case, a web console, could be Azure as well, or it could be through the CLI. Both of those need credentialed access and certain permissions to do a task. The logs look almost identical. Really what changes is your user agent. So nothing crazy there. These permissions are usually granted in a JSON document. It's going to go through and say, this is what you're allowed to do. Here's the resources you're allowed to do it on, and you apply that through various methods. So we can attach those policies directly to a user. We can apply them to a group that contains multiple users. Or the most complicated one is we can use a role. And so I want to talk about this a little bit because it's crucial. A role I think of as a hat. It's a hat that you can wear. That hat has permissions, and on the inside of that hat, they write down who can wear that hat. And so this is what's called a trust policy. And so down here we see this role has certain policies associated with it. Here are the two users that can wear that hat, and there you go. You have nice little Cowboys hats on user 1 and 3. So these are really the basic mechanisms for how you grant permissions in the cloud. So it's crucial to understanding these next few sections. So when we talk about persistence, there's really two major avenues. I either want to create attacker-controlled infrastructure or identities. So maybe that's a new key that I create that I have access to. Maybe I'm spinning up a new instance. Maybe I'm creating a new policy. I'm creating something from nothing. The alternative is I'm going to build a backdoor into existing identities. And so as we go through here, keep in mind, it's going to be one of these avenues. So some basics, just to really set the stage here. These are some basic persistence mechanisms. Some people may walk away with something from this portion, and that's great, but most of you have been in security for a while. This is going to be a huge surprise, but we need to cover the basics. So I'm going to go through a lot of API calls, and I'm not going to go into them into detail. I'm just going to mention what the event name or what the action is in Azure. If you want, you can scan this QR code. I promise it's legit. You can go there, and it's going to list out all of these as a reference, so you don't have to go and actually jot all these down as I'm going through it. So I'll leave that up for a few seconds. I see some phones coming out. But in theory, it should allow you to watch the talk instead of having to type things into a tiny notes app. It's going to be a better way to do it. I'll also pop this up at the end, so if you've missed it, that's totally fine. So, persistence option 1, I can create a user. And that sounds like, oh, well, that's great. You're done. You've created a user. But by default, that user has no permissions. We need to attach it through some mechanism. So if you create a user and you say, great, I can log into that user whenever I want, and you walk away, when you log back into that user, you're going to get some real sad console logins. A lot of access denied. Azure is going to pretend it's never seen you in its life. It's going to say, welcome to Azure. We have all these great things. Please sign up for Azure. And so at this point, there are no permissions actually associated with that user. So step 1 is create a user. Step 2 is somehow get a policy associated with that user. In Azure, it's called a role, but it's very similar. We're looking at attaching permissions directly to that user. So we have a couple ways to do that. Here are the API calls. In orange are going to be the AWS. In blue are going to be Azure. Pretty straightforward. We're going to create a user, and we're either going to attach a user policy or add a user to a group that has permissions associated with it. So once again, super basic here, but this is a good starting place. As we get a little bit more involved here, I want to take a look at alternative authentication methods. So in AWS, you have one of two authentication methods at a basic level. You have console login, so that's going to be username and password. I can punch it into a browser. I'm navigating the GUI. I'm good to go. The alternative is a set of API keys that I can build into my code, drop publicly into GitHub if I want to. I can interact through the command line. And so usually a user has one of these two. If you have a well-architected environment, you probably do it a little bit differently, but ideally it's one of these two. Either I'm using this to navigate, maybe to handle billing, maybe I'm a new user, I'm using the console, whatever that may be. And then I have my automated accounts that are going to be using CLI. That opens a door for attackers to establish persistence, and they can create the alternative method. So if I have a service account or what I'm using as a service account through API keys, and that's how it typically authenticates, if I create a console login, now I can log in as that service account, and maybe nobody notices. More importantly, that console access doesn't exist day one, and so I can go create it, and if I don't have good monitoring set up, all of a sudden I've got a direct path into that environment. So here's what they look like. If I'm looking at a GUI user and I want to create an access key, it's pretty straightforward. It's called create access key. I can request it for a specific user. It'll spit out those access keys that first time, but they're no longer retrievable. So if I create those access keys, I've got both the access and the secret key. I'm good to go. If I do console login profile, if I create one of those, I can actually set the password right there. It won't be visible in the logs, but I can set that for myself. Azure works a little bit differently. They have users and service principals. Very similar methodology though, right? There's going to be console logins and there's going to be CLI access through API keys. Now, the thing I've noticed about some service principals is you can create quite a few access keys with that, and so you're not limited, but those are going to look very similar. So I can create those. I can create as many API secrets as I can. So in AWS, a user can only have 2 API keys active at any time. So if those 2 are used, I can't really create a third. Azure, not so much. You can create as many as you want, which is it's kind of bonkers to me, but they do have expiration dates on them. So you can set them to expire over a period of time. So it's, either way. Here are the API calls used for these. Once again, these are all in the reference. So these are API calls I would understand in my environment and know what to look for. All right. We're going to go back to the hat analogy. We're using a top hat this time instead of a cowboy hat, but the kind of intent remains the same. When I want to set up cross-account access in an AWS environment, I create a role, and let's say Steve wants to access my AWS account, and he has his own account. Well, what I can do is I can create a trust policy that says Steve can wear this hat, even from a different account. And so what we have here is an example of a legitimate user able to put these permissions on. But if I can give that cross-account access to somebody I trust, I can also give it to somebody that I don't trust. So if I can gain access and add myself to a trust policy, all of a sudden, I don't even need to authenticate against your environment. I can just assume that role. I can wear that hat, and I can walk around in your environment and do whatever that set of permissions allows me to do. And so this is a fairly common method of persistence. It gets a little bit more advanced when we start building it into some Lambda functions and some other things that we'll talk about in a second. So from here, obviously I just notify me whenever somebody uses my AWS account that isn't in my account, right? It's that easy. It's not, unfortunately. If you have an AWS organization, you have multiple accounts, you're going to have cross-account activity all the time. So maybe you have your prod environment set up, but you allow a few of your security users to have read-only access to your prod for investigative purposes, right? So that trust relationship will be there. The other piece is if you have vendors. All these vendors up here have cloud, and more specifically AWS offerings that require that cross-role permission. So you're not setting up a user inside your environment for Databricks or Qualys. You're setting up a role and saying, hey, this hat, this is for Qualys. It can wear it. So you'll have to build some exclusions around that, so just be aware. And here's what an update assume role policy looks like. The event name is pretty straightforward. The policy document associated with it, log, is a mess. It is string formatted JSON. A lot of SIMs will be able to handle this, but you may have to do some conversion. You'll have to use regex to extract the account IDs and kind of figure this out. This is actually a great way to catch that cross-account activity. I was working for a client and I set up some rules. We actually were able to catch a few POCs being launched by other development teams. I think they brought in Orca security, they brought in Dig security to test things out, and they had to set up these cross-account roles, and they didn't let the security team know. And so we were able to catch those pretty quick. Luckily, they were legitimate. So once again, the afterthought of Azure has something similar. They do it a little bit differently. You can set up a guest account, which grants cross-account access within Azure. So there's 2 steps to this. The first step is inviting that external user, and then there's a log that's generated once they redeem it. I would recommend setting up an alert whenever the invite goes out. I don't really care if it was redeemed or not. I want to keep track of who's being invited to my organization. I take that back. I do care if it's redeemed, but I definitely care that they're sent out. Those are 2 sides of the same coin for sure. All right. Let's get into the fun stuff, though. These are some pretty basic ones. We've set up some accounts. We've created cross-account access. But let's get into some more of the fancy stuff. So first step is going to be what's called an instance backdoor. And so, I've talked a little bit about instances being a way that attackers get in. Maybe they breach it through some vulnerability. There are credentials on that box, and they're able to pivot from there into the control plane. And so this is the exact same path we're going to take, except we're going to set up the infrastructure as the attacker. So I'm going to set up this new instance, and in order to access it, I've got a few different options. I can create a brand new SSH key as an attacker. Now that SSH key is only downloadable when it's created, and so I won't be able to actually pull that back up from the console, but if I'm the attacker, I create it, I have that key. The alternative is importing or uploading a local SSH key. So I've got a key that I generated, I want to use it. And the last one is, hey, I've created a key. This is the key we use for all of our instances because we have terrible security practices. I'm just going to use that key again. And so those are the 3 options that you have. So if I'm an attacker, I'm creating this. I'm probably using one of the first 2 options. I'm going to create this instance, and I'm going to maintain access over SSH. The next step is you add a role to this instance. You give this instance permission to do things. And the reason this exists in general is if I'm developing something legitimately, if I need my instance to reach out and grab things from S3, or I need it to reach out to a database, whatever that may look like, there's legitimate reasons to add permissions to a role. It happens all the time. It's kind of the core of how EC2 in AWS works. But if I'm an attacker, I set up this role, or I set up this instance, I put a role hat on this instance and say, hey, you've got some pretty strong access. Maybe it's complete access if I've got the right permissions. And so from there, I can SSH back into that box and then hop back into the console. And you may think, if anyone here has played around with AWS, you're like, I've got 12 instances. I would know when there's a 13th instance. It's not really how enterprise environments work. We're talking thousands of instances per region. Maybe you even create this in a region where people aren't looking. And so think about that when you're setting up monitoring. Should you have any instances spinning up in the APJ region? Probably not, depending on if you do business there or not. So just keep that in mind. Once again, I have a really fun list here of API calls. Keep in mind, they can't do this without having access to these API calls. We'll talk about that later. So it's not like they gain any foothold and they're able to do all these things. This is why reducing your blast radius matters. So we'll catch up with that at the summary there. Once again, the equivalent for Azure, it's generating an SSH key or updating a SSH public key, and then creating that role assignment and creating a virtual machine. It's the same steps for Azure. They just use different names. You'll notice that I'm using 2 different versions of the action for Azure. Depending on if you're looking on the console or if you're exporting those logs out, they can appear differently. Azure is all kinds of fun with its consistency, we'll say. All right, so quick primer on AWS Lambda. This is when we start getting away from the manual configuration of infrastructure or permissions and more leaving some type of automation behind. And so what Lambda is at its core, it's really AWS's basic serverless offering. And it's not really that fancy. It spins up an instance, it runs some code, and it spins that instance down. That's really all it is. And there's a ton of different languages that are supported. If you're like me, you just always scroll down and pick Python because that's just what I'll die with as somebody who's not in the development space. But they offer a ton of different options. And it's not very complicated, it really isn't. You have a Lambda function that you grant a role to. You have code associated with that Lambda function, and then you have a trigger. If anyone has ever used if this, then that, that's basically Lambda at its core. It's not quite as drag and drop as if this, then that, but it's very similar. So what can an attacker do with this? Well, there's a attack or a post-exploitation attack framework called PackU, and they built an amazing module for this, and I'll go over it in just a second. If anyone hasn't played with this tool, I think there's 2 people in this room that I attended your talks that talked about PackU, so we're at least up to 3 at this conference. So doing pretty good with PackU. It's got some good representation. It's built by Spencer Gitson. He was a brilliant researcher for Rhino Security Labs. Unfortunately, he passed away at a very young age. I just want to give credit where it's due. This platform is amazing. So it requires some type of access keys, and it can launch different types of attacks. The one we're talking about is a Lambda persistence module. So the idea here is our trigger is a new role created. So we've created this new role. It's sitting here. It's got permissions. And maybe I'm using that for maybe one of my development instances. Maybe I'm using it for a production instance. Maybe I'm granting this to, it could be anything, quite frankly. So me, legitimately, as a user, I've created this, and that is the trigger. Code will run whenever a role is created, and what happens is the code tells me to add the attacker's user to this trust instance. So let's step back and think about what that means. I'm an attacker, I've gained access to your environment, I've created this Lambda function, and I've walked away. Maybe I didn't have quite the access to the things I wanted, but I was able to create or modify a Lambda function. So I set this and I walk back. Now, your legitimate developers or legitimate engineers are going to come in and create roles, and automatically that attacker will be able to wear that hat or assume that role. And so unless you're looking at your Lambda function and knowing what's happening, you may not understand how they're getting persistence back. There's no API calls that are made externally. These are all made internally from AWS. And so we'll cover how to detect this kind of stuff in a second. And yeah, now all of a sudden the attacker is wearing the cool chef's hat. They're gaining access to your environment. So I looked at this and I said, this is awesome. How can I make this more complicated? Because that's what we tend to do in this industry. And so within Lambda, there's an ability to create a function URL is what they call it. And so this is a URL that you can go to that triggers that Lambda function. So instead of it being automated, it's kind of manual. You click on that link and it fires whatever code is there. That's kind of interesting. It can be useful for a variety of different things. But what's more interesting is I can add parameters to that Lambda function. So all of a sudden, I create this Lambda function. I don't set an official trigger, but I do create a public-facing URL, and I walk away as an attacker. So what that does is it gives me the ability to launch that Lambda function whenever from a very unique URL. So I've got that in my pocket, and I walk off. What I can do, though, is I can add parameters to the end of that URL and have the code do different things. So I set this up, I give the Lambda function adequate permissions, and what I've essentially done is I built a C2 framework within this Lambda function. And so now I can go back to my browser as an attacker, months or years later, I can go to this URL and I'm going to get an error. That's totally fine. But I can go at the end and I can type in type equals help. And this pulls up a help function for me. So this is something I've built into the Lambda function. And so what's happening here is there's really not any API calls being made at this point other than the Lambda function running. But I can go in and I can say, hey, can you give me the help page? And the Lambda function runs its code and spits out this string. So far, nothing crazy. But I can change that. I can say, okay, well, I got some options here. I want to list users. And so I can type this into the parameter up here. Is going to make an API call from Lambda, and it's going to list the users. And so from a defender's perspective, which is the seat I normally take, what does this look like? This is a Lambda function that exists in my environment listing my users. Maybe that's normal, maybe it's not. But it's not coming from me, the attacker's IP. I'm making Lambda do it for me. So I can do more with that, though. I can expand this to do whatever I want, really. At this point, you can see I clearly gave this a B-sides Denver. I can go and I can create access, or I can list access keys for a specific user. Once again, I can build this to do whatever I want. I kept it focused on persistence, but I can say list user keys for this service B-sides Denver. It's going to list the keys that exist, so it looks like I've got one key. That gives me an opening to create a second key. You'll notice that this API key right here only gives me the access key and not the secret key. So I can't use this key yet, but I can create a second one. So instead of listing the users, I'm going to create a key for this user. All of a sudden, I've got access keys created for this user, access key, and the secret access key is over here. And so it's just a different way to maintain persistence that gives you a little bit more control over what's being ran. So you drop that in the environment, you walk away, you can come back whenever you want. Here are the API calls required to build something like this. You need to create a function. The 2015 tag on here is a little odd. That's just the version of Lambda or the version of the API call that's being ran. I assume that they really had an idea that they were going to update it more often than this, but this is kind of where we're at. We do create the URL config or the function URL, and then we update the assume role policy, right? We have to put a hat on that Lambda function. We have to put the permissions on that function to be able to do whatever we've designed it to do. In this case, list users, list keys, and create keys. Now, how do we detect this? It's pretty easy, actually, to detect Lambda functionality in your environment. If we're looking at API keys, we can see in the user agent, AWS_Lambda. And most of the time, I would say user agent is a weak way to actually go about doing things in terms of detections, but in this case, because it's spinning up from Lambda, it's actually pretty good. I'm not going to sit up here and say there's not a way to change that. I haven't done the research into that, but out of the gate, that is a box that is controlled by AWS that is spun up temporarily to run your code. I think it'd be complicated to do, to say the least. The next question is, what do you expect your Lambda function to do? Do you expect it to do IAM activities? Do you expect it to spin up instances? I can't answer that for you. I can tell you that if you're building this detection for a single environment, it's much easier than building across hundreds or thousands of environments. When you're doing that for a vendor on behalf of a huge customer base, this becomes really difficult. If you're doing it for your own environment, it's much easier because you can take a look historically at what Lambda's done, build guardrails around that, and it'll alert you when something goes kind of out of the ordinary for that. Azure has something similar called runbooks. You can build a very similar persistence mechanism there, and you do create a URL for that as well. And so you can see we're generating a URI for this Azure automation webhook. We're creating a runbook. It's a lot of the same things, just different language for Azure. And so it works very, very, very similar. Now, I haven't built out a full C2 framework for Azure, but in theory, you're still running code. You can still grant that runbook permissions. It's all the pieces are still there. So, in summary, what do we do about this? Right? We have, we've gone through a bunch of different persistence mechanisms. We started at user creation and went all the way down to some more advanced automation work. So, what are the next steps? You have your initial access vectors. And so, good news, it's actually really easy to stop this. You just don't let your instances get breached. You stop developers from uploading credentials into their code, and then you stop users from clicking on links. It's actually really, really easy. It's not, right? It's actually really hard. So we're going to assume these things are going to happen. That's not where this talk is focused on stopping. There's some mechanisms you can put in place, but that's outside the scope. So we have this list of API calls. It's not great. I changed this to a light mode presentation last night, and the orange does not have great contrast, but that's okay. We've got this full list here for both of these. Now, what's interesting about doing security in the cloud is these API calls serve two functions. First of all, I can go detect these activities using these API calls. The other side of that coin, though, is these are the same API calls that are going to exist in permissions that will allow an attacker to do these activities. So it's actually really nice, whereas within a traditional security space, you're indicators are much different than the actual permissions that are needed. They're almost decoupled. So what do? We need to limit our blast radius. We're going to assume that that identities will get breached. And what we see in the cloud a lot is the cloud is complicated, it's new, it's spooky. So what people do is they're trying to get something to work. They just want to see the API call get sent successfully, and they end up building policies like this. EC2 equals asterisk. So that's wide open access to to the entire EC2 service, and they can do any activity. And I don't blame people for building things this way. I used to build things this way. It was in a lab environment, not production, but I can guarantee you this happens in production. A better way to do this is to restrict your policies to exactly what you need. And so over here, we have a much better written policy. This is saying that you can associate an instance profile. That is the action you can do. It's a single action. And the resource over here is an asterisk, but over here we specify the exact resource we need with an asterisk on the end. So any instance starting with the name district. So much better way to do that. And then on top of that, you can create conditions. This one in particular says MFA must be present for this to work. You can even have these expire after a certain amount of time. There's all kinds of things you can do with conditions. So when we go back to auditing, right? Like I said, this is a sexy part of security. How do you audit your environment? It's actually pretty difficult to do in AWS in a lot of cases, but they're building tools to make it easier. So when I go to look at a role, so this role's been created, maybe I made it overly permissive, and I want to pull those back in. AWS has built a functionality in that says, hey, we're going to look at the last 90 days of CloudTrail. We're going to see what activities it's done and what resources it's done it against, and we're going to build you a policy based on what it's actually using, not what you've granted it. And so that's a huge win. That's a great starting place. Maybe it's not 100%, maybe you have to tweak some things, but that's a great start. There's also some third-party tools. I built something for an engagement that I have posted up on my GitHub that basically goes through and it takes a look at users, groups, and roles within an AWS environment. And it says, it's a little hard to read here, but you can say, hey, this policy here, it has a role, this policy is attached to a role, and here's the trust policy. Hey, this policy is attached to multiple instance roles, and here's the policy. And what it does is it looks for things that are overly permissive. So in this case, we see the action is ECR asterisk. In this case, it's ECR asterisk. Down here we have, let's see, oh wow, this is a fun one. RDS asterisk, S3 asterisk, all types of services wide open, right? So it said this is a sketchy policy. Where is it attached at? So we see it attached to all these users, and also spits out when the last time those access keys were used, when the last time the console login was used. And so having something like this is incredibly powerful because doing it by hand is not fun. We have a lot of clients that have tens or dozens of AWS accounts, and if you're doing this manually one by one, it can be pretty burdensome. So with that, I'll open up the floor for questions. Yeah, so the question was, I talked about breaching an instance and getting into the cloud via instance with the permissions that are there. And the question specifically was, do I see less of that with instance metadata version 2? So for those of you who don't know, instance metadata version is a way for an instance to gain access to information about itself, metadata, if you will. And part of that metadata is credentials. And so what version 2 introduced is basically a protection for machines with server-side request vulnerability, server-side request forgery vulnerabilities. That's a mouthful. It basically blocks that. So in version 1, if I could make that server send a web request, I could probably get it to give me the credentials of that host. That's what that means. Version 2 disallows that. Are we seeing less of it? I don't have the numbers on that in front of me. But one thing to keep in mind, while version 2 does a great job of stopping an attack over the network, if I gain access to that host, any user on that host can still pull the instance metadata. And so it's not a foolproof, but I have to assume it's gone down some, to your point. Now, What I can say, though, is across our customer base, we have about, I think it's, last check is 28% of the instances being spun up with version 2 required. And so what that means is a lot of machines are still being spun up with version 1. We can talk about it more, the challenges of that, but it's not as easy just flipping the switch on, right? By the way, instance metadata version 2 has been out for 5 years, and we still have, 60, 70% of our instances being spun up without it. It's wild. Hopefully that answers your question. It's a bit rambling. I had to add some context to it. Does anyone else have any questions?
So in the DevOps world, there's a lot of CI/CD and people starting to use things like Terraform and that type of stuff now. People are having trouble dealing with like multi-factor authentication and automation, right? So they're just kind of like skirting it, or like what is the proper solution to that type of stuff?
So the question was, with DevOps being more prevalent, more CD, CI, I think that's right, CI/CD, not my world, very clearly, sorry, being used, what is the proper way to pass credentials across? And there's some services, things like Cognito and Secrets Manager, having some way to get away from hard-coded credentials or even anything you have to put in the variable space or into the code itself is going to be ideal. I don't know how you would handle MFA with a DevOps pipeline. I'm guessing that option is going to be Secrets Manager, but I would look into that. Not my background, I apologize. Great question, though. Any other questions? All right. I'm giving it the long enough amount of time. Thank you, everyone, for showing up for this talk. I really appreciate your time.
How's it going, man?
your nodes that you run are not tied to an identity at all. So your personal identity is safe. The apps that use the nodes, they don't know where the other nodes are located. They know that nodes exist in the world, but they don't know what they're running. They don't know who's using those nodes or what apps are running on those nodes. And it was designed to be resilient and fast and to switch. I mean, when you're mobile first, you have to deal with like the nodes you're running, like going through a tunnel as you're driving your car. You know, it can't be relying on nodes being up and functioning all the time. So unlike a lot of overlay networks, this was designed for downtime and for churn.
So we presented this idea back at DEF CON, and you know, it's come a really long way in the past, what has it been, 8 months, 6 months?
6 months.
I don't know.
Yeah.
I've lost all meaning of time. When Dill first came to me about this back in 2020, he's like, I have this weird idea. I'm a little scared about, you know, doing it, because this could be really something that's really bad. We've seen, you know, some things that have happened when you just let people have privacy on the internet. I said, no, I think this is what matters. I believe that if, you know, we should be making privacy, you know, as accessible as signing up for Facebook.
Yeah.
We should be, you know, working on something that is giving the entire world the opportunity to be private without having to jump over a bunch of gates, without having to go through all these hoops, without having to have the technical knowledge to, you know, go and, you know, start working with proxies and things like that. We want to make sure that everybody has the ability to, you know, not be the product for some billionaire. As of July 2023, the network was officially working. We were able to, you know, pass data from one node to another.
I think it's up to almost, I mean, we really don't know, but like 1,000 plus nodes now. So it's people are running it. It's pretty cool.
We have a good guess. We actually kind of can't tell. That was the beauty of this, is we are releasing it into the world, and there is no overlords. We're not the overlords. We don't run it. We have just given it to everybody. We presented it at DEF CON 31. We threw a really epic party. It was my first time throwing a party like that, but we had some amazing musical guests. I brought in some, you know, different, you know, entertainment that isn't normally at DEF CON, and it was a lot of fun. We actually had the most Cult of the Dead Cow members at a conference since BO2K.
Yeah, it's been 20 years. So.
Yeah. So it was a nice return to the way things, you know, used to be back in the hacker scene. And I was really excited for the opportunity to put that back together. Speaking of returns, you know, he mentioned about Web3, you know, Web3 and where that has gone. And we've seen that it's gotten, you know, filled with a lot of like scammer types. And we don't want to think of ourselves as Web3 or Web4. I want to take it back to Web 1.5. This is what we should have had all along.
Yeah, the future we were promised, you know.
You know, when we were younger and the internet was first introduced to us, it was introduced as a free, welcoming landscape for everybody to exchange ideas, for people to connect to one another, for people to, you know, share some nerdy niche information for other people into that nerdy niche thing. And instead, what we found ourselves is this situation where every little thing that we do online is being scraped, and it's being put in a database, and it's being sold to this person, to that person. And we don't know where that's going to lead.
Yeah.
You know, we're looking at a world potentially where, you know, our kids and our grandchildren may not be able to get health insurance because grandma joined a Facebook group so that a support group for her depression. We are looking at that as the future. Do I really want to go into Web 4 and Web 5 looking like that and having that be the future?
No.
Nah, this is Web 1.5. This is what should have been there all along. Went on a tangent. Sorry, I get really excited about this stuff. Anyway, at the same time, the plan was we wanted to not only present this cool code, drop this, you know, whole thing. We wanted to build a community. We wanted to give everyone the opportunity to join us in helping us build this. And we established a Discord community back at DEF CON. And it has grown, and we're going to get a lot more into some of the things that have been happening since DEF CON. This is not the same talk. So, this is our mascot. This is Elliot. They are a brick. I found myself thinking, I really want to make something this is, going to catch on. I want to make the marketing something fun that people will remember. And, we have bricks. And the idea behind this is that, we've all heard the story of the three little pigs, right? Bricks working together build something that lasts. They build something that is strong. Bricks build amazing things all together. But there's also the implicit, meaning here.
Yeah, our community is people that might carry bricks around in their car, so,
A brick started pride,
yeah.
all right? And, bricks, to me, every tool is a weapon if you hold it right. And when I look at a weapon and I look at the window of data capitalism, I don't know, I get ideas. So, I mentioned that Discord community has grown, and it definitely has. I believe we just hit 3,000 members as of this morning.
Yeah, I think so.
So 3,000, that's pretty sweet. And people are active. And it is 3,000 diverse members, and that means so many different things. It doesn't just necessarily mean diversity of, gender and race and backgrounds, but it also comes down to diversity of skill types. We have a lot of people in there that are not necessarily technical, but want to see the internet change for the better. We have people in there that are accessibility experts. We have people in there that are lawyers, marketing people. People are coming in, bringing ideas for apps that could be developed on the Valid network, and we are able to give them the tools they need to not only help build that app and make that back end run great, but also to make it usable for everybody, because there is no point in continuing to build these complicated apps that are only available to people that understand the internet. We're seeing a lot of things come out lately that aren't accessible to people. We love the idea of Mastodon. I think it's wonderful, but it's not mobile first, and that is how people are checking their social media. That's how people are connecting, is on their cell phone. They want to sit and scroll and talk to their friends, and then we're not building it for everybody. So we want to make sure that we are giving everybody the tools they need to build it for everybody. Also, we got really caught up in, just getting this code written, and we kind of didn't do documentation. We're not real good at that.
Well, when you're iterating really, really quickly, if you were to stop and document everything and have it become obsolete 5 minutes later when you realize that you needed to change things around, it gets hard to settle on an API level commitment. Once you start writing English, people start to read it and have expectations. If you want to remain nimble, sometimes you can't afford to sit down and bake it all into text. But now, as things are starting to stabilize, it's the right time. We need to make sure that people understand how to use this thing. And that means documentation. It means the API docs, but it also means guides and books and user-level stuff, as well as all the crazy internals of how it works.
So we have been going back and doing huge runs for documentation, having a lot of help with that. We are really grateful for the folks that have come into the Discord and helped us out with that documentation.
Yeah.
And we do have some published guides now. You can go check it out on the GitLab. We have the Rust docs, and we have the developer and the internals books are in the works. They're going to be coming out soon. There is pieces you can go see what we have available.
They're living documents. They're being built today by volunteers who just wanted to learn how Valid worked and were willing to write it all down as they learned. So that's cool.
All the code, as we said, is open source. Everything that we're building is open source. We want to make sure that this is all available to everybody and that you can go through it and see that there are no backdoors. There's
no tricks.
No tricks, no nothing. We've had a ton of technical improvements since then, pushed quite a few updates.
So, yeah, as of DEF CON, we have published all of the crates for Valid, which includes a core crate that everything links in, and some other useful tools that sort of improve the state of asynchronous Rust and other things that we felt were needed to make Valid as performant as it is. We have improved our private routing performance as well. So when you allocate a private route, it selects nodes, and we'll talk about how that works in a little bit, but you have to select nodes that you can kind of trust, and then your destination has to find nodes that they trust. And what happens when that churn happens? You've got like 4 nodes in a loop that form a circuit. What happens when the network goes down for one of those nodes? How do you very quickly reestablish a route for the 2 endpoints without having to deal with like packet loss and stuff like that? So there's all these little details of like how Valid takes care of its connections. Better WebAssembly support by a long shot. WebAssembly is now first class for Valid, so basically everything you can do, including distributed hash tables and storage and private routing, all of that can happen right through your browser. Browsers normally cannot receive inbound connections. You might be familiar with how WebSockets can only go out. Well, Valid has facilities for inbound relaying as well. So nodes can help each other out in an encrypted fashion so that those browsers can still receive connections inbound through an inbound relay that they've made an outbound connection with. So the entire signaling mechanism is enabled browsers to be full first class. Much improved stability. Nodes are dealing with network churn and even the weirdest symmetric NAT, carrier grade NAT situations, all the weird stuff you might find on your phone as you're going through different cell tower systems and whatever else. Corporate networks, that kind of thing. It gets real weird on the internet, and you see all these IP address ranges that you're not sure what is that documentation range? When do they use this and that? It's all built into Valid now. We support a distributed hash table built across the entire Valid network. You might think about that as using the hash space of the public keys of all the nodes as a locality metric for storing copies redundantly of mutable data that you push out to the network. So we have this whole crazy schema-based DHT. It's very different than a lot of the other DHTs you might find for like BitTorrent or some of these other Web3 projects. It's very innovative, has schemas which allow multiple writers to happen and communication to happen through the DHT. It's really kind of neat. Beyond the scope of this talk, but definitely come to Discord and we'll fill your brain with it. One cool addition that we've had recently is that it supports pub sub notifications as well. So if you make a DHT record and change the value, other people can notice those changes immediately and be notified rather than having to do polling like every 5 seconds to figure out if a value's changed. This allows you to use the DHT as a communication mechanism for things like synchronizing messages for a chat app, for example, and it makes those messages arrive just like this instead of waiting around for an update. So yeah, interrupt-driven stuff instead of polling, right? Good stuff. One other big deal about the way we are doing Valid is we are a security-first organization, and I gotta say, this is the first time that I've had the opportunity to do this. I've thought about this for a little while, but I've always been proud of getting hacked, We encourage people to mess with Valid and break it, to the point that we've had a number of researchers, enterprising folks who, want to come in and, help us break our own stuff. We actually take their exploit code that they give us and publish it in our own repository. I don't think I know of any other projects that do that are so proud of getting owned that we'll put the code that owned us right in the repo. So, if you want to get your first contribution, hacking Valid, we'll put the exploit right in the repo, tell everybody that, here's this, here's the CVEs that came, we actually have a few CVEs already, we fixed the bugs. But this helps us because it encourages all of our developers to make sure that they're using the latest version of Valid and to upgrade. See, when you're in a peer-to-peer system, you can't just upgrade some core backend, like a big corporation, they've got a bunch of Amazon cloud machines, they roll out a bug fix, they just push it to all of the machines they control. For us, we don't have that luxury. We can't force some person to update their app. We can't force some node operator in, wherever in the universe to upgrade their version. So to keep the network flowing, we have things like security vulnerabilities as a strong arm. We can say, oh, there's a critical vulnerability, upgrade your servers, and if people don't do that, we can lock them out for having not upgraded. You can have the ones that have upgraded not want to talk to the ones that haven't. So the network is a little bit self-healing in that way, but it helps us to be able to put pressure on people to upgrade by just giving zero downtime, guarantees here. Just go get the upgrades done, as soon as you find out. So, yeah, we're pretty proud of that. So we've had some denial of service type things and an unbounded decompression. Again, because of Rust's memory protections, these just are crashes. It's not like a remote exploit situation, but it was still significant enough that we felt it was important to fix these things and highlight the fixes that people prompted us to do.
So when we started building this, this network, we had some use cases in mind. Obviously, the first one we were thinking about is, man, I really wish Twitter wasn't, going as crappy as it is, and I would love to build that. But honestly, we are quite a few years away from that. There's so much nuance, especially when it comes to, building a safe environment for everybody that is decentralized. So that was the first immediate use case we thought of, and since then it is very much so on the back burner. My introduction to this entire industry, to hacking, personally, was some of my pictures leaked that I didn't necessarily want them to get leaked. I accidentally did some hacktivisms as a result. And so I, wanted a way that people could communicate and store that sort of, private stuff, a way to store it in a way that wasn't going to end up finding on some weird website. Those were the use cases we thought of, and obviously secure and private messaging, which we are going to be getting into in just a couple of slides. I really thought that it would be cool to have a secure and private messenger that, did not let your ex know when you joined, or that involved giving away your phone number.
Yeah.
So that's the first one that we are tackling. These were our immediate use case thoughts. But what's interesting is when we opened this community up, people had other ideas. And that's what I love about community, is people are going to think differently than what we thought. And these are the projects that people are pushing, and starting to, develop a community, a sub-community around, building their team so that they can start getting these apps out there. A decentralized wiki, Wikipedia that you can it's there. A private Slack alternative, Slack, Discord, all of those are, I believe, what was the word Cory Doctorow used? Shitification. Things are getting real weird in a lot of those apps, and we would really like to see something that is stable and private be more available. Patient portals that are easy to use, that are actually not storing any of that information on some server somewhere for somebody to ransom. That's huge.
Yeah, it's a big deal right now for some people, unfortunately. So.
Yeah, we're seeing a lot of, people's health be, put at risk because of ransomware and because of hacking. And so why are we putting it on servers in places that people can have, be holding hostage? The other idea is a privileged chat between lawyers and clients that has the legalese written right in the TOS that explains what attorney-client privilege is. And also that is not stored on a server somewhere, so that is not going to end up somehow getting, published because they, somebody didn't take care of that data the way they should have.
Data provenance is hard,
Mm-hmm.
So.
And as Elliot says, the possibilities are endless. It's a brand new way to look at how to build apps. It's a brand new way to look at how to approach the internet. And we have really done the work of making it easy for developers to start trying different ideas. Because there isn't any overhead. There's no server costs. There's no anything. The only thing that developers really have to put into building an app is their time, their energy. So it gives a lot of people more freedom to try new things. The possibilities are literally endless.
So yeah, I'd like to highlight some of the things that people have already successfully published using Valid. Some of these are honorable mentions. Some of them are pretty cool just on their own. We have Tailveil, NetDog, a Valid plugin for the Bevy game engine, and a little honorable mention called Valid Towel. I'll just go through those little projects. But these are all people who have come to the Valid Discord, engaged with us, learned how the system works, and just started putting some code and linking Valid in and making something happen with it. And some of these are, I'd say, all happened in the span of less than like 2 months of development time, and that includes learning how Valid works. So it really isn't that hard if you just bite the bullet and start going and start working on it. Tailveil is a plugin, a VPN like Tailscale, but uses Valid as a network substrate. So it creates a ton interface on your Linux box or whatever, and you can route your VPN over Valid from one point to another. It's a pretty cool use case. It's not a full-fledged VPN solution, but the fact that it works is pretty cool. It shows off some of the sort of snappiness of the bandwidth and throughput of the network, which is pretty neat. Another one is NetDog. If you've ever used Netcat, you probably have. Everyone in this room has probably touched Netcat at some point. It is just a simple tunnel builder that lets you tunnel stuff arbitrarily from one end in one node in Valid to another node. And it's as simple as running the server, cut and paste the blob, which is like a little private route, bunch of encoded string. You paste that into the client, and now you've built a tunnel, and you can just start feeding content through over standard input. There was a plugin for the Bevy game engine. Bevy is a game engine written in Rust, so you can write your entire game in Rust, and it's automatically portable to a bunch of other platforms. It's very simple, but this is a networking substrate for your game so that you can have your clients all reach each other, and it's done over Valid private routing. So there's a game out there you can play, the Valid Checkers. It's simple, but it shows off the capability of the plugin for the game engine. It can be used in any other Bevy-based games as well. So it's a proof of concept, but I think it's pretty cool that someone just decided to make our we have like a development framework. It's neat to see it plugged into another development framework. It's just going to end up in more apps that way. I think that's great. And then, of course, there's Valid Towel. Valid Towel is ASCII streaming Star Wars over Valid. It actually plays the little internet towel video thing of the ASCII Star Wars over a Valid link. It's goofy, but it's fun little ASCII art thing, but it runs over Valid. I'm not sure why that matters, but you can do it. Anyway.
These are the droids you're looking for.
Yeah, right, yeah. So anyway, they're instructional, they're useful, so it's just simple. It's a hello world, but it's got Star Wars in it, so whatever, So you can learn how Valid works with something very, very primitive and simple, but it's cute, so. And of course, we have Valid Chat as well, and that's going into public beta very soon. I am actively developing on that right now. We have a bunch of private beta people using it, helping us debug. But the code is open if you want to see how we're building it. It's a first-class Flutter and Dart app that runs on all of the platforms, your desktops, Windows, Mac, and Linux, iOS, Android, and WebAssembly. I'll give you a little bit of a peek into how that's going to work. But feel free to join the Discord if you want test flight invite code when the time comes. It's another couple months tops. So, Vela Chat.
This is the sign up for Vela Chat, and that's it.
You download the app from the App Store, you run it, this is the first thing that pops up. You put your name, some pronouns in, and hit create, and that's it. There's no other sign up, no other identifiers, no phone numbers. Nothing.
No asking to access your contacts. No, nothing. It's going to be simple. It's going to be easy. This is something that everybody can use. You have to connect with people out of band.
Out of band, yeah.
Out of band in order to message with them at the moment. But that's simply because you don't want random people messaging you. I don't like it when I get text messages from random people.
Yeah, you're not going to get weird incoming chat requests from the internet by using Vela Chat. You have to at least kind of know who you're talking to. You can send them an invitation. The way this works is you just say, I want to create an invitation. You create this invitation. It says right here, send contact invite. Put a message in for the recipient. You can protect the invitation with a PIN or a password, which could also be shared over some other medium if you'd like. And you hit generate invite, and what you don't see on this page right now, but I'll show you on my phone after the talk if you want, is it pops up a little QR code and an option to copy the contents of the QR code into a text encoding. You can then paste that over iMessage or over other messengers to do that initial contact exchange. Someone would import that by pasting it into Vela Chat or by clicking the scan button that's on it, and it's going to scan the other code. And that basically just transited a random encryption key, which is used to decrypt a DHT record that was published with the invitation. And that has a conversation pair that is then synchronized once your identities link up. We can talk about identities at some point. It's a little more complicated, but Valid Chat is also the first app for Valid that has an identity mechanism built into it. It has a master / rotating identity key system where you can roll a new identity on a regular basis, and it's all tied to an initial identity. So if, like, say your machine was compromised and you needed to regain access, you have offline recovery keys that are built into the system, and it's that same mechanism that also lets you share your Valid Chat with one, your desktop as well as your mobile device, for example.
But if you lose those, identity keys, we can't give them to you.
Yeah, there's no recovery mechanism, there's no centralized way of getting your account back if you
Because we
if you
don't know
lose it.
that you have an account. We don't know you exist.
Right, and the way that our DHT works, if you don't refresh those keys, it's not fully permanent. So if you were to just delete your account, all of the copies of your stuff, even, first off, once the key's gone, no one could decrypt it anyway, but it would eventually just sort of time out as nobody cared, and other more popular content overwrites it. So, yeah, it's got some interesting features already. We are actively building multiple account support as well, so you can have a separate Valid profile in the app for, say, work or for your friends or for that one person you just wanted to chat with online but you didn't want to give them your identity. We can share the accounts between desktop and mobile platforms. You get your same messages delivered simultaneously between all of the accounts that are logged in. We have localization support built in from day one, so everything can be translated. All of the text is not baked in English or something. It's all translatable. We have lockable and deniable accounts as well, so that every account can be locked with a PIN or a password that is required to unlock it, as well as a duress password. So you could put something in case someone's trying to rubber hose you and show them that it unlocked, but there's no messages. That way, if somebody's trying to rubber hose you, you can comply, but they won't get a copy of what you're doing. They won't be able to prove that that wasn't your password.
And we are also making sure that we are building accessibility as a foundation of this project. We want to make sure that this is going to be accessible to everybody. It's taken a little bit more time to make sure that when we release it, we're not having to go back and, suddenly realizing that, this is not working for people that, have issues with hearing or seeing.
Low vision, requiring a
Vision.
mouse, that kind of stuff.
Yeah, so we, from the start, are building accessibility as a foundational aspect of this. The end user, we want to make sure they are having the absolute best experience possible, because we want, like I said, I want to make privacy just as accessible as Facebook has made it to our parents. We want to make it comfortable. We want it to make it very welcoming to everybody.
Okay, so, yeah.
So here's where I get to spout off on the ideals. All right, so right now, Valid is so important. As I've said, we are facing the internet and all of this data being scraped and stored, and I'm still hearing horror stories even today, or yesterday at this conference. I heard about how, various websites are collecting your health data based on the fonts you're using.
300 trackers on a medical website. I'm like, give me a break.
Like, that is terrifying. Where is that going? Where is that ending up? It's being sold to how many different companies? We are seeing a world where our online activities are being tracked more and more and more. We're living in a world where people who are, messaging each other to, get health care in various states are going to jail because they're turning this stuff over without a warrant.
Yeah.
Okay, the future of that data looks pretty bleak. It looks pretty scary. And all that's being done with it thus far is, keeping more people, keeping the people down and allowing billionaires to go and, try and fight each other or go to space or whatever
Yeah.
weird ideals they have at the moment. But either way, we shouldn't be so reliant on these billionaires to be protecting our data. The cloud doesn't have to be Jeff Bezos' computer. We have already paid $1,500 for this supercomputer that you carry around in your pocket. Why are we still continuing to pay? Whether that's either monetarily or with the bits of your life that you are handing over to some random internet company every time you log on.
Now, what's the first thing you think of when you see a free app on the App Store? You know that you're going to be getting ads, and a lot of them, and that's how you're paying with your eyeballs. And we got to stop paying with our eyeballs.
We also want to be able to give developers the freedom to do things that they normally wouldn't have the freedom to do because it would be too expensive to try and fail. One of the beautiful things about Valid is that there is no board that anyone has to answer to. We have no intentions of making any money on this. That is the last thing that this project is for. Can't be bought. We don't have to give developers the choice of either you're going to make the user experience less enjoyable, or you can sell their data just to make ends meet and keep the app in the store.
Yeah.
That doesn't need to happen.
That's a perverse incentive.
It is.
You know.
So let's break it. Let's just not do that anymore.
Yeah, do something else.
Yeah. We really want to be able to give people the freedom of not having to have that much invested monetarily into building an app.
Yeah.
You can build things just because the world needs them, and it's not going to cost you anything but your time and your energy. And that's the way it should be.
So yeah, all that's missing is you. You can join, you can help us out. And Valid's really what we make, all of us make of it.
Yeah, together, we can hack the planet. All right?
I find it's kind of weird and ironic that hackers pride themselves on making computers do things that they were not intended to do. This might be one of the first times that I've started building something that makes computers do what they were intended to do. It's a different way of thinking, but I'm kind of like, whoa, really, this is what they were thinking about when they put that internet together. It's like everyone was just talking to everybody, sharing everything. It's like, this is the first time that the hacking is going the other way. So,
Everybody always thinks of hacking as, breaking things. Move fast, break things. What about move fast, build things?
yeah, build a better
That's
future.
hacking too.
Yeah.
We do have the Discord, and we are, my background personally is with activism and mutual aid and building these communities. One of the things that's great about our Discord, like I've said, there is no, risk of coming in and trying something new. If you know of people that are not necessarily in cyber that are trying to break into the industry, tell them to come in. Tell them to come in, contribute, try to do something.
The diversity of perspective matters a lot to us.
It really does. Not to mention what we're doing, there's a lot of people in there that are hiring managers. If you, go and you do something and contribute to the project, we'll be more than happy to give you a reference to show that you have experience in the field doing this.
Yeah.
And it's a way for that footing to be equal.
Go ahead,
when
stick
it comes
contributor to Valid Foundation on your LinkedIn. It'll help you get the foot in the door. We'll tell everybody how you helped.
Mm-hmm.
So speaking of Valid Foundation, real quick, we do have a 501c3 nonprofit charity that exists to develop, distribute, and maintain a privacy-focused communication platform and protocol for the purposes of defending human and civil rights. We have to say it that way. It is our mission statement, according to the government. Basically, Valid costs us not much to actually run, if anything. I mean, we have some subscriptions for GitLab or whatever and other little pieces of things, but Valid is self-sustaining. When you contribute to Valid, you're helping us with outreach, coming to events like this, some marketing around it, paying for some of the human time involved in helping to make it happen. So if you want to write off or you want to tell your company to do their matching donation, you have the opportunity to do that here. And we're eternally grateful.
And none of us are quitting our day jobs. We're all, this is our hobby.
Yeah.
It's a weird hobby, but we like it.
Yeah, absolutely. We've had a lot of contributors, and I'd like to actually go ahead and thank them right now in person. You can see on the right here is a list of the pull requests that we've accepted to the repository. I think only one of those in the last month was actually from me. You can see a lot of other contributions from other people. We've had people working on documentation, specifically this guy Kianha, who has been absolutely tireless in helping us build the books and documentation in Rustdoc. Retroid, who's an absolutely amazing hacker, has contributed to tearing apart Mastodon's protocols and Twitter, and to his credit, one of the security vulnerabilities in Valid.
We have Daniel Meyerson. He's a lawyer. He asked us what we wanted to do about our privacy policy, and the only thing we could say is nope.
Yeah, we don't want it.
We don't want any data. We don't store any data. Just nope.
Nope. Yeah. So.
And he managed to turn that into an entire comprehensive privacy policy, which I highly recommend you go read if you're into that sort of thing. I am.
It is the edgiest, coolest privacy policy that is still legally binding and viable. So, really proud of that. Sal Testa did a bunch of Rust work with us. Eve Hobart also Rust work. Definitely, small contributions matter. Fixing little things that might just become a foot gun for somebody, or porting like a small piece of code that needed to make it work on FreeBSD or other platforms. Paul Saginaw also bug fixes, but really with a focus on making sure that Valid Check gets out the door on time. People have been helping us, lubricate these things, get out the door. CI/CD optimizations, automation really matters to a small team like ours. So people who have helped us move faster, get a lot of credit. Testing, testing is like documentation. Nobody wants to, but you gotta. You want to scale, you have to have good tests, and we've had people help. Sergey Surovtsev did some tests for our distributed hash table, which were great. Documentation cleanup, Haley must have committed like 50 different pull requests, fixing everything from silly typos to things that were just simply not clear. And Rivka Sagan has written maybe one of the big security vulnerabilities and a number of other just architectural patches, helping us identify places where we might have accidentally incorporated some privacy fails in places that we shouldn't have. So no contribution is too small. Please help.
I also would love to thank our core team.
Yeah.
My husband, TC, many know him as Super Tease on our Discord. He has been a huge help as far as even just throwing ideas back and forth with him about how various things are going to be working. The Gibson has been absolutely amazing and a huge help when it came to getting this thing off the ground in the very beginning. Not to mention, he introduced it to Hackers.town, who has been amazingly supportive. That entire Mastodon community has really rallied around this idea. We have CodeBabe, who built our amazing website and constantly, is more than happy to update it whenever I have some weird whim or I'm like, I think we should just make this word different. Our lawyers have been amazing and answered so many questions because I have a ton of them all the time. Every member of the Cult of Dead Cow has really come together and helped either make the party happen, helped us, formulate some of the ideals, asked us the hard questions, about like the bad things that could possibly happen and see how we're going to handle them and help us, create game plans for the future. And honestly, this idea that started way back when, it has grown into so many people and so many different things, and I would love to see the world truly just get the internet we were supposed to have all along. And that's going to take everyone here. If it stays in this room, if it stays in this community, then we have failed. We want to make sure this is accessible to everybody out there.
And at the same time, I'd love it if someday the Veiled apps that are produced for most people are just sort of indistinguishable from any other app. They're just simple, easy to use, one click. They shouldn't have to become privacy experts to just be able to trust what we're building.
Privacy should be the baseline.
And if we want to wonder what's the future of Veiled Foundation down the line, we really hope that Veiled Foundation can serve as a governing body that also helps promote and judge applications we feel are holding up a privacy banner the right way. Not everybody in a peer-to-peer network is bound by the same ethical standards that maybe the founders of Veiled are. We'd love to think that people are only going to use this for good, but it would be good if we extended the Veiled Foundation mission into highlighting apps that are doing a great job of managing the privacy and being an opportunity for trust. How do you trust applications that are just built by whoever? So over time, we hope to take on a role in terms of really judging how Veiled apps are how private they are.
Mm-hmm. So you can find us online at all of these places. We are on the web. There's our website. We are on Twitter while it is still existing. I'm shocked, honestly, that we still have that on the slide, 9 months later. I did not expect that.
We're not a blue check. We're not going to be a blue check.
Yeah, we're not a blue check. We are on Mastodon. Veiled Network, we have the Discord until we can build a better Discord. We are there for now, though, and everyone is welcome to join. And the entire theme of the Discord, I see there's kids in here, so I don't know, plug your ears for a second, but our whole thing was we are encouraging everybody to come in, play around, buck around, and find out. Yeah. That is a scientific method. That is how we learn. Say you have never tried marketing, you've never tried, writing Rust, you've never tried Flutter, come in. Yeah. Lots of people want to teach you how to do it, and you got nothing to lose except your time. That's it.
Yeah. Help us out. Help yourself.
And if you like to go through the code, check out everything that has been built, see how it's been built. Dill has really made its fantastically glorious architecture right there, and it's on the GitLab.
It builds anyway, yeah.
It is.
It's pretty good. I actually started learning Rust because I wanted to build this, and it's gone through a lot of iteration to get to the point where it's at. I think it's a pretty good example of how to write really solid cross-platform Rust. So.
And as we said, very soon we will be opening up the beta for Veiled Chat. It would be open already, except I was worried about him burning out, so I introduced him to this thing called Stardew Valley.
Yeah.
And
So I've
all-
been making like little vegetable farm for quite a while now. So
Yeah.
sorry, folks. Priorities here.
yeah,
I know you all
that's
want to
on me.
overthrow data capitalism, but I'm freaking selling onions or whatever it was. Yeah.
Yeah. So
Anyway,
it will be available soon.
yeah, it's coming.
So anyway, I am really thankful to be here. I am happy that all of you came out to hear this, and I hope you walk away with some really fun ideas and, understand that you are welcome to come join us, and hopefully we can all hack the planet together.
Thank you.
Was it okay to mention Stardew Valley?
Oh, yeah, it's very humanizing. I appreciate it.
I try to interject somebody's stuff. You bet. Thank you.
Yes, remember the Web 1.0 generation.
Yeah, so
So I appreciate you bringing that up.
thanks. Yeah, no, I don't like the way the internet is heading. I'd like to definitely see it get back to the roots of what it was supposed to be.
You're probably not old enough to remember Stuart Brand well.
I do remember it well.
I was a member of that.
Oh, wow, cool.
And that was so exciting. Just exactly what
Cool.
We have an opportunity to do things a little differently now, so let's capitalize on that and make it happen. Thank you. Nice to meet you.
Nice to meet you. And bring out stickers. Everyone wants stickers, right? Yeah.
Sticker economy here. Yeah, right.
Oh my gosh, yes, I do. Yeah, no, I actually, I got plans for him, but as of right now, he's in the back window of my car, and people take pictures of him when they park behind.
Our roadmap is more of a technical roadmap, but it is available on GitLab. You have to know a little bit about GitLab. It has a organization level epics. If you go to the epics, the projects, not for the repository, but for the organization. If you look at the epics, you can see what we're building and what the next steps are. So that's more of the technical side. In general, though, you got Valid Core, which is like how everything talks. But then we're also building, and this is like, I'm gonna backport it out of Valid Chat when I'm done or debug it. But I'm gonna be taking the Valid support library package out of the Dart code, moving it into Rust and writing bindings for it. That will become a Valid standard library. We're gonna do that. So I don't want to encourage people to copy and paste my shit until I'm happy with it. But once Valid Chat is out and sufficiently scaled to prove that these are things that I feel comfortable sharing and saying I don't want to write code using this because it works, it's been proven to work. We'll factor that out into the library. It's going to accelerate a lot of development. They won't have to write certain kinds of data structures and how this is working with distributed system. They don't have to think about that stuff at all. It'll just be a little bit more easy. So we're just trying, we're trying to make this so that people are just used to having a database or something. You have to eventually use a Valid-enabled DHT-backed, Rockstore-backed database. They're not thinking about it. Just writing queries, they know they just work and automatically synchronize stuff. But down the line, you're not going to be thinking about building distributed systems as much. You're just going to be trusting that people have built their libraries using the right code, that it has certain guarantees. That's really what this is about. It's sort of like an operating system. What Linux did for OSs is sort of what we're doing the same. We're doing this for apps and distributed systems. So really, it's that kind of core that we're building. Hopefully, the world builds on top of it. Yeah, well, thank you.
Wasn't really
Yeah.
but might have been addressed already, but like sharing this code, like say through third party messaging. So that's like Twitter, like say like one-to-one.
Yeah.
I could trust this I would have first in-person thing, PR for the VIP. So recognizing being could, say, represent like bad actors.
Here's how the attack would work. What's in the invite code is a decryption key and a public, it's a DHT record. So somewhere on the internet is a DHT record that is accessible to the person who made it, and with that decryption key, whoever you hand the password to. Right, invitee. So that is a one-time operation, sort of like exchanging an SSH key. So you know how like there's a public key in both ends and it does a DH? Well, that's your identity key that you've generated when you made your account. We do a DH dance through that DHT record. It's a one-time operation, and now you've got a synchronized conversation. Now, for that to be man in the middle of some other means of this sort, they would have to have a very small window of time. They would have to rewrite the QR code or the paste somehow, like you'd see it change. You know, they have to man in the middle of that. They still wouldn't be able to really do it because the conversation comes back. They would have to be like pretending to be the other party. They don't know their public key. You know, they don't know who you handed it to, so they can't man in the middle of a party that they don't know the other end. The thing about the public key DH man in the middle is that you have to know the public key of both ends to do it. Right? Because you have to create a third key there in the middle. That's like a third and fourth one. That's yours, right? That means you have to know the other person's public key. That means you have to know who's being man in the middle to begin with. If you don't know that, because you don't have access to their iPhone over there, there's no attack that's possible. Someone's going to fail the signature verification on the exchange. So it's just not really, like, it's not possible unless somebody owns one end already. In which case, they're fucked anyway, right? There's all kinds of scenarios where it's all sort of chicken and the egg. I don't see a practical attack in the Village chat in my system. So, I mean, it's the attack, which is kind of thwarted by the out-of-band pin, is somebody does a QR code and then like puts their phone down and lets somebody else scan that QR code. You can't at that point attest who scanned it. But if you had a pin, you'd have to have that pin or a password. If they scanned it, they'd have to know that to decrypt the encryption key. So that can be done out of band too. So what if you did want to post a QR code publicly and just tell the person with the iMessage, you know, it's still yet another place that would have to be made of it. It's really practically impossible to do it. I mean, even with like a nation state, they'd have to be really lucky, you know? And they'd have to know exactly who they were attacking, you know? And I don't know. I can't imagine it ever being a practical attack. So, yeah. So anyway, once that's built, and Village Chat has built this network of people that can talk to each other, I would love to also sort of standardize that invitation mechanism and identity system so that other apps piggyback on the Village Chat contacts that you've made. You can say, okay, I want to use that same identity for the social network or for the video game, and be able to leverage that same chat system identity everywhere. So the question of does Village have a blessed identity system? Not yet, but we're getting there. And Village Chat is sort of our proving ground for that. So it's pretty fun. Do you? Awesome. Sweet. I knew that we had done a bunch of work for FreeBSD, and I have a feeling that it probably just kind of got like BSDized enough then. Did you actually change the code to make it work? Okay, cool. Yep. Oh yeah, the Village tools. Yeah, yep. Make a PR. Set the PR. Yeah. Nobody has done officially an OpenBSD support for it. So if you have a patch that would help us compile it, I'll accept it. Absolutely, yeah. I did break it down so that all platform-specific stuff is There's on Discord. We're there, and there's two sections of the Discord. One is like tech shit, the other is like human shit. It would be a great topic for human general, and then all the people that like we want to talk about like verification or app validation or whatever, we'll have other people join in and probably make a channel for that.
Yeah, it's like if you post something like, what if some card like updates terribly?
Sure. Well, what is the process for ongoing verification? Someday there needs to be some kind of entity that says we're looking at apps, and if you're going to get the valid seal, I don't know what you call it. What does that mean?
That's why I was like so stuck last night.
I want to get there, you know. So
This is so cool.
yeah, by all means, get in the Discord and help us think about it.
Yeah, it's easy.
Sweet.
You're the best.
All right.
Also, if you're at least like
I am. Yeah.
It's like Merit's also super fun.
Yeah, I love Merit. We knew each other from Twitter, and then we both like independently discovered we were at Lacework. She joined from AWS.
Yeah.
You know, and I've been at Lacework for about 2 years now. So
What are you having to
There's
do
3
for
medices before me.
I write AppSec tooling for Lacework. I'm in charge of their code security efforts. So, you know how I used to be at Veracode writing static analyzers? I'm like writing cloud-enabled static analysis stuff for Lacework. Well, I'm at least telling people how to write it and being like, you know, the
It's
engineer.
a cool baseline for understanding how you even not rely on software.
Well, it's a little bit weird that I work for a cloud security company whose bread and butter is cloud apps, and then I'm like writing the anti-cloud in my spare time. But you know what? Whatever. So I'm better than you.
Who better than you, man? Come on.
But no, honestly, not everything needs to be in the fucking cloud. You know, we wouldn't need as much cloud security if like they didn't have the data to begin with.
I wish people didn't think it was like cumulonimbus clouds holding their data. Like I really wish people understood that it was like server farms and shit.
Yeah. And people are fucking with that shit all the time, and it's changing.
So yeah.
Lacework's all about observability, so
Yeah.
we know how this shit can go wrong, you know?
Which is why it's really fun to talk to y'all.
I was like, can we step out of the...
your name?
My name's Tim.
Tim. I'm
Lydianne.
Lillian. Lovely to meet you both. I'm Naomi. Yes. I do. Yeah, it's all about privacy and how the people at this conference can make a big impact. So hopefully I can get a rallying cry. Yeah.
All right. And I'm Randy, by the way. Nice to
Lovely
meet
to
you.
meet you, Randy.
And what's the audio thing I want to have?
So I've got,
Please look at it, and then I can know what I know.
so it's an XLR plug and I have the adapter.
You got some serious kid here.
Yeah, so it would just be XLR into here. And I've got an XLR if you need it.
Okay. And is this just a recorder?
Exactly, yeah.
Okay. So,
And it's not going to put too much malware on your system, so don't even worry about
you
that.
sure?
Yeah, I mean, a tiny little bit.
I'm not aware of any XLR malware exploits, but you know.
Listen, I'm very advanced, so.
You are. And I now know that you're not allowed in my studio. Your band.
Whatever.
Well, 10 years.
10 years. That's pretty reasonable. Thank you so much.
I'm lenient for the first
You're
time.
very, very kind.
I'm willing to give people second chances.
I appreciate
See what I
that.
can do. No promises here.
Okay. Oh, this is already on. Got like a pre-show. Discord. When?
Whenever you could.
Sounds great. Okay. Yeah, I don't have it on this computer, so it'll be when I get finished traveling.
Okay. Would you rather email? Is that easier?
Signal or email is great. About just general connection?
Yeah.
Okay, super.
Connection, questions, mentoring.
Amazing. Yeah, yeah, yeah. Email or signal are great.
I'm getting a few people involved on making sure all your entire setup.
Yeah, yeah. I mean, it's not much of a setup. It's my little travel thing. I got a white phone. I always like to have secondary audio vision.
So Jamie is supposed to have a laptop. I'm trying to find Jamie right now. But
Jamie's missing.
yeah, Jamie's missing. So
This is bad news.
and then so supposedly
I mean, it's not a huge deal. I had the slides there, but I just won't be able to have it on the same system because I'll be using that computer for other things. So I won't be able to like split the screen to do both, which is why she offered.
Okay.
Yeah.
All right. Yeah, I'll send her over here when you find her.
Sounds good.
That's
Smarter people than
smarter than people in me is a pretty low bar, so just about everybody includes just about everybody.
Do you get your napkins sorted?
I got the napkin sorted.
That's really great news.
Love that very British way of saying it, though. Sorted.
Actually, Australian, but
Australian.
heavily influenced by
I
British.
can hear it now. Okay,
Yeah.
my hearing's not great
Yeah, it's
today.
that like
been raining
nasal
all day.
twang. It's like ugly British. That's what Australian is.
No, I like it. So, got notified AV about your little box there. He drooled over your box too, so we're gonna play Rochambeau for who gets to keep it.
Oh, cool. That's
3 out
so
of 5.
awesome.
I'll invite you since it is yours, so
Yeah.
we'll give you a chance to win it back.
You are beyond generous. I cannot thank you enough.
It's the way we roll around here. Right?
Yeah, just giving me a chance to win back my own things. I'm speechless. I'm speechless.
Welcome to America.
Yeah, thank you.
Sometimes let you keep your own things.
Sometimes, not often. Why should I do this? It's not going to be any use.
privacy. And from 2013 to 2015, she worked as a policy associate at the New York Bitcoin Center. She's also been a producer for several award-winning documentaries in technology, and she is going to tell us all how to reclaim our privacy in the age of big hacktar. Let's welcome Naomi.
Good afternoon, everyone. It's wonderful to be here. So my name is Naomi Brockwell. I make educational videos to help people reclaim their privacy online. And I'm really excited to be here at CactusCon. So I just love this year's theme. The tagline is so good. The year is 2024. Surveillance is privacy. Submission is liberation. Control is freedom. And it's just so relevant in today's age. So the reference obviously comes from George Orwell's 1984. It's a classic novel, and the world of Big Brother, which is a symbol of excessive surveillance and control, I think is really important to just kind of keep in mind during today's talk. So I have to admit that the CactusCon spin-off of this theme is a lot more fun, and I've been really enjoying the posters and will be entering that raffle. So let's start off just by talking about 1984, because that's a good segue. 1984 is a riveting story, and it shows us how a world stripped of privacy can shift the balance of power really far away from the individual, and it shows us how scary this can be. But sometimes literature can be so dramatic and excessive that it seems really hard to relate to it. And oh, that Big Brother is watching. Oh gosh. They're on to us, everyone. So, literature can be sometimes so dramatic that it's hard to relate to it because we fail to recognize the similarities between this author's made-up world and our own lives. And indeed, 1984 takes these ideas to the extreme. There's a giant face that is glaring down at people everywhere they go. And citizens gather in big halls to scream hateful words at a screen as part of their daily activities. And that's not something that we do, except maybe at election time. But my point is that there's this dramatic flair to 1984. And so we might be tempted to dismiss its lessons as pure fiction. But underneath this exaggerated dystopian world that Orwell created, there are some profound lessons about the psychological effects of pervasive surveillance. And I wanted to go into that in today's talk, because I think these lessons are extremely relevant to modern society. There's that big face there. And before I dive into that, I first want to get a sense of the audience. So who here thinks that privacy is important? All right, almost everyone. Noting down the thought crimes of all of you who didn't put your hand up. Who thinks privacy is dead? Yeah. And who here thinks that we could possibly still save it? All right, that's not bad. That's actually more than I was expecting. All right, let's flip it. Who here thinks that we cannot salvage privacy? All right. So my job today in today's talk is to try and sell you a white pill, because there are a lot of black pills in this audience, but I do want to let you know that you are more empowered than you realize. So, and I also just want to mention that I think we have to change course because what's at stake is so important. So it is going to be an uphill battle, and I know that it's not easy, so I am kind of on the side of everyone here who's like, no, we cannot be saving privacy because it is a giant undertaking, and I get that. We're changing culture, we're fighting inertia, we're staying at the cutting edge of technology and technological advancement. Not to mention all the costs of this, right? If you run a business, it costs money, it costs time, it costs resources to integrate privacy measures into your platform. If you're a user, there are convenience costs to choosing privacy. But there are also costs to continuing on our current trajectory of diminishing privacy, and we need to understand that. So it's those costs that I want to focus on in this talk today. So first I'm going to look at the current state of privacy. And I mean, it's not as brutal or harsh as Orwell's 1984, but surveillance today is just as pervasive. And it doesn't matter how palatable or even enjoyable that we've made this surveillance, because we're most of the time opting into it, right? We click that little, yeah, I agree button, and we get free products, and we kind of like it. It seems like a pretty good trade-off to us. But the effects of this surveillance on the fabric of society is just as profound as in something like 1984, and that's worth exploring. And on top of that, we need to make sure that we're fully aware of the consequences of creating a world without privacy. So I want to make sure that we take stock of the kind of future that we're enabling and what's at stake, to make sure that we are fully aware of the choices that we are making. And then I want to talk about how everyone in this room can help make sure that the future we create is the best possible timeline, not the worst. Like the people who attend this conference, you are not your regular and passive enjoyer of technology. You have a say in the direction that this technology will take. You guys are helping write its future because you are involved in this industry. So let's be intentional. So let's be intentional about the kind of future that we want. And I just want to start off with a disclaimer as well. So I am not someone who wants to make people start sacrificing modern conveniences of modern life in order to salvage privacy. That's not me at all. When we start talking about privacy, so many people do resort to these straw men, and they tell us that, oh, if we want privacy, throw out your digital devices, or you care about privacy, okay, stop using the internet. And I mean, that solution is just not good enough. It's not, and like probably all the people in this room, I'm a technophile. I adore the internet, and I'm always trying out the latest gadgets. So suggesting that people give up technology is just not a reasonable answer. And it's also incredibly outdated. So it's 2024, the technological possibilities around us are incredible. And if we want to reclaim privacy in the digital age, the answer is not to throw out our devices, it's to truly embrace technology and to leverage all of the new cutting-edge privacy and encryption technologies that are being developed every single day. So it's up to the technophiles at conferences like these to push these privacy tools forward, not just in their development, but in spreading awareness about their existence. You guys are all perfectly poised for this. So let's get into the first section, taking stock of the current state of privacy. Things are intense, and I want you to understand how intense. Pervasive surveillance is a part of our normalized everyday experience. And we don't have like literal telescreens in every room as this ominous reminder that Big Brother is watching our every move. The surveillance in our life is more subtle. And it comes from a mix of companies and governments, and it just kind of fades into the background for most of us. We have devices like Amazon's Alexa and Google's Home constantly listening to our conversations, and we put them in intimate places like our living room and our bedroom. What are we doing? We have major services like Google, Microsoft, Facebook, Amazon, Zoom, Adobe, the list goes on, that all harvest significant user data and share it with thousands of entities. And a lot of people don't even really look into that and how many people are getting this data. Cars these days, they monitor everything we do. It's kind of insane. And people are only just waking up to how many entities this data is shared with. Did you know your insurance company gets data about how you drive? Yeah, it's insane. It's really crazy, depending on which car you drive, obviously. We have comprehensive video coverage of suburban areas thanks to doorbells that we point directly at our neighbor's house across the way, and we point them at public streets, and they also capture audio of people's conversations as they pass by on the sidewalk, or audio of what you're saying in your living room, because they do reach that far. And when there aren't home cameras, there's CCTV, there's facial recognition software, there's tracking via BLE, Wi-Fi beaconing, RFID, and IoT devices have introduced a cascade of unintended data sharing. Devices often continue to share networks and transmit data even when users think that they're isolated. So that's worrying. And then in our pockets. Everywhere we go, we carry cameras, microphones, GPS, you name it. Our phones can tell whom we meet. They can infer what we're doing. They hear what we say. They track not just location, but our online activities. So what we click, what we read, our health data, our financial choices. Then there are the data brokers. These are the digital pack rats of the internet that are hoarding any scrap of all of this that they can find, and they're selling it to others. And we have no control over who gets access to this data. And some of the largest clients of data brokers are actually governments around the world. But governments also have other ways to collect our information. So let's go into that, because I want to make it really intense and black pill before I tell you how empowered we are. Remember that? That we're empowered? All right, good. So let's keep going with the surveillance. In the US, we got a glimpse a decade ago at some of the intelligence programs used to intercept data due to the Snowden revelations. So things like PRISM, which gives government agencies access to servers of major tech companies. There are programs like Tempest, Turbulence, Turmoil. There are indexing and search systems like XKeyscore. In the UK, they have programs like Tempora, which is a full-take data collection program, and all traffic entering and leaving servers in the UK is collected. We can presume that we will never know about most intelligence programs or about the data sharing agreements and reciprocal relationships that exist between different governments. Although I'll take a guess that there are probably some people in this room who do know more than others. There are also systematic data collection programs like census data or KYC, mandatory reporting for everything that touches financial payment rails. And we like to think of data collection from private companies as distinct from government entities. But in the modern age, they are inextricably linked. Before the internet, businesses could only collect a very limited amount of data from people. You know, you'd go to your local video rental store and you'd give them your name and telephone number. It'd be stored on their local system. They're not connected to the internet, so it's not going anywhere. It's just sitting there. You know, if the government wanted that data, they had to get a subpoena for that specific store to get all that information. Nowadays, businesses collect a constant stream of data about you, and they store it in centralized servers, and you have no reasonable expectation of privacy for any of this information if it's handed over to such a third party. And this basically gives companies carte blanche to share that information as they choose, even with law enforcement without a warrant if they want to, thanks to the third party doctrine. And on top of that, many companies deliberately obscure the specifics of their data collection practices. So they're leaving users in the dark because if users knew the extent of data being collected about them, they might not want to use the product. So the situation as it currently stands is we hand over the intimate details of our lives, sometimes voluntarily, sometimes without explicit understanding of all our actions, and sometimes against our will. And there's a free-for-all with all of this data as companies are breached and it ends up on the dark web, or it's purchased, or it's siphoned in bulk from various governments around the world. Gosh, let's take stock of all of that. So who's here said that privacy is dead? Yeah, okay, yeah, it does seem like that when you kind of just start to look at the specifics. You may be onto something here, but remember I did already acknowledge that this would be an uphill battle. So let's keep going and let's move on to what's at stake here if we don't start to push back against the current trajectory. Pervasive surveillance. Even when it seems non-threatening and comes from the rudimentary tech in our lives, has two big consequences that I want to dive into. First, it shifts the power away from individuals to centralized entities, and it potentially jeopardizes future freedoms. And second, constant surveillance has deep psychological effects on society. So let's start with the first implication, that constant surveillance potentially puts our future freedom in danger. Now, many people in this room, you're probably comfortable to be here in the USA. You probably think that this is not a risk worth worrying about. Who here is not that worried? Who's here is like, no one puts their hand up. This is my kind of crowd, or you're all terrified. Either way, I can work with that. So a lot of people, even if they're not in this room, a lot of people are just trusting that companies are going to do the right thing. They're going to trust their government. They're going to say, well, I like my government, or at least I like the system that's in place that lets me elect a new government if I don't like the current one. You know, I think everything's set up pretty well. I don't need to worry. So let's, for argument's sake, let's not worry about the USA for the time being. Let's just zoom out and we'll focus on authoritarian regimes that use surveillance as a tool of oppression, that most people would say, yeah, that's an authoritarian regime. So in North Korea, constant monitoring gives the regime an iron grip on its citizens, and it's ubiquitous. In China, a social credit system converges things like financial habits, daily activities, and social graph into centralized metrics that determine whether your children can attend certain schools, whether you're allowed to travel, whether you're allowed to leave your hometown, if you've been well behaved enough to use the fast train, or if you're allowed to book hotel rooms. It gets pretty scary. In Nigeria, the introduction of a CBDC, or programmable government money, allows lives to be monitored and controlled through financial choices. So it puts the Nigerian government at the center of every transaction so that money can be more easily tracked, frozen, seized, even programmed to be erased if certain spending conditions aren't met. So by looking around the world, we do get a sense of how pervasive surveillance has the potential to be weaponized, at least. So now let's go back to the USA, or Australia, or Switzerland, or insert whatever your favorite country is that you really like and you think it's free and you think there's no risk of anything bad happening. And it doesn't matter if it's old. And it had this strong protest culture, but this law resulted in the immediate suppression of speech, particularly of political expression, and led to the arrest of pro-democracy activists, the disbandment of political opposition parties, and the closure of independent media outlets. And it happened so quickly. The Iranian Revolution in 1979 led to the establishment of an Islamic republic with a rapid change in societal norms and personal freedoms, all within a single year. And women, in particular, lost many of their rights. The construction of the Berlin Wall, 1961, separated East Berlin from West Berlin overnight, and it resulted in the immediate loss of freedom for over 1 million people, including freedom to travel, speech, assembly, association, economic activity. And those trapped in East Berlin had to endure this situation for 28 years. So the dangers of data permanence in a world where societal norms and laws are constantly changing is a real threat, because this data might be used by any government or entity in the future for any reason of their choosing. And we should keep in mind the surveillance asymmetry of modern digital era. There is a great video by Slovenian political scientist Samo Borja where he explains how the internet has made us far more visible to governments and large corporations, but it has not made governments and large corporations more visible to us. And this information asymmetry is crucial for control. When corporations and governments collect large amounts of data about us, it inherently creates a power imbalance. And at their core, governments and organizations are made up of people. The resulting concentration of power risks being misused by individuals within these entities against those in more vulnerable positions. And we already see examples of this imbalance of power being abused by individuals, where the surveillance put into the back doors of our lives can harm people just as much as it's trying to protect people. So, instances like the officer in Kentucky who used his insider access to law enforcement backdoors to hack people's Snapchat accounts and extort women with nude photos. Or intelligence workers who use their privileged access of surveillance tools to spy on romantic interests. It's apparently common enough that the term love-int was coined to describe it. And now maybe these cases are few and far between, and overwhelmingly in free countries, data isn't being weaponized. And let's again, for argument's sake, let's just presume that this is the case. As the builders in this room envision and create innovative tools built upon the internet, we need to think hard about the future that we're enabling. And relying on hope that the wrong individuals won't access our systems is not a robust safety strategy. Likewise, we can't just hope that data we're collecting remains benign while legal landscapes and societal norms keep changing around us. Instead, it is essential that we focus on fortifying what we build to safeguard the balance of power and protect individual freedoms. So now I want to explore the psychological effects of pervasive surveillance. And while these effects might be less overt than the other risks we've discussed, they're no less significant. There are popular archetypal examples of pervasive surveillance that we can look at to help illustrate the deep impact that it has on society. So Orwell's 1984, wonderful example there. And it paints this chilling picture of a world drowning in fear and paranoia, and citizens are always under the threat of surveillance from these telescreens and from ThinkPol, and they risk punishment for any unorthodox beliefs or sentiments. But there is another illustrative model that we can look to, the panopticon. And how it works is there's this circular prison with this central watchtower, and there's only one guard. And he can't possibly watch everyone all at once, but the prisoners have no idea whom he is watching. So it gives them this feeling of constant surveillance, and so the prisoners start to regulate their own behavior, just in case the guard happens to be watching. Now, putting aside, again, the dramatic flair of these two symbols, both 1984 and the Panopticon underscore the profound power of ever-present surveillance in molding human behavior. Most of us have an instinctive understanding about the surveillance and data collection around us. Even if we can't explicitly detail the extent or the methods of this monitoring, its ever-presence creates crucial changes in behavior. First, and probably most obviously, constant surveillance creates a chilling effect, stifling of free speech, thought, and action due to fear of retribution. When people feel like they're being watched or monitored, they're less likely to express their opinions or engage in activism, especially if it's controversial or against mainstream opinion. Without private communication, agitation and pushback against authoritarianism becomes impossible. As privacy advocate Juan Angel put in his essay, Privacy, the Hill to Die On, life in the panopticon of absolute digital surveillance forces humans to become shells of themselves, subjects who self-censor their own thoughts, behaviors, and expressions, even in private interactions. But along with internet surveillance and collection of our data, a fundamental shift has happened to do with the permanency of our actions. Our interactions with people, they used to be largely ephemeral. We'd see people in person, we'd wave hi, that moment's lost forever in time. Our conversations, our mistakes, our private moments were mostly fleeting. And they were remembered only by those present, and often they were altered by the passage of time or the fallibility of memory. But now in the digital age, a digital specter follows us around. Our every utterance, every search, every like or share has the potential to be catalogued, analyzed, and remembered. And this takes the ephemeral and it makes it last forever. In pre-internet times, people could grow, they could evolve, and they could even reinvent themselves over the years. Mistakes or beliefs from our past did not necessarily haunt us for life. But with every action, statement, and thought being collected and recorded in the digital age, it becomes more difficult for individuals to evolve beyond their past. The consequences of our past opinions and beliefs, etched permanently online, creates giant problems. It gives rise to this permanent self instead of us being living, breathing narrative shaped in real time. And when we say that things when things we say become permanent, there's a tendency to become defensive about them instead of being open-minded. Admitting to change in our beliefs might seem like a weakness in the face of ever-present digital history, and knowing that our actions are constantly monitored and recorded can make us refrain from exploring new ideas or questioning the status quo because we fear potential repercussions or judgment based on our digital trail. With every digital action being scrutinized, there's a subtle push towards conformity. It becomes safer to follow the herd than to stand out or challenge prevailing norms, and this leads to a society that values uniformity over individual thought. This newfound digital shadow haunts us. Instead of spontaneous expressions or genuine searches for knowledge, we might lean towards actions that look better in our digital profile. There is this subtle internalization that our digital self is in some way more important than our real self. In a world like this, authenticity becomes scarce, replaced by curated personalities for digital consumption. And these are profound shifts in the collective psyche of society that we need to be aware of. And I think they're important enough that we should start pushing back against normalizing the surveillance of our innermost worlds. So let's recap where we've come so far. In the modern digital world, we're under constant surveillance. We know that. This affects us psychologically in subtle but profound ways. Constant surveillance also has the potential to threaten our free society because laws change, social norms change, but data collected about us is forever. And we don't know how this data will be used in the future. So with all of this in mind, we can no longer afford to keep ignoring the importance of privacy in our lives. The internet may have started without keeping privacy in mind, but it should not continue that way. So, how do we actually protect our privacy better in the digital age? So this is the final part of the talk that I want to focus on. And the people in this room are the developers and contributors building the future of the internet. So you're part of companies and projects that facilitate the online activities of countless people. And it's all of you who in large part get to determine how much surveillance is able to take place. So the mass surveillance of today, it largely depends on individuals freely giving over their data to companies and not realizing that they're giving over their data to companies. So people naturally think, okay, so individuals need to be convinced to stop doing that. Let's just reach up to 7 billion people. We'll get all of them to change their mind. But rather than trying to shift the behavior of billions of people, it's far more impactful for those building the tools of the internet to start prioritizing privacy instead. So after the 2013 Snowden revelations highlighted vulnerabilities in data transmission and the extent of government surveillance that was going on, a tremendous shift happened in the internet at that time. But it did not come from individuals reading these reports and changing their habits, nor really from the adoption of better laws. It was the tech industry's response that completely changed the landscape of digital privacy. So internet traffic, although already on a trajectory towards greater encryption, experienced an accelerated shift from being around 30% encrypted in transit pre-Snowden to an estimated 80% encrypted in transit just a few years later. And major companies like Google and Apple intensified the call for robust encryption, and they were the ones who led the way for a huge uptick in the adoption of encryption protocols. When WhatsApp added end-to-end encryption to their messaging app, they turned on privacy for 1 billion people. The impact of this was huge. It was builders of internet tooling and services who created privacy shields for billions of users. And every builder in this room can make an impact by being mindful of privacy when coming up with policies, architectural designs, and implementations of all the technology that they're developing. And again, there are obvious costs to integrating privacy-minded changes into our work. But we have to realize that there are also costs to not doing so. So what kinds of changes might you think about? What might be helpful? Well, first, there's the collection side of things, right? Companies right now intentionally collect a lot of data about users. They store logs, they attach information to account profiles that include all kinds of data points about user interaction. The reason it's collected is because they can gain insight from the data. This can help them provide better services. And they also collect it because money can be made from this data. But they're focused only on the benefits of data collection, and not realizing that this data collection is actually a huge liability. So companies are notoriously bad at protecting data. John Chambers, the former CEO of Cisco, once said there are 2 types of companies: those that have been hacked and those who don't yet know they have been hacked. So user data is leaked all the time in data breaches. And it's not just hackers that we have to be mindful of. Companies might decide down the line that they want to start selling the data that they've been collected to data brokers, and you'll have no control at all over this decision. Or it might be demanded by governments that seek to do harm to someone. Again, you'll have no control. You may have implemented or set up a system that collects that data in the first place. You're not going to be able to control what happens to that data down the line. So there's an assumption that many companies should just by default collect any data available. But many are increasingly realizing that it is irresponsible to collect data that they can't adequately protect. And so they're adopting a data minimization approach, where they consciously don't collect unnecessary data. So pushing for a culture at your company where only data that is needed is collected and nothing more can make a huge impact on the lived privacy of countless people. Next, let's talk encryption. If you do collect data, is that data being stored securely? At the most basic end is the data stored in clear text, and it seems ridiculous to mention that in 2024, but remember that Equifax stored the passwords and social security numbers and sensitive information of 150 million people in clear text. That's insane. But presuming that all data being amassed is encrypted, is it securely implemented? And who has access to the decryption keys? Can any employee at the company get access to this data? Protecting user data extends beyond merely preventing external breaches. It's also about managing internal access. Allowing unrestricted internal access to user data or being at all lax about this creates multiple points of failure because every employee with access becomes a potential vector for data leaks, whether inadvertently or through malicious intent. Access to user data, no matter how benign that data seems, should follow the basic principle of least privilege. So as few people as necessary should ever be able to access this consumer data. So if you're in a position to make sure that user data is being protected the best way possible, again, that's somewhere where you can make a huge difference. And there are tools for anonymization and pseudonymization, disguising data to protect identity. This is tremendously powerful if you do have that data that you need to store. Exploring how you might use such methods in your work allows you to utilize valuable data sets for analysis and innovation without compromising individual privacy. And then we get to the really exciting territory with the real-world applications of homomorphic encryption that are starting to be explored. So the promise behind homomorphic encryption is that we can do computations on encrypted data without first needing to decrypt it. And this is groundbreaking for privacy. It allows services to provide all kinds of tools for users without ever seeing the data in its raw, unencrypted form. Users can store encrypted data in the cloud, run computations on it directly without ever having to decrypt it, which would ensure that data remains private even if a cloud provider is compromised. Patients' medical data can be encrypted and used in research computations without ever exposing individual medical records. There are applications in banks and financial institutions, private voting systems, secure data marketplaces, machine learning, especially when training with sensitive data. There are so many ways that this will revolutionize the privacy landscape, but none of this is really a reality yet. Homomorphic encryption is computationally intensive, and it can be slower than traditional methods. We've moved past the purely theoretical stage of this technology, but real-world applications are still limited, with just a few early-stage deployments of proof of concepts emerging. So another thing that privacy-conscious people can push for is continued research into this area. If you're at a company that might be able to support that work, maybe this is something you could look into. Having more people working on this encryption technology can steamroll it from its current developmental phase into something used in everyday applications. Next, many companies keep users as uninformed as possible about what kind of data is collected from them and how it's used, when it's shared, how securely it's stored. And this is often by design. Too often, privacy policies are written as a form of liability insurance instead of educating users. Explanations are hidden behind 60 pages of legalese instead of being clearly explained in a way that users can actually understand. And I think there's an ethical responsibility to users to make sure the policies are clear about when data is collected. So it's important that people really understand what agreements they're entering into and that companies respect their users enough to allow them to make informed decisions about whether they want to use certain products or services. So if you can help shift culture around privacy to one where users are more informed about the practices going on, that would make a huge impact on the privacy trajectory. You can also shift culture by looking at the internal practices of your organization. By adopting more private communication methods, developers can reinforce a culture where privacy is a paramount concern. By supporting privacy-focused platforms and open source privacy tools, we can support the work that is currently being done to protect privacy. And we can also send a regarding our digital future. Ourselves feel that maybe we're not in a vulnerable position. We can help the most vulnerable people in our societies who do rely on these privacy tools to stay safe. So making that switch is actually more important than you may realize. And all of this importantly fosters an environment where privacy is the norm rather than the exception, which helps maintain privacy awareness and commitment among peers. And I think that's one of the most crucial steps that we can take. So every time I attend a hacker conference, I feel like I am amidst the vanguard of digital innovation, because the people here understand that the internet is as much a beacon of enlightenment as it is a potential tool for surveillance. And we just simply can't ignore the dual nature of the internet any longer, or rely on people's goodwill to not abuse this surveillance. That is not a robust measure for safeguarding our digital future. As we navigate through an internet brimming with personal data, the innovators here hold an extraordinary power. The power to embed privacy into the very fabric of the platforms that you are creating. The fact that a single company can give billions of people access to private communications with the flip of a switch is a testament to how all of us can make a difference. So what switches can you flip at the places where you work? And there's also the cultural impact. We have the ability to push back against complacency. Let's empower people to create positive change, and let's stop normalizing pervasive surveillance. So the people in this room are uniquely positioned to play a huge role in the direction that our digital future will take. And every line of code, every infrastructure choice, every innovation can not only push the boundaries of what's technologically possible, but can also uphold the fundamental right to privacy for billions of people across the globe. So as we craft the web's future, let's not just innovate, let's protect. Every decision that we make can be a step towards a more private, safer internet for all. Thank you so much. We've got time for questions. I don't think there's a microphone, but you're welcome to stand and shout at me because I'm used to people doing that, so. Anyone? Question? Yeah, let's do it.
So one of the things you didn't touch upon is the voluntary giving up huge amounts.
Yeah. I think that that's important. I mainly focused on what like developers can do in changing infrastructure, in changing systems that billions of people use. But there is a whole other side that this gentleman focused on, which is the user side. And overwhelmingly, people voluntarily give up their data. You know, how many people, like, put your hand up if you use Gmail. Yeah, I know some of you are afraid to put your hand up. I'm watching you. Yeah, so, I mean, we again, it's 2024. We just don't need to be using a service that literally in its privacy policy says that it is analyzing every single email that we send to someone, every single document we put in the cloud, every single, you know, every aspect of their services is analyzed, and it's used to build this profile, because ultimately companies like Google are advertising companies. You are not their customer, you are their product. Their customers are advertising companies, and so they're packaging you up through all of this data you're voluntarily feeding them. So I think on an individual level, just making the switch from tools like Gmail to, I don't know, pick a private email of choice. There's so many. You've got ProtonMail, Tutanota. Find something that will end-to-end encrypt emails between users on a platform. They will store it with zero-access encryption, encrypted with your private key so that even they can't get access to the contents of that email. Just make that switch. The good thing about GDPR, I know it's like this strange privacy rule that's arbitrarily enforced a lot of the time, but one thing to come out of it is that Google was forced to expose a lot of APIs to the public. And the result of that is you can literally go into ProtonMail, click one button that says import your entire email contacts, and you can switch your entire email over to a private provider that's going to respect you as a user. That seems like a really easy thing people can immediately be doing. So if you want to do one thing as a takeaway leaving this talk, maybe just do that. They also have encrypted calendars. How much data is revealed about us for our calendar, from our complete history of where we've ever been, the people that we've connected with? We have their contacts written in there. Google's getting all of that and mapping all of these social graphs accordingly. So use an encrypted calendar. Again, Proton has a great encrypted calendar. Not a sponsor of the talk, just a good tool you should look into, but there are countless tools. You know, are you using SMS? Are you voluntarily handing over your data? Because we know that there are lawful data access laws all over the world, not just in the United States. Every country in the world has lawful access laws for communications channels. So they're not legally allowed to encrypt telecommunication channels. But you can encrypt packages and put them in those telecommunication channels, right? So you could use something like Signal instead of SMS, which encrypts your messages and then puts it into this data stream and sends it around. So like if you're using SMS, they can absolutely be intercepted, not just by the telecommunications company itself, but intercepted by rogue actors, although that is more difficult these days than it used to be. We just shouldn't be giving access to our private communications to anyone that way. If you're using Facebook Messenger, if you're using Telegram, and you don't understand that Telegram does not end-to-end encrypt your messages by default, I mean, you're making choices that voluntarily hand over a huge amount of data, and you can, as individuals, be making better choices. And there's so much low-hanging fruit where the transition cost is nothing. You know, switching from Chrome browser, which is collecting every single thing you do, to something like Brave browser, or perhaps you use Firefox and tweak all the settings to harden it. Whatever your browser of choice is, it probably should not be Chrome. You're just, again, voluntarily handing over data, and these days alternative browsers are so great, there's just no cost to switching. So that's a very long answer. I just go into a rant. So anyone else have any questions? Yeah. Mm-hmm.
What's the best response to somebody who doesn't think they have anything to hide?
Yeah, I think that we need to make a distinction between understanding the value of privacy as an essential part of preserving a free society and thinking that we ourselves don't have anything to hide, because they're fundamentally two different concepts. So let's just look at, the foundation of privacy for a second. We all instinctually understand that, again, go to some authoritarian regime, get out of your comfort zone where you're privileged enough to, have surveillance used as a tool of oppression against you. Let's go to a different country where you're not allowed to protest against the government, where you're not allowed to say anything bad against the government, where you're not allowed to say anything bad against the warlords who, control your region. Maybe you're not allowed to write anything in the press that is critical. Maybe you have to just be the mouthpiece of the state in the country where you are, whatever it is. And then let's say maybe you're someone who wants to make a difference in that country. How are you meant to do that with pervasive surveillance? How are you meant to, aggregate with other people and put together plans and fight to make your lives better if there's pervasive surveillance? And we see that in a lot of countries it's just not possible for people to do this because surveillance is just so pervasive. It's just so terrible. So we understand the principle of why privacy is essential for a free society, because people need to be able to communicate privately to push back against authoritarian regimes without fear of retribution. So given that, when you hear people say, I have nothing to hide, first of all, I feel like they're just virtue signaling. They're just like, well, I'm a really good person. And then essentially what they're doing is they're saying, well, me and the people with guns are always going to be on good terms. It's like, what kind of a bet is that to make? You have no idea what laws are going to be hatched down the line, and you're making a bet that you're always going to be on the government side? I don't know. I think we have a history of really terrible governments all over the world who institute really bad policies. So if you're someone who's like, I have nothing to hide because I'm always going to toe the line and then, just follow mainstream thought and, do whatever authoritarian regimes tell me, even when maybe morally I know it's bad, but I'm not going to step out of line or try to make a difference. You're saying a lot about yourself there. So I feel that people who share this rhetoric, I have nothing to hide, this doesn't affect me, first of all, I don't respect these people because I just, it's someone who's like, I never want to be an activist. Well, all right, cool, you do you. But on the other side of things, I think it comes from a very privileged position. I think that it's someone who is just lucky enough to live in a society where pervasive surveillance is not used to subjugate them. And unfortunately, there are billions of people all over the world for whom life is not so easy. So that's great that they're not willing to participate in the privacy anonymity set because they feel really nice and secure in their bubble. Me personally, I want to make the world more private for everyone. So yes, I'm going to be using Tor, even though I'm only looking at, I don't know, Instagram cat videos or whatever. Like, I'm going to be using the tools that are going to help these people who are the most vulnerable people in society stay safer, because I see the work that they're trying to do to make their future better, and I want to give them a fighting chance. And they're not going to have a fighting chance if, like, only 3 people are using Signal and they're one of them. Like, you know, we all need to be jumping into these privacy tools to help the most vulnerable people. So that's the response I would give. Yeah.
If nothing else, we need to live up to the title private citizen.
Yeah, private citizen. It's like this interesting inversion that happened, right? You used to have, like, you know, public servants and private citizen, and somewhere along the line, governments get more and more opaque, and then the lives of citizens get more and more transparent. I think that's dangerous. Even if you're feeling safe in, you know, your current situation, you don't want to set up a system where that imbalance of power is only going in one direction, and one side accumulates more and more of it, and the other side, their lives have just become more and more open and vulnerable. So yeah, definitely worth keeping in mind. Yeah.
Proton Mail and Signal both use end-to-end encryption, but they are in the clear on my end at each of my hardware devices.
Mm-hmm.
And we all know that much, but many of us haven't heard and don't know about self-destructing options that each of those have in them. Would you address your opinion on using those self-destruct options and expand on that?
Yeah, I think that this weird thing happened in the digital age where, because now we have these digital artifacts, we kind of want to hoard them. Like, who has looked over any of their past photos, like, recently? Like, what about that fireworks display you went to? Did you go through those fireworks photos and watch them again? Like, I mean, I feel like we collect all this stuff and it just kind of sits there and we keep it for some reason, just in case. And that's a weird change in society, because again, we used to have these ephemeral interactions. We used to have fleeting conversations, they disappear. Now, you know, we meet someone online, we have our entire romance over text message, and it stays there in perpetuity. And you know, we somehow want to keep that. But I think we need to realize that all the data that we hoard is a liability to us, right? If we are just keeping a history of everything we've ever said, sometimes it can be useful. I can definitely see use cases, but I actually think that people need to kind of let go of that idea, just for their health. I mean, that's a choice you guys can make. I'm definitely not going to be like, guys, delete all your messages. But I personally find that, like, self-destructive messages are fantastic. Also because if you've ever been friends with someone and they're involved in a court case, you understand that discovery process means that they have to hand over the entire contents of their SMS history or whatever. If you're using Signal and everything deletes after 4 weeks, it's like a good amount of time. So 4 weeks, if you need to go back and see something, it's there. But anything past that, it's deleted. And I just think that if you don't want your private conversations ending up in public discovery because your friend happened to be involved in some legal dispute, it's probably something you should start thinking about. You know, just how can we safeguard our own lives by not creating this target on our back, not creating this liability?
Is that a process that Signal uses, like the whole 4-week message destroying mechanism? Does that work as well as Snapchat? Because I know they have like the whole deleting thing, but I'm like, do they still keep track of that stuff? Deletes after 24 hours?
Snapchat. Let's talk about Snapchat. Yeah, so Snapchat's so interesting. If you like Google, let's stop using that word, goddamn. If you brave search Snapchat end-to-end encryption, you'll get a bunch of articles from about like 4 years ago talking about their plans in the future to add end-to-end encryption down the pipeline. It's vague, but it's like a big announcement. So it's like, okay, cool. So Snapchat's private, right? If you scour their privacy policy, you won't see end-to-end encryption mentioned once. And you have to click through all this rabbit hole of, okay, click on see more of our privacy policy. All right, I'll click on see more of the privacy policy. Click here if you want even more information. It's like, oh, okay, I'll click here. Like, click on this other thing and see our glossary. And it's a maze. And I've dived into Snapchat so many times. So no text messages on Snapchat are end-to-end encrypted. So your conversations, group chats, private messages are not end-to-end encrypted, so keep that in mind. Your pictures, I mean, they ostensibly photos between people are end-to-end encrypted. I'll say that with a bit of a caveat there. One, it's closed source, so we really can't know what's happening, and it doesn't say anywhere on their website about that. It's just kind of looking through things that have talked about this that suggests that they are. But they also have all these backdoor tools. There's something called SnapLion, which is like a law enforcement tool that's actually been abused by workers before, who've used it to exfiltrate photos of people. So it's like, if it's end-to-end encrypted, and you have these backdoor tools, and you're able to get pictures, how's that working? So Snapchat's like a whole muddly, shadowy thing. If you're trying to find a private messenger, definitely don't use it. If you want to send deleting photos, honestly use Signal, right? Because you can literally change there's a little icon on Signal for pictures that says view once only. You can see that picture once and it deletes. And that's not stored on anyone's servers. That's not even going through anyone's servers, unlike, sorry, I take that back. That is not being stored on anyone's servers, unlike in Snapchat. So, yeah, just opt for better choices there. We've got 5 minutes left, so maybe just one more question. I know you had your hand up for a while.
So you talked about changing culture within organizations. So I'm kind of curious, for people who are in a position like me, who's at an entry-level engineer position and don't really have a lot of influence, where you should begin, especially when you see things going wrong policy-wise with privacy in organizations, beginning that culture change for somebody who lacks influence of, managerial positions?
Yeah, I think that's a hugely important question. And I think even if you're not working for a company, how do you just change this culture of privacy? Human beings are herd animals. We really do like to fit in with our peers. If we can just start normalizing these tools, it does make a difference. All of my friends know that if they want to get hold of me, I am not going to respond on Instagram. Maybe I'll look at it in 6 months' time and be like, oh, I have 705 messages on here. I'm not going to respond to anyone. And they know that. They know if they want to get hold of me, they use Signal. So if you can just start small within your local group, and suddenly you're normalizing, hey, we prioritize privacy, that starts to spread. That starts to bleed into other areas. So really just, you don't even have to make a big deal of it. You don't even need to be accusatory. Again, I understand the costs of switching things up and implementing better policies, and businesses are very much aware of this stuff. They're factoring this in when they're making decisions, probably not factoring it in enough in terms of the downside of losing privacy. But I think that just starting small and normalizing privacy, reminding people that privacy is normal, it's not the exception, this is the rule, this is the default, I think can go a long way, because that spreads, and then you start to say, okay, well, we have a choice here about which way we're going to go. Well, privacy is important, right? Or maybe we'll err on that side. And so just growing it from there, I think, can be really powerful, just, again, by starting from your local network. I think we've run out of time, is that right? 3 minutes. Let's have a quick question.
How do you feel about how we're slowly kind of transforming into a cashless society? How do you turn that the tracking data is encrypted because they use it for IRS purposes and stuff like that. So it's is there any way to go against a cashless society?
Oh gosh, this is such a good question. All right, so we have this weird situation right now where we, again, have normalized pervasive surveillance when it comes to finance. We're like, yeah, my private messages are private, but of course everyone needs access to all of my financial choices. This didn't used to be the case. 1970, the Bank Secrecy Act came in and it said, listen, we're just doing this little thing. It's just $10,000 cash reporting requirements, right? And this was challenged as unconstitutional at the time. They were like, what? You can't just mandate that everyone who makes a purchase over $10,000 has to hand in their financial data? We literally have the Fourth Amendment for a reason. You can't have overbearing searches and seizures. People have the right to privacy. And this went to the Supreme Court, and the Supreme Court said, we agree completely. This is unconstitutional, but $10,000 is such an overwhelmingly large, life-changing amount of money in 1970 that this really isn't a problem, but they had the caveat, if things change, then, inflation, all of that, maybe we'll reassess. And it's now 2024, we have never reassessed that. To give you an idea of how much $10,000 bought you in 1970, that was a house. That was a brand new house, right? So this is insane. So yeah, of course, today, if you went and spent all cash on like a $600,000 house or whatever, then maybe the government would be like, this seems fishy. But what's happened is we lose our purchasing power year after year, and it just becomes more and more normalized that yes, people have the right to see all of our financial data, and it's just not okay. And I just push back against that culturally. I try and pay with cash everywhere I can, just out of principle, It's annoying. One of my friends remarks like, Naomi, you take pictures of your receipts and have to do things manually. I just pay with my card and it automatically gets uploaded to my accountant. Why are you doing this? And I'm doing it because I don't think that these companies have the rights to just be looking at every single thing I'm doing. And I'm not doing anything wrong. Like, I don't know, I'm buying anime or whatever I'm doing. Like, it doesn't matter. But I just feel like I have the right to make decisions that other people are not privy to. And so cash is great, but it is disappearing. We are, seeing the advent of CBDC being explored, which is going to completely transition us to a cashless society. I ran out of time. So the last thing I will say is in the digital world, cash just doesn't really work anymore. You can't use cash on the internet. So what do? I encourage you to start looking into different cryptocurrencies. And I know that there are people who'll be like, it's all a scam, it's all a Ponzi. It's also the best option for digital privacy that we have. And I'm not talking about Bitcoin, which is completely transparent on public ledgers. I'm talking about coins that implement zero-knowledge proofs. I'm talking about things like, look into Zcash, Monero, Ethereum. Like, there are a ton of things. Railgun for Ethereum. Like, just start looking at it. It's a learning curve. But honestly, in a future where all we have is CBDCs or our cards and cash is just disappearing, if you value your privacy, this is going to be something that you will eventually have to start implementing in your life. So that's all the time we have. Thank you so much, everyone.
Also, good to meet you in person.
It's good to meet you. I was like, oh my God, good to meet you.
No, we're doing sort of the vaguely satire, sort of critique the cybersecurity reporting.
Okay.
So, Okay, cool.
Yeah.
Sounds good. Perfect.
I'll come outside and give you so much.
My stuff is with my friends, so.
Fine. And Sandy's like,
No worries.
sorry.
Move your laptop.
Let's see here. So we got internet first, right? And there's a USB-C connector already on it. Excellent. Yeah. We're gonna need a bit of a speed run, I guess. So, all right. I just had a last one was pretty strong. Good. Yeah.
Okay, and now we have Yael and David for the worst of cybersecurity reporting in 2023.
right, everybody, if you're here for the worst of cybersecurity reporting, you are in the right place. If you are not here for the worst of cybersecurity reporting, you're still in the right place. Welcome. So, you know, as was mentioned earlier, I'm David Huerta, digital security trainer over Freedom of the Press Foundation, and this is...
Hi, everybody, I'm Yael.
And this year we're going to do our annual talk. We're going to talk about the worst cybersecurity reporting that we ran into in the year 2023, the year of a lot of cobbled together stable diffusion and other LLM and various machine learning language things that have been, or machine learning things that have been co-opted as being called AI. I don't know, if I don't see Lisp code, it's not AI. I'm old school like that, sorry. Hello, so Yael, you can talk a little bit about yourself.
Yeah, hi everybody, I'm Yael, and my day job is working for Security Planner. This is not a Security Planner talk, but I do have stickers. And my background is in journalism. I actually went to Cronkite for grad school, and it was pretty fun. See, there's a Cronkite alum here. It was actually really cool because it started right after DEF CON and ended right before the next DEF CON. So really nice way to kill time between DEF CON.
And I'm David Huerta. I'm a digital security trainer over at Freedom of the Press Foundation, where we basically help journalists not get hacked, which is working out. Actually, it's surprisingly good these days, which is great. Also sometimes do a little bit of cybersecurity reporting myself. And then way back in 2010, my friends and I helped co-found your local Arizona hackerspace, Heats and Clouds, which you should all go check out. It is down the street in downtown Mesa. It's still there, which is kind of amazing, given all the shenanigans that people do and all the various chemicals and flammable materials, like safety third. All right. So welcome back to our annual grill. Fun fact about this image, Bing would not let me actually get it, describe the CEO of OpenAI. So I said, I described the characteristics that looks like the CEO of OpenAI, and it let me through. So AI is not that I guess. All right.
So right now we're going to be roasting print articles, not because they're more roastable, but that's just because we had to narrow it down somehow. So we're not going to be roasting op-eds. It's just a little bit too easy. We're not going to do broadcasts because we didn't want to watch 5 million videos. And we are not doing marketing material, even though we probably should. But luckily, there is some journalism that reads like marketing material, which is fair game.
And this is something we repeat every single year, but it's basically a very good reminder to kind of showcase that, you know, a bad article doesn't mean the author is bad every time. A bad author doesn't mean the publication is bad every time. A bad publication doesn't mean the industry is bad every time. We actually really like journalists. We do journalism ourselves. We even like some of the journalists that we are roasting today, and some of the publications are, in fact, from our own media diets. And yeah, so we just kind of like to focus on we can still do better, everybody, just like all of us working as cybersecurity professionals as well as journalists.
No, we really do. Every year we roast a journalist that I really like, and I feel really bad. So please don't harass these people. But yeah, we try to put this in themes, and one of them is about context counting. And this very first article that we are going to roast, smartphones, is the best smartphones in 2024. And when I said that a lot of journalism reads like marketing material, this is an example. The Black Phone Privy 2.0 is the guardian angel of smartphones, offering an unbreakable fortress for privacy and security from the moment you lay hands on it. But we're not only picking on Black Phone, they also did this with joining the purism revolution and experiencing the pinnacle of tech with Librem. And also they put a lot of faith in VPNs, which I personally do not do. They said just as the finest VPNs do, Black Phone vows to never log your data, because we know that VPNs never log your data. That's not actually true. But, and I had a lot of questions about this article. I wanted to know what a secure smartphone is. And what is vault-like security? Like, what are the specs for vault security? And what about elite security? Like, is this like a spectrum? What do these words actually mean? And I really wanted to know why this piece kind of bounces back and forth, which is what it did. It was like, this is secure because it auto-updates. This is secure because it has end-to-end encryption. This one's secure because you can configure the security controls. This one has kill switches. This has Face ID. And we didn't really know how the phones compare to one another. They just listed a bunch of phones. We also didn't know who made these claims and how they analyzed it, because sometimes marketing material is aspirational. And so it's really great when journalists try to investigate and interrogate those claims. But every time there's a bad article, there's a good article to go along with it. And we really like this New Yorker piece about encrypted phones. And as you can see from the next slide, many criminals have been convicted because of stings of encrypted phone apps. So yeah, everything with a grain of salt. We don't really trust these marketing claims 100%. So what went wrong? We think that maybe the tech reporter was told to cover phones for security without being given a lot of guidance or the proper tools to do so. We know that everybody's getting laid off. There's usually one journalist doing the job of like 4 people. Sometimes there are deadlines that don't even allow you to do a good job with your reporting. And sometimes there's like bad editors. So we don't really know exactly what happened here, so these are just hypotheses, but this piece was kind of like a mishmash of security features with a lot of marketing hype, but there wasn't a clear methodology or evidence for any of these claims, and so that is why it won the award of making it into this year's roster.
All right, this is actually not the worst article, but it is an article that kind of goes into a really, really interesting story if you're like a cryptography and math nerd, but if you're everybody else, maybe left out or sort of diminished certain key aspects. So to start off the bat, this article is technically accurate. Like, there's no like false claims. Everything actually is just actually impressively like fact checked for a subject matter that is actually difficult to even understand in terms of just like talking about like lattice math. Does anybody know what lattice math is? This crowd probably does, but outside of this crowd, maybe not as much. So in this case, this was about a attack that was done by some academic researchers trawling through a whole bunch of SSH, IPsec sort of like handshakes. Basically talks about some of the caveats, mainly being that there's not really that many actual implementations of this affected basically at all. So we're looking at a data set over 7 years of 5.2 billion with a B SSH or IPsec records. And out of those, a good 189 like private keys were taken. So, you know, the ratio that you can do the math yourself, but it's not necessarily, it's, you know, one of those like, will I be struck by lightning while also being stung by killer bees type situation. And the other thing too is it's not OpenSSH that's affected, which is what maybe most of you use and are familiar with. It's like weird, interesting, specific implementations of SSH from versions of, you know, router operating systems on Zyxel and Cisco OSs, but it's one of those things where like that could still be important if that is connected to important critical infrastructure. It's like, oh, is Zyxel used for like every hydroelectric dam? I don't know. That'd be cool. That'd be an interesting thing to explore. It's not explored. And you know, these kind of like we're breaking cryptographic things stories are, you know, very technically impressive. So they're a pretty big deal, but also as far as like being able to explain, like, you know, do you as an everyday user of the internet have things to worry about here if you just use SSH or IPsec for stuff? Perhaps not. All right.
Okay, so our next category is sensationalism, and our next story is about a hacking expert who has mainstream apps that he would never use because of privacy risks. They interview a security researcher. We all know them. Some of us are them in this room, I'm sure, who like don't use certain things for certain reasons. This person in particular doesn't use Uber, WhatsApp, photo editing software, weather apps, or a digital voice assistant. And there's a lot of different people who use and don't use different things. There are a lot of opinions in this space.
Aside from voice assistance, he said don't put it in your bedroom or bathroom if you have one, which is good advice. But other than that, the piece doesn't really explain the risks or mitigations. Like, what if you really want to use it? What should you do? And I feel like what went wrong here is really on the part of the journalist, because they interview a single person who says he won't use things and then print it as advice for everybody, even if they have completely different context, situations, needs, threat models, and appetite for risk. And so I thought that was kind of lazy, and it's really unclear why this happened. Like, there's a deadline pressure, so they couldn't add context or interview other people. Was it a bad assignment? Maybe people didn't want to talk to this journalist, so they couldn't find another source, but it's just kind of, I feel like that's kind of the equivalent of being a fashion magazine and saying, this person won't wear certain outfits for reasons, and just publishing that. So it's a little lazy.
All right, here's an oldie and a goodie. No, this is not copied and pasted from last year or the year before that or the year before that. It's just a new article about juice jacking, which still isn't a thing, Gretchen. Like, it's not going to be a thing. So this is the latest juice jacking story from NPR that happened last year that looked at a sort of repeated sort of warning about this proof of concept in this FCC document, which it references, but also the FCC document itself actually talks about how this has not really been seen as a real ubiquitous thing. It's been more of like a proof of concept thing that people have developed for researchers to just kind of prove that it can be done. I mean, this is one of those kind of situations where there seems like there was some sort of they wanted a second opinion from somebody that was an expert. Maybe that expert did more speculation than explanation on well, this could be more of a thing due to pandemic, which was a weird kind of take on why juice jacking would suddenly become a thing. But I think the kind of last bullet point is probably the most important lesson of this, is that I think that, for us in this room, there's a lot of things that are very easy and make sense that are completely not easy and not economically sensible. If you're a cyber criminal and you have a massive return on investment from a very, very, very low cost, phishing campaign, or if you have a good return on investment into that, why would you build custom bespoke electronics, go back and forth with whatever fab you're working with to make that a thing, sneak into airports somehow and use that to unscrew power outlets and put in bespoke hardware that has to fit in these tiny little spaces? There's a reason why this doesn't exist in the world yet. All right, and yeah, so basically just to reiterate, this has been just a proof of concept attack for a long time. But the fact that this has been only a proof of concept for half a decade, I think deserves some exploration. That wasn't happening in any of these articles over the past few years.
Okay, I really like the writer of this, and journalists don't usually write their own headlines, but the first thing I'm going to do is make fun of the headline because it's 3 lines long. Hacking tool, Flipper Zero, tracked by intelligence agencies, would fear white nationalists might deploy it against the power grid. Okay, I would really like to see some evidence for this, or better framing for this. And the piece did disclose that there's actually limited capabilities. For example, gates aren't inherently susceptible to Flipper Zero attacks. Older gates are actually more susceptible to radio interception. So maybe that's the real story here, is that these intelligence agencies are overstating the threats of these issues. To be fair, as far as what went wrong, there was a little bit of nuance in the story. It does hint at exaggeration. I don't know if the report itself is newsworthy. Definitely not the framing. And then also, I think a lot of readers might not worry about people taking away their Flipper Zeros. I worry about people taking away my Flipper Zero.
That's right, Canada.
Yeah, Canada is taking away Flipper Zeros because people steal cars, which is not, I feel like the act should be illegal and the car manufacturers should get better instead of taking away our fun toys. And also I was kind of disappointed. I feel like this is a joke, but I feel like this was a missed opportunity to get the feds to tell you how to use your Flipper Zero as a garage door opener, because I haven't been able to do that. So if you know how to do that, please find me afterwards and let me know.
All right, this is, speaking of Canada, actually, where no flipper zeros are allowed. So we have this story from the CBC, which honestly almost didn't make the cut. There's a lot of kind of weird intrigue surrounding it. It's very much like a spy novel. So basically, there was somebody from the RCMP, which yes, is the Royal Canadian Mounted Police. Not all of them have the horsies and the hats and the red outfits. But some of them do kind of more cybersecurity things. And in one case, there was a story where somebody was basically charged with selling basically Five Eyes shared intelligence with a sort of criminal underground that was basically funneling things into, among other places, Iran. So this is probably a super interesting story. Also, God, this is also just, all these headlines are just getting longer. There's headline inflation. I don't understand. All right. And unfortunately, when it came to other stories like this, when it came down to the Snowden revelations, we got the goods, we got evidence, we had the receipts, we had here's literally a PowerPoint presentation of what was being done. And in this case, we have no such receipts, I guess, unless we are, criminals that want to sell them to Iran, I guess. But yeah, in this case, we have these sort of weird claims that just kind of end up getting floated, like Tuta, which is Tuta Nota, which is sort of German proton mail, as being sort of a front, a honeypot basically, for some sort of Five Eyes thing that there was no detail out about. There's not really questions that are being asked, but then they probably wouldn't be answered anyway because there's a whole big old court process that's a very big deal. So it's one of those things that it does include a rebuttal, but also it's well, also Google's PR team had no idea that PRISM was a thing, so they were caught off guard and said they weren't doing it when they were. And this is sometimes this is a very difficult story to handle because you just don't have anything to prove anything one way or the other for a lot of these things, and you're talking about people that are very, very interested in keeping secrets that are involved. So there's a lot that basically isn't presented as evidence. Maybe that could have been a little more highlighted, perhaps. But otherwise, this is really not necessarily the media's fault so much as it is just the security state, I would say.
Okay, so this next story is again a Dr. Bronner style label style headline about hackers abusing Gmail's blue check marks. Experts warn 1.8 billion Google users about imposters trying to steal money and passwords. And here's how to spot fake verified accounts. Seriously, this headline is half the slide. But the thing that really made me upset about this article is that I feel there's a tendency to blame users or give them very complicated things. Oh, surely you won't fall for spoofing if you look closely at all verified email addresses and see are there different numbers and letters next to the blue check mark? Because people do that to try to trick you, and I feel this is an unfair onus on the reader, and takes away from accountability that companies should be facing for having these errors in the first place. But we didn't see a really good article that we liked in Cyberscoop. So what went wrong? Actually, ironically, what went wrong is that trying to be first, it's kind of ironic because the Cyberscoop article was the second one that was good, and they have scoop in their name. But sometimes trying to be first and being hypey means your story is kind of meh. And sometimes people think that you're empowering users if you blame them for not doing things that no reasonable person would do in the course of their day. It does not empower them. It shifts blame where it shouldn't be shifted. We want secure by design, secure by default, but that's my other rant for another day. But I did want to say that scouring through the technical details in Mastodon posts is really good, and that's why we liked AJ's article in Cyberscoop so much.
All right, this last one made me sigh because I actually really, really love the markup and recommend them highly for a lot of the other very important journalism that they do. But as soon as I read the headline, I knew this article would be bad. So without a trace, how to take your phone off the grid, which is about, hey kids, want to do a burner phone? Check this out. So unfortunately, it's one of those stories, and I was like, oh dear. So in this case, there's a lot that, unfortunately, there are situations where oh, this journalist threat model actually does involve burner phone. All right, let me look into all the several ways this can go wrong, so I can prepare them to tamper their expectations. in this case, there are like court cases where things like surveillance footage from stores where a SIM card was found was used to figure out like who was the owner of a particular phone number, even if it was a prepaid card. So that was like totally left out. And in this case, talks about using a used phone, but there's certain identifiers that are not necessarily SIM-related that allow things like emergency calls, tower dumps, among other features. The IMEI identifier, I think, that basically are persistent across users. So you may have bought a used phone, but that IMEI, you know, if there are records of where that is and where that was, and like it's past or still attached to whatever used phone you get. It's not exactly a clean start. And then there's the sort of like screen unlock code of being 6 digits long. This is unfortunately like very oftenly repeated, and it's not necessarily terrible for modern implementations of iOS. This is a slide for, but you know, I wouldn't recommend it. So because there's literally a screenshot of a 6-digit code being cracked by exactly the kind of tools that they're worried about. So this is a screenshot from a tool called GrayKey, similar to Celebrite if you're familiar with that particular vendor. And this is where, you know, basically cracked a screen unlock code that was 6 digits long, which is exactly what the article is recommending doing. Of course, there's been newer things done to iOS to prevent that from being too easily cracked, but among other things, there's also this sort of recommendation for Proton Mails being anonymous, which is often conflated with secure or private. And this is very, very nuanced. Like if you sign up for Proton Mail using a VPN or over Tor, it will ask for a phone number, at which point it's kind of not really as anonymous anymore. If you're doing that before you actually have a phone number, that would basically mean you have to use a number of phone numbers. So either you already have a burner phone that you can use to create the email account for the burner phone, or you use like your own cell account, which is not a burner account. So there's also other things that I think are overly cautious, I would say. Things like, for example, not using the Notes app on iOS because it's synced with iCloud. There are ways of using iCloud with advanced data protection to make it end-to-end encrypted on iCloud servers. This is a very, very new feature, though, so I don't blame people for not necessarily knowing it. And there's also just the other issue where like they're talking about overlapping Wi-Fi signals, not so much on cell signals. They could have maybe highlighted that a bit more to make sure people don't bring their regular phone with their burner phone. And these are all a lot of different skills in a lot of different places where you learn things. Like you learned about court cases from Pacer. Not very many people in tech have access to that because they're not lawyers. Telecom infrastructure is its own Cthulhian like hellscape, and I can't pretend to know everything about it, but I know that it's complicated. And in this case, yeah, they probably didn't actually need a burner account for what they were doing. They probably just needed delete me.
So we don't want to be the people who just ran about how journalists are bad. We actually want to give you some advice for what you could do to be better as a journalist. And this isn't just for journalists, it's also for CactusCon speakers and maybe some of the people in this room. It is really important to put things in appropriate context. Otherwise, people, I don't know, it's just good. This is just good to do. You also want to practice skepticism when covering what a single expert says, what a single company says, what a police report says, or if there's a proof of concept that seems too easy to be true, like maybe put your skeptic hat on. I think the world could use a lot more skepticism. If you are a journalist, I want you to do this above the fold. If there is a lack of evidence for the story that you're writing, do not bury it in the bottom of your story. I want to see that high up in the article. Don't compare apples and oranges. That was specific to the phone article where people are like, here's a bunch of secure phones that all do a bunch of different things, but you're not like showing them against one another. And I think that just confuses people who are like, oh, I'm going to use X because it's secure. Secure for what? Like, what are you trying to do? And the last thing is, please do not blame users or tell them to jump through elaborate hoops to fix issues that companies should be fixing. Seriously.
All right, do's and don'ts for security researchers. It's important when we're kind of showing off like really cool proof of concept work, which I absolutely think we should show people that things are possible that they maybe don't think are possible. It's important to mention like the context of this, of just like, yeah, you know, actually I had to create bespoke electronics for this sort of thing to work. I had to do these things. Like there's a lot more to what goes into something that would actually make it not necessarily easy. And also thinking about like why certain proof of concepts we don't really necessarily see as much in the real world versus stuff that is like very common and persistent and doesn't seem to be going away, like phishing. And, you know, it is a good idea and fun, I would say, to call out like terrible marketing hype. That is why Mastodon was invented, probably. And it's important in this case to, you know, keep, you know, no, I don't want to say stay in your lane in terms of like, you should not stay in your lane. You should explore everything you think you don't know so that you know more about that, and I think that's great. But it's also one of those things where, you know, being good at, say, doing IT stuff is not necessarily the same as being an expert on creating a burner phone. So that's my take anyway. All right, any questions?
Yeah, we're, and then also if you wanted to the next slide. We have maybe a couple minutes for questions, but also if, you can find us both on Mastodon, and I live in Phoenix, so if anybody ever wants to get coffee and rant about the state of journalism or the industry, I'm totally down for that. And yeah, I think we have time for like a question or two.
I don't know where the microphones are at. Oh, there's one question over there.
I got one question. So with the type of content that's in the articles that you guys have described, how much of that, in your subjective opinion, might actually be contributed to like an editor-in-chief that might be pulling out content?
Oh, yeah.
Yeah, no, it's absolutely an issue. Sometimes editors will rewrite stories badly. Sometimes they won't even show them to the journalist before they publish it. So yeah, you don't always know that there's an editor. Oh, zero. Yeah, yeah, editors can be really bad. There's good editors, there's bad editors, and writers don't usually throw their editors under the bus. So yeah, that's a good question. Thank you. We're at 0 time.
Yep. Sorry, we're at time. You can ask us questions once we're down here, though.
Yeah. Okay. Oh, sorry. I was going to say, I will quickly introduce you guys. I also have these. I'll be holding them up in the back. It's 15 minutes, 5 minutes, 1 minute, and 0 minutes. So, sounds good. Yeah. If you have any questions, like if you're wondering how much time is left, you can ask much up to 20 minutes, whatever counts. So, yeah, I'll introduce you guys, Morgan and Noah. Sweet. Just paired. What? That's who we're trying to be. 2-1. Hey. They're going to be interested. Yep. So. Hey, how does what you're doing work? It's a good question. Yes. Figure it out. Okay, why it's not connected to my filter, that's not great. But I don't need it, but I would love it. Forget it. Like, on your... It's got Bluetooth off. Oh, I just got it as it turned off. Every time. Every time this seems to happen. Shaking. There's a lot of people here. That's cool. No, pretty weird. Do you want to try to connect Wi-Fi? No, I got it. Got it. Okay, all right.
All right. Up next, we now have Morgan and Noah giving a talk on unlocking RFID security.
All right. Hello, Hello, everyone. Welcome to Unlocking RFID Security. It's going to be a deep dive into this. I'm sure you're all aware, the Flipper Zero and the different vulnerabilities that exist within HID's multi-class reader system. So, I am Noah. That's me up there. I'm a student at GCU. That's pretty much it.
Yeah, I'm Morgan Hunty. I'm also a student at Grand Canyon University. We're both studying cybersecurity and set to graduate pretty soon. So just to get the kind of fun legal stuff out of the way, everything that we've talked to you guys about today, we sent a paper to HID about 7 or 8 months ago, and then resubmitted it because they said that wasn't really anything. About a month ago, and they came back to us and said that this was already known, and they had a paper published on kind of what to do that was actually published in January of this year. So, they do know about this kind of stuff.
All right, let's start getting into fun technical information here. We'll start with, this is basically table contents of the different types of security that HID employs within their reader access control system. We have 5 different main types here. There are a few more, but they're not super important for today's talk. You have low frequency, I-class legacy, and then you have I-class elite, which is building off that, and then moving on to the I-class SE systems, which is the currently used system introduced in about 2011. Ironically, still 13 years old, people still use it pretty consistently. Standard security key 1 readers, and then standard security key 2 readers. There is a difference. So, moving on to standard low frequency RFID. I'm sure you're all aware of this, but we'll go over it anyways for context. This is going to be beginner, intermediate level talk. This is one-way slow communication with the reader. It's unencrypted, really. It's just bytes. You can see them, or bits. And all these different types use some sort of wagon protocol, which is either between 26 and 37 bits. It can be more with some of the new extended formats, but essentially it's pretty basic. They literally patented it in 1974, so still used though sometimes, which is not a great idea. Then we have I-class, which is built on the Pico Pass card system. So this one is a big upgrade in security, I would say. We're talking authentication keys, diversification keys, a bunch of encryption keys. There's actually a bunch more that aren't in this, but for the purposes of today's talk, again, looking at more high-level overview, it's built on 13.5 megahertz, which is important to know because it's a lot faster communication. It allows the cards to store a lot more data. Which obviously allows for stuff like that diagram up there. It looks super fun, I'm sure. Lot of cool information in that. For the purposes of this talk, you don't really need to understand all of that, but we're going to look at block 0, which is the card serial number. We're going to look at block 3, and we're going to look at block 6, and I'll explain a little bit more in a second. So there are also 3 that are important encryption or decryption keys today that we'll talk about. First, it starts with the authentication key. This is effectively what effectively allows read-write of the card, but in essence, it's actually only used to calculate the diversified key. That diversified key is stored in block 3. The encryption and decryption keys, and these can either be DES or triple DES. In essence, they're all triple DES in any modern system. The actual keys that are stored on the chip in the reader, and then the command to tell the reader which to use is specified in block 6. There is also some fun code that we uncovered in block 6 that may have some disabling of the encrypted communication between the reader and the card, but we're not going to get into that much today because we just found it. We're not going to touch it in anything today. Then we have the diversified key, which is the key used for the actual authentication of the card. It's calculated by the reader, sometimes using the CSN and the authentication key, but with the standard I-class legacy, it's using just the authentication key and then putting it through a DES encryption. Then we have the I-class elite program. So this is another upgrade to this, which a uniquely diversified authentication key. So this allows each individual site to have their own keys. So kind of breaks that whole, hey, we have one key for every reader in our entire lineup. Which isn't the greatest practice. But in essence, we have this diagram as well. Again, something that probably won't really get into until we want to break it. But you basically take the card credential number and the high security key that's diversified for each individual facility that wants to use it, and then you put it through a bunch of fun algorithms, throw it in a 128 byte key table, gets rotated, and then throw it through a separate fortification algorithm, which then gives you a diversified key, which is very different from the original iClass legacy, as you can see up top there, where it literally just goes through a DES. So a little bit more security, right? They're learning. It's about 2008, I think, at this point. But again, all these protocols that we're going to talk about today are literally still often used, like very, very frequently used, and still considered top of the line sometimes. This is free and easy implementation. iClass Elite wasn't always free, as far as I'm aware, but HID, after the paper was published that we're talking about, they kind of made it like, hey, everyone can use this for free, because obviously there's been some issues. And then there's that 120 by key table, like I said, just a stronger fortification algorithm. Then more information in the next level, iClass SE, which stands for SIO enabled. It's a new type of data wrapping technique that they employed with a secure identity object. This is like grossly simplified, by the way, but just for a high-level overview of what needed for the talk that we're talking about. They implement the secure identity object, and it utilizes triple DES encryption, but it's a new key. So once this SAM, as you can see with the diagram there, there's a SAM, which is a secure access module, which keeps the keys inside of it. So basically, you can't just go into firmware anymore and pull those keys out of it, which is what they used to do with the standard iClass keys. Those are stored within a fun little secure access module. Looks like this. Very, very small, very cool. And it decrypts the triple DES data that you're looking at. It takes about 100,000 lines of code and then puts it into like 6 sometimes, and depending on the size of the card. And then it carries the credential and the SIO information to the authentication key chip, and that authenticates with the credential and the access control payload there. So in order to take advantage of this, HID needs you to upgrade your readers most of the time. They added this secure access module so cards can be read on legacy readers, but when they initially came out with the technology, they employed key sets. So they employed the second standard key set, which was not leaked. For important context, the first standard key set was leaked in 2016 and is available pretty widely within the hacker community at another conference, not this one, but that one was leaked, and the new SE authentication key was not leaked. However, when they deployed the system, HID was like, hey, or the customers were like, hey, we want to be able to use our old credentials with this. And so they basically downgraded the security entirely and started to use the original authentication key, which had already been leaked for even SE communication, which is also not a great idea. If you have already leaked stuff and then you're going to go back to it, not the greatest idea, I would say. This is kind of a comparison of what the inside looks like. Like we talked about before, it's built on this PicoPath card system. You have so on the far left, you're going to see a legacy iClass card that has all the important information is colored, by the way. Has the access control payload there, which stores like a PIN and a password and all that good information. And then iClass SR was a new implementation in between iClass Legacy and iClass SE, which allows a secure identity object for authentication with SE readers, as well as legacy reader authentication with the standard access control payload there. But because we know the triple DES read key for 6 through 9, we can basically see it in clear text, which is not a great idea if you're wanting to stop cloning from cards. But with the actual SE implementation, it uses just the secure identity object, which again is triple DES encrypted and the key has not been publicly available. This is a sample dump of kind of what credentials look like. Basically everything's blurred out because they're real, so. But you can kind of see where the blocks lie, and it's just all a bunch of hex data, basically, inside the card.
Perfect. Well, thank you, Noah, for all of that information. But let's look and see what this is actually going to look like for, in the real world. So this is kind of going over what standard iClass to low-frequency downgrade attack looks like using Upliver 0. It's really two buttons that you really need to hit is reading the card, which will give you the CSN, the facility code, which is based off of kind of which location you are. So if, this is a location, this would have its own facility code for all of the readers here. It gives you the card number as well as the credential number. Really all we need for this to downgrade it to a low frequency is just the CSN and the facility code. So this is encoded using a standard ligand authentication, and then as well as the standard 26-bit format such as H10301, which we are using here. It's really 3 hex pairs for that low frequency. So if you know what the facility code is, you can enumerate those 3 hex pairs fairly simple. So there's not much security in that, unfortunately.
And something I may have forgotten to mention before with low frequency, the standard ligand protocol only uses a facility code and a card number, and so that's just 2 bits of information. That's basically no information for authentication. There's no keys. There's nothing like that. There's no really encryption whatsoever. So with something like this, if you're able to look at someone's printed card credential or even get close enough to actually clone it, right, that's going to be an issue. But additionally, like, you're able to just see a card number and then brute force facility code. That allows you basically some level of credential access to the system. And while that's not super important modern day, because you don't want to just sit there brute forcing something for 100 seconds while you're actually actively trying to get into a building, so it's not super important in an actual practice. But what it does teach us is important information. It teaches us that HID uses across-the-board authentication with their readers. So no matter the encoding method of what you actually want to authenticate with, any of these multi-class readers will use all these different protocols in essentially the same manner. So the standard I-class card will have the same level of security as an LF card. Or there may be some other protocols that we're going to look at, like Elite or SE, and starting with Elite. So this utilizes something called a low-class attack. Shout out to Eric Betts for recreating the cipher. He did a lot of the great coding work on this. And this is all accessible using Unleash firmware on anyone's flipper. That's kind of the point. It's very simple to do now. There's 2 parts to it. First, you're going to have to present the flipper to an Elite keyed reader, and it'll collect about 18 responses from the reader, and then save it to a log. And once you have this log, you're able to connect the flipper to your phone, something like that, and then run the data that you're getting from the reader into a cipher recreation, which then allows you to reverse engineer the high security key up there, which is different for literally every single place that wants to implement this. And when you're able to reverse engineer that high security key, then you're actually able to clone credentials and do things like that. And so once the key is found, you add it to the Elite dictionary path, you can run the attack against the card and then clone the credential. Then moving on again to SE, SEOS, SR, anything like that. For this, it gets a little bit more complicated. Like I said before, we don't have the triple DES read key. We don't have the authentication key. We don't have these things because they're stored deep within memory. Hardware hackers have been trying to find standard key set 2 for years, which is the SE specific one. But we do have SK1. And if we have SK1 and a lot of multi-class readers use this, well, we can actually weaponize that secure access module. So if we can take only the triple DES read key, which is written on here, and then utilize that in an application, we're able to essentially downgrade the access control payload that exists within the SIO wrapper, and then downgrade that to a standard PicoPass card. So you might ask some cool questions like, isn't SIO tied to CSN? Which, if it's encrypted via a CSN and a key, then yeah, it's probably going to have the serial number somewhere in that encryption cipher. Well, once you actually are able to read the SIO payload, then you're able to, once you downgrade it to a standard access control payload, it's no longer tied to that information. So there's no check on it outside of the encryption, since they just assume that once it comes off the SAM, it's okay, it's good. This allows us to kind of exploit that a little bit, which If the Cedar app on the Flipper does this pretty well. You just read a peak. It's literally 2 buttons or 3 buttons. You read a PicoPass, you're able to see the credential right away, and then save the PicoPass card, and then clone that whenever you want to. It does populate the PicoPass card with a bunch of bogus credentials, but that's not really important. And it kind of teaches us that a lot of the stuff in the card is not checked when it's presented to the reader. The only thing that's really checked is the access control payload. And another question is maybe, is an SE diversified? And if it's some level of elite, because elite and SE can work together, in this important context. When elite and SE work together, they're able to do the same attack on the same SE card, because once you've read the SIO payload, turned it into standard access control, then you're able to decrypt that in the same way that you were able to with elites. But the point of this is basically that all these attacks are stupid easy now. You basically need to understand none of what I just talked about in order to do this. So at one point, you had to do a bunch of super fun research. You had to know how to use a Proxmark III and a SAM module, which is, intermediate to advanced as they advertise in like their GitHub. If you have some experience with hardware hacking, I'm sure you've seen many of these in your days. I enjoy them personally, but you also could have used a spoofing card, which I don't know about everyone else in this room, but I cannot build that. I'm not that good. I had trouble soldering my badge the other day. So I don't think I could do that. If you can, props to you though. And you also had to have a pretty advanced level of knowledge. You had to manually do this all back in the day. And when I started this research, that was the point. These apps did not exist. Last year at CactusCon, still working on this research without the Flipper whatsoever. And now the Flipper implements all of that like that. So we kind of changed up the talk a little bit, obviously, because of that. This is some fun information that you had to know before. Take this, you don't even have to read it, but the point of this is basically just to say what you used to need to know. You used to need to understand a cipher. You used to have to understand actual reader authentication protocols. You used to have to understand elite ciphers and hashing functions, and then how you're able to look within reader memory in order to find the calculated key values. You had to understand the 128-byte key table and what the weak hash collisions were within the DES encryption, or the SIO channel, like the secure channel encryption keys, and how to create transport data. Stuff that I'm sure none of you wanted to figure out. I didn't want to figure out when I first started reading it, but then I got a little determined, so. That's what a Proxmark looks like also. That's a lot of data that, again, a beginner, a child, probably is not going to want to figure out. So kind of creates a barrier of entry into this level of hacking that we're talking about.
So again, thank you very much, Noah, for all this great information, but this has kind of all turned into one device. Again, Flipper Zero, which I know probably a lot of you know about, it really doesn't need any coding knowledge at all. It's a really nice and easy to use GUI of just saying, I want to read it, it does it, spits all the information that you need, and then does all of those hashing functions for you. And we did the math for this, and it should be able to read about 98.2% of all the readers that HID uses. So that's about 75 out of their 4,000 different readers. We got this number from their Excel sheet that they do have on their website for when you are wanting to purchase these as a business, which we will get into in a little bit. So you may be wondering, what are the implications? So it's the ease of compromise. It's super easy for a script kiddie now to buy one of these and then start using them immediately without any of that programming knowledge. And then it's limiting the effectiveness of all of the SK1-based readers. If you are just wanting SE, but you're also accepting these lower security, like low frequency or standard I class, it's really not worth it to have that standard SE with those standard security 1. And then it's also the cost versus security trade-off. So what are you really willing to spend on security? Not everything is free. It's what are you actually going to pay for that? How much are you willing to do? And then some people who are in their businesses use these, you might be wondering, what should I do for all this? First one, just don't have an office. Really, that's, I'll go home. We really don't need it, you know, but for real, use standard key set 2. So using this will have it so you're not going to accept any of those kind of lower end cards. It just kind of bolsters that great security that HID does have using layered security. So maybe they can get past your first door, make sure they can't get past your second door using MFA or, you know, security guards. So if, you know, hey, I don't know who Bob is walking into that door, we make sure that we know that they're actually supposed to be there. Another one is employee training. Let them know what this is. It's not that expensive. Let them know, hey, if you see someone carrying this, don't let them get it near your pocket. Like, come on, guys, we really don't need that. Number 4, if you really don't trust your employees, trust me, I understand, have them have an RFID blocker. It's something super simple that you can give out to your employees, so they might just tap their wallet on their readers. They actually have to pull out their card. It makes it so I can't just go behind them and grab their key kind of relatively easily. So kind of what I talked about earlier with all of the different readers that HID does implement. This is actually a screenshot of their Excel sheet. So if you are wanting to purchase those standard key set 2, you're wanting to, hey, let's spend all the money that we have to purchase the best that we can. You just need to make sure to select that we're only wanting to use the SIO/SEOS and that ensure that it does say that it is using the standard key set 2. This is their best one. We would highly, highly suggest using it. This is what HID does suggest to use as well in their paper, kind of talking about what we're talking about today. So yeah, thank you very much. This is all of our references. It is a lot, but again, this is a lot of information. Thank you very much. If you guys have any questions.
Any questions for us? A lot of convoluted information, I'm aware.
I'm assuming when you get a off-the-shelf SE multi-class reader system, they're going to be able to be downgraded. Is that correct? So you have to take some steps to prevent them from being downgraded.
So in a sense, yes. There's 2 types of those SE readers. An off-the-shelf reader may be like configured via standard key set 1 or 2. The issue with that is that HID doesn't really advertise which of these is used in the reader on their website. You have to actually go through the Excel sheet. And the Excel sheet will tell you specifically which key set is used. And like we said, we only have around 75 that actually use standard key set 2. So only 75 truly secure readers exist within their lineup. So the Excel sheet is really the best place to find that information. Yeah. Anything else? Thank you. Thank you. Anything else? Thank you. Thank you. It was like 400 hours.
Not that easy.
Thank you.
Yeah, it was awesome.
Oh.
Yeah, our physical security guys go, what the, oh, that's why.
Yeah.
Yeah, exactly. That's exactly why.
Glad to hear it. No. Oh, do you want it? Okay, sure. All right. Sure. Perfect.
Yeah.
That's my official picture.
Good job, mate. Thank you. Nice to see how there's a fan around.
Yes. Yes.
Is yours?
No. That's yours. Thank you. Good luck, you guys.
David.
The same thing now, like they've been introduced as far as they learn. So basically everything that like applies to already applies to yeah, yeah, absolutely. So yeah, kind of. Not like you can buy it off the shelf, like
Mayor Bear.
so this is taken
Drillful.
okay, not by us, but obviously they sell them now. HID discontinue them, but there's this goes all the way down. Red team tools has often.
Basically, if I hold this up for kids, it's Mary's first talk to
Awesome.
She mentioned that. You want me to mention that or whatnot? I know we do things a little bit differently for DEF CON. What happens? DEF CON, well, typically DEF CON they take shots. But, okay. We're not doing yeah, let's not do that. Okay.
Yeah, let's get out of here.
What's up?
I was just looking at what it looked like on the screen.
Okay. Cool. Ready? All right.
Hi, all. Please welcome Mayor Bear and Threlfall speaking on how to swindle machine learning caches via the wagon train.
G'day everyone, my name's Adrian.
I'm Mary, hello.
Today we're going to be covering some red team tactics, first up, of methods of using machine learning models as a supply chain attack vector to get C2 implants running in businesses. We're going to discuss how to deploy these attacks, do the associated like phishing or watering hole attacks that you need to do to get them deployed. We're going to cover off then what you can expect to find when those C2s detonate inside a business. And we'll go through some looting activities. Then we'll move on into the rootin' and tootin' section. And we're going to cover off like defense and prevention and threat hunting and research of these particular TTPs. So there's a few things that we need to lay up for you of core concepts so that all of this makes a bunch of sense. I like to start presentations like this with kind of the bottom line up front. By the end of the attacker section of this, what you're going to see on screen is a functional machine learning model that's still accurate. There's been no decrease in the accuracy of the model's predictions. But you see at the end of the video that it actually is executing malware in the background that the machine learning engineer or whatever can't actually see that this happened in the background without affecting the inferencing of the model.
Yeah, so if you start to look at machine learning things, you might be a little bit overwhelmed at the number of libraries and toolkits available to craft such a thing. So this is just a very brief overview of the different kinds of libraries and frameworks available. The TLDR is that most of them you can embed malware in. We're not really sure about safe tensors yet. It's a big question mark. And the popularity is all over the place for these things. PyTorch is far and away the most popular. Our talk today is focusing more on Keras and TensorFlow, which is also a very valid
Like there's still tons of models using that format as well. One thing to note about safe tensors is while we haven't like yet embedded malware in that, it's also like you can't just ask everybody to move to using safe tensors. It would be like asking every Python dev in the world to go learn like Java or something. Like it's a great thing to exist, but it's not necessarily like a Band-Aid to the problem.
It's often presented like if everyone just moved their models to safe tensors, then none of these attacks they're about to show you would happen. But it's obviously not realistic, and the primary consideration of a person who needs to deploy a machine learning model is, does it do the thing I need it to do, and like, can I deploy it? They don't really care about the other things, and if you as like a security team want to get in the middle of that and say you can't deploy any models unless it's safe tensors, then like good luck with that, because that's not going to happen. There's a QR code and an associated link underneath that will take you to basically a playbook that we have created that contains all these attacks and a bunch of other machine learning attacks. It is the only resource like that of its kind, and all the attacks that we're doing today, all the code and everything, you can find here and on some associated stuff you'll see at the end. So the primary place that people are fetching machine learning models from is called Hugging Face. It's a repository. It's like large file system GitHub. On screen, you can see the typical workflow of someone shopping for a machine learning model on there. What they do is say they need a tool to do entity extraction, like pull the names out of a document or something like that. And say, even if like to help them say like build a search engine or something like that. They will search for that term. They will click on the most popular thing that looks like it does the trick. They will skim the model card to confirm that, and then they will download that and run that. I've interviewed and spoken to a large number of ML engineers at multiple companies, and that is like the workflow, right? You just need thing, go get thing. So let's go over why you would want to do ML attacks over some other kind of attack. The key reason to do this is proximity to very important data. Now, I've been a red teamer for a long time now, but I am not very good at persistence or post-exploitation in general. So I've always been very attracted to supply chain attacks because it's usually a one and done thing. You drop in basically right where you need to be most of the time, and you very quickly get like awesome stuff, and you don't need to worry about messing around or like endpoints that have got EDRs on them and all kinds of things that can just like sometimes be a problem. So ML engineers and data scientists, they need incredible amounts of your business data to do their job, right? So that means that if you can get malware on their machines or the compute services that they're working with, you probably have all of the data. So now that you have direct access to that using the same sort of tooling and access that they have, the exfiltration process is as far as it takes as long as it takes to download stuff, really. It's pretty much immediate. Like the malware's in the environment and 5 minutes later, I'm downloading from your data lake. Like it's very, very fast. ML teams are optimized for rapid experimentation. Their projects are not often thought of as targets, and that is often because their services are not thought to be like production services. It's not like a public web app or something like that. It's an area for experimentation, but everything that you care about is in that environment. It really, really does have access to all of the data. Prior knowledge for all of this? None. Yeah. Neither of us, know very much really about ML at all, I would say. Like, we aren't data scientists or anything like that. You do not need to know math or be an ML expert to do offensive campaigns with machine learning. Like, this is definitely proof of that. If you can operate a C2, you can do all of these things. When you target an ML pipeline, you get very fast and efficient looting because the data pipelines are designed that way. You get code execution as a service. So models, machine learning models are not pure functions. They are programs. You think of them like software packages, binaries. They're full-blown applications, and you can put whatever you want in them, in most of them. You see heavy use of containers and virtual environments, oftentimes both of those things at once, which means detection efforts are like a real, just terrible, basically. Like these environments rarely have EDRs running in them, and even if they do a terrible job of seeing inside the container and seeing inside virtual environments. They're often like mounting the wrong disks and all kinds of things. The data access and the things that you do in this environment is very normal. So you're using services and accounts that are designed to do these things. So from an anomaly perspective, a machine learning engineer like doing big queries in Snowflake is sort of just like a Tuesday. Yeah. So the kind of people that are basically being targeted by these attacks is not just ML engineers. Increasingly, it's software engineers, and businesses are running ops teams that facilitate the serving of models inside the businesses. And all of these people can be victims of these attacks, as well as, of course, ML engineers and data scientists. There's a lot more people that can fall afoul of this attack than you would think. So let's talk about what are the features of the environments that make these swindles so easy. And I'll just go ahead and say that I've been using this attack on my employer, but also in bug bounties, taking inspiration from things like Alex Bersand's dependency confusion attacks. It is a successful technique, and it works on places where like you have a decent time horizon, where you're not on like a 1-week consulting gig where you like supply chain attacks are a bit hard. But you know, if you've got 3-4 weeks that you can spend on a thing, you can have more of a confidence that you'll get a detonation. What I love about Hugging Face is the interface and the design, the newness, the rush and hype around machine learning. I'm using all of those things to my advantage. Most namespaces that belong to businesses are not occupied on Hugging Face. You'd be surprised at the major companies, some of them pioneers in the ML space, that don't own their own namespaces on Hugging Face yet. The counts of repositories is very low. So you could have the most popular entity extractor on Hugging Face that you just made yesterday just by getting it to like 20 stars, right? Which it's very easy. There's no bot protection or anything like that that's going to make it hard for you to like pump up those rookie numbers. Even the font choices of the site, I think, create different problems. So like typo squats are a thing that work in the software dependency space, and so they work here too, because we're functionally dealing with just like a different kind of software dependency. Registering organizations claiming to be anyone comes down to just like typing the name in and pressing save. Then you go and you get their little favicon and their web address, and you upload their logo, and you just like make it look a little official. It takes a couple of minutes. And this is the most effective technique, is squatting the namespaces, making them look official. And then you have two choices. You can invite people from that company to join the repository that you administer, and you give them like write permissions, and they come in and then they start uploading like their data and making private repositories that you're the administrator of. But oftentimes what I noticed is that people would just go like, oh cool, my company's on Hugging Face, and then they just like request like, can I join? And you'd see like all kinds of people just being like, hey, can I come in? And I'm like, yeah, sure, write permissions, like have fun. We have a lot more research in this space to come that will come out soon. And so like the resources at the end, like keep an eye on them, because there's a lot of things of interest here to folks. So now we're gonna weaponize the models. Let's just step through like for a basic model format, what's involved in having one like run a C2 implant. Anything you want to hide in the model format, you can hide in there. Be as creative as you like. Some formats, as we mentioned at the beginning, are more resistant to like arbitrary code execution. But yeah, that doesn't really matter, right? Like if someone's joining the org that you own and then uploading models, you have right permission to that model too. Just change it. First of all, the next couple of slides have some code on them. It's not designed for you to like fully read it. I'm just going to step through the methodology so you can get a sense of how easy it is. But all the code is publicly available. There'll be links at the end to the repo so that you can just like get started with malicious models. So as I mentioned, the models are not pure functions. What that means is that you can put anything you like in them. So we're going to use TensorFlow models in Keras. And so the first thing that we need to do is we just start importing libraries like normal. After we get started, we're going to, in this example, put our malicious payload at the top of the model. When you're doing this for real, you tend to just like put it in the middle between some other like data imports or other like functions, so it's not just like the second line in the file. What we do is we populate an exec with our payload code, and we design it to be like a layer that sits, it's like an architectural layer on top of the model. And every time the model executes in training or inference, it will run this payload and do whatever I say. And so this is supposed to be used to adjust the weights of a model in experiments. It's not actually like ever really used to do full execs, but it supports it anyway. By defining it as like an OR-X and making it a pass-through layer, it means it won't mess with the math of the model. So like you can take an existing model, add this architectural layer, and the model will still function exactly as it's supposed to. Whether it's an image model or whatever kind of model, it will do exactly what it's supposed to do with no change in the accuracy. So this is what we put inside the exec. And functionally what it does is we call out to an external service, and we're just basically going to download a bin and then execute it. I don't leave my implants out on Hugging Face for a couple of reasons that Mary will explain. But most of all, I want some control over where my malware detonates, not just for blue team reasons, but because we're like hosting files that anyone could download. I don't really want to just like pop random people. So on the AWS side where we're serving our service, there's a little code out there that I just assigned from my recon, the different like CIDR blocks of my target, and then only people who are originating from those IPs get to download my file. So after that point, we just define the rest of the model, which is just like normal model things, the different inputs we want, the shapes, and then we add in any of the training set or things, just to make it look normal. There's been some changes recently to try and defend against this attack that are really, really hilarious. So you can see here that we use a model.save function, and then we just give the model a name, in this case, Open Diffusion. And this Open Diffusion model was actually recently in a threat actor report of malware on Hugging Face. And it was like, look, we found malware on Hugging Face. And I was like, hey, that's me. Yeah. What they did is they made it so that model.save saves in a file format that restricts arbitrary code execution. But what you can do is when you're defining model.save is you just adjust the file extension to another kind of machine learning model, and then you get the execution back again. So instead of saving it as like a .keras file or whatever, we just save it as like a .h5, and everything just keeps working, which is also a super normal looking format. Many LLMs actually save in the h5 file, and I know everyone freaking loves LLMs right now. Okay, so now we've made a malicious model. We need to deploy it. We need to get it in front of people's faces. When we host this on Hugging Face, here's a little video of like what the files and the file structure looks like. Because we have this malware being saved as a like architectural layer, when the model is compiled, it actually looks really normal from a file system. There's no like Python file here that you can go and read and see the downloader. It's all now in a serialized bytecode in one of the metadata files. So what you see here is like, it looks like a normal model to people.
Yeah, like especially to note, because Adrian's chosen to just put a downloader rather than the full implant in here, the serialized bytecode is like quite small, right? So it looks completely normal, this metadata file, but in fact, like you get a little something extra with it.
So of course at this point, you know, we've either infected a model that someone's given us, or we've put something out there and we're just hoping for the best. We get callbacks. And you can see in the white image, just an example that like the math is all still correct, the model still functions the way it's supposed to. And it's a very easy model for people to run. They don't have to do anything special, they just do what they do with all their models. One thing to note about this technique is your post-exploitation activities are going to be primarily happening in Linux. So C2 choice is going to be important. Many commodity C2s are not amazing on Linux, and they make it hard to do some of the things that you need to do, because you will likely need to go interactive in your sessions in the ML environments to do what you need to do. I find Sliver is really quite a decent commodity Linux service, and I tend to default to Sliver on Linux. I don't have any detection issues with that either currently. It works quite well. So what we've got now is an attacker who's hosting malware in a location in Hugging Face, and then we have businesses that are pulling those models and running them, and then phone home connections to C2 infrastructure. So it looks basically like the traditional model that you're familiar with, except that things are coming from Hugging Face. Okay, so now you're inside the environment, let's talk a little bit about like the looting activities and things that you might want to do in these environments that are a little different to normal. This section's pretty short, and the reason is that like the whole attack is short. Like none of this takes very long. You're hitting like top tier op objectives in pretty much immediately. So we've got some QR codes here. This will take you to some maps that have been created for enumerating out MLOps pipeline tooling and MLOps services, things that you need to like look for in the immediate vicinity. The first thing that you typically find is you may have just gotten a shell in a Jupyter notebook, which a lot of people like poo-poo that, and they think that's not like a great place to get put as an attacker, but it's actually a freaking awesome place to get put as an attacker, because it's a virtualized environment with like no detection engineering done on it usually at all. And you've got a lot of data scientists and people are saving API keys into shared notebooks. And now you can just grab, like, I think at 7 different businesses now, I've found Snowflake API keys in shared notebooks. So like you get a Snowflake API key, like that's really, really bad. It barely gets worse than that. You'll see big lists of customer data, Spark connectors for big data things, a lot of custom tooling, especially for like model stores. Model stores are like model registries, you know, like how you have a registry for Docker or a registry for dependencies.
I was just going to mention also, like, if you're talking about shared API keys, these notebooks are often like not committed frequently to source control. They're just shared among the team. So if you have like a traditional thing looking for creds in your source control, it's not really going to be looking in this area. So they're a little bit easier to get a hold of.
Yeah. So yeah, the QR code there, it's an Mmap script there from a fellow called Adeline Travers from Trailer Bits, he's made a mmap for looking for MLOps pipeline tools. Also directly adjacent to the file where you'll see that when you're on their website is another tool that just came out called Vega by Joseph Lucas, who works at NVIDIA. And it's a post-exploitation tool specifically for Jupyter that will help you like poison models and do all kinds of like fancy attacks that I think many people consider to be out of reach on like a red team engagement. But hopefully what you're about to see is that poisoning models is absolutely not out of reach for people who can operate a C2 but don't know any math. It's actually surprisingly easy. Because, you know, showing impact on an engagement is very, very important, sometimes you need like a top-line narrative. And what better way to do it than to poison an LLM? You know, you poison an LLM right now, your business, people are going to pay attention to what you just did. Because like you're hitting all the high notes of shit people care about right now. So there is a tool out there that is designed to edit the ground truths of compiled LLMs like Llama, any like internally hosted GPT models, your BERT models from Google, and so on. And easy edit can be used by anyone who can use a command line. It's super, super easy. The only caveat to using it is you need to go interactive, which means you need a decent shell. So easy edit can be pipped onto the box that you have access to, or you know, some other method if your C2 supports it. This is not a hacking tool. This is called an alignment tool. So it's designed to correct the behavior of LLMs that are not aligned to, say, like the business's principles. And it's very, very easy. So you can see on screen, this is what it looks like when you're steering Easy Edit around. You basically give it a prompt in plain English, say like, what's the capital of Australia? And then you give it what is currently the expected truth, and then you give it a target truth. And so now you're literally poisoning models. You're doing adversarial machine learning. Like, yeah, it's actually surprisingly easy. Model registries are a real like nascent area, I would say, still of like security infrastructure, but also just like from an ops perspective. Model registries tend to be like an open service with read-write from everywhere, actually. So you know, if you can just find your business's model registry in general, it will probably just be like open to whatever network it's on, like your prod network or whatever. It likely won't have any auth, because many of the model registry tools don't actually support auth at all. Many MLOps tools do not support auth at all. So during one of my usages of this, an ML engineer unusually executed it on his endpoint, his laptop, not on a server, which is unusual. And because I'm basically like downloading a binary from the internet and executing it, an EDR noticed this activity and it was flagged and sent to them for investigation. And they looked at what was happening and they saw that it was an ML engineer doing ML engineer things, and they marked it false positive. And just like the show continues, basically. Do you want to talk about some of the malware scanning on, oh no, we've got that later. Yeah.
All right, so Adrian started sharing this like attack vector last year internally, and my team at the time, Threat Intel, was working to start a research program starting to look into generating threat intelligence, not just consuming it. And so I thought, well, I could maybe do something in this space. And so I started to think about particularly what can be done to detect this and what can be done to identify it, and how prevalent is this out in the wild? Is it just Adrian doing it, or are there a bunch of people out here making these malicious models? So I started my work around August and September. I wanted to make it kind of a formalized project, so I set a scope and goals. I decided to scope it to just Keras models because that was the known, like, successful happy path at the time. And for goals, I really just wanted to understand the pervasiveness of these on Hugging Face and to identify ways to potentially catch people doing it. So I wanted to start off with a little bit about my background and my state of mind throughout this research project. So I started knowing nothing about machine learning. I don't have a math background. I don't have a computer science background. I don't know anything about ML. So my starting place was basically, isn't machine learning just like if then else kind of fancy? Like that's it, right? And I was a little bit terrified of it. So I was kind of started low. Then I went to, it's going to be great. I'm going to learn all the things. I'm going to learn everything about machine learning. It's going to be awesome. I'm going to hyperfixate on it. We're going to defeat it. Then I kind of went downhill as I started to realize how deep and broad this field is. There's a lot you can know about machine learning, and so my strategy to know everything was not successful, obviously. And from there, I kind of just came to peace and said, you know what, I'm just going to send it. I'm just going to YOLO it. We're just going to start looking at things and see what I can see, and I'll ask questions. It'll be fine. So my first lesson that I kind of learned is what I just said. Like, people get advanced degrees, people get PhDs in ML for a reason. So, like, don't worry about knowing everything, and it's okay to not know everything. The second thing is you're going to have questions that you might think are dumb, but they're not. And people working in the space also have these same questions. So just like with coding, like if you have a question about a model or a library or anything, like the answer will be on Stack Overflow somewhere. It's there, I promise. The third thing I kind of came to realize as I started to look at these like particular files and investigate them is that really machine learning models are like Shrek or like an onion. They just are layers of things, like layers of dictionaries and data all kind of compiled onto each other. So from like a forensics point of view, if you can find the right layer, you can find what you need. The other thing that came as kind of a surprise to me is how easy it is to execute the code that Adrian puts in these models. Like, it's quite easy. If you load an H5 with TensorFlow and Python, like in an IPython kind of interactive place, it's going to execute his code. Like, you don't need to train it. You don't need to do any inference. You just pop it in there into an object. TensorFlow's like, great, I'm so happy. So yeah, just like that's, don't do that like in an environment you care about unless you want it to be full of malware. So for this, I decided that I'm focusing on Keras models, and so there are two formats we kind of care about for that. There is the H5 format, which is just a big flat file that contains everything about the model. It contains the metadata, it contains training, model weights, the whole bit, just one giant, horrible, huge file. To note about H5 is that, sorry, it's so small. Sorry. No, it's fine. So H5 is like a really popular format to store model weights in. You can also store full models in it, but model weights are very common. Also, sorry, H5 format is not just machine learning models. It's actually a format to just store large data sets. So it's like they've kind of like forced, like Keras will use it, but it's not the only usage for it. So that can be kind of confusing if you're looking for information about H5 stuff. There's two ways to save a model into an H5 file. You can use, in Keras, you can use .save, or you can use .save pre-trained, but you also need a config file if you're using save pre-trained that tells it like where the data it needs is. For the other format, which is what Adrian was talking about with that like small metadata file, that's actually using protobuf serialization. That's like a standard format for it. They're consistently stored in this file that is always named keras metadata.pb. So that's like really nice. Because Keras needs that name, you can always grab it and find what you need there. They're tiny, and really they're just like nice little nested dictionaries, and arbitrary code is always in this like lambda layer. On the Keras website, it does tell you that, hey, these can be kind of unsafe, but it's definitely like put as an aside, kind of buried in the middle of a paragraph. So yeah. So as I started to think about, okay, well, I want to look at all of these models on Hugging Face, and I want to do it kind of in a way where I can get all the data in a good place and do my assessment and then kind of do my analysis in that kind of format. So basically, I chose to, I chose to use cloud because I like using cloud services. That's kind of where my home is. So I decided to create like a little isolated environment because ultimately we are probably executing malware. And this also helped me kind of track the cost and define my infrastructure in nice code so that I could tear down easily. I chose to put all of the data I was finding into DynamoDB so that I could have good metrics and look at numbers and do all of that at the end. So for my environment that I chose, I have a AWS space. I have some CDK defined components. Those are my DynamoDB table to hold my metadata. Then I have some IAM roles and some policies so that I can interact with that Dynamo. And then I made an EC2 instance profile and associated that with that IAM stuff so that I could just boot up an instance of an appropriate AMI and type, which is the Amazon machine learning, like deep learning AMI that has all of the libraries you need preloaded onto the box with my instance profile. And that meant that I could write to my data source and read from my database, and it was all just super easy. Using that EC2, I went ahead and basically my assessment process was, first I want to pull the Hugging Face REST API. I want to know about every Keras model that you have. Then once I had a list of all of those models that were my candidates, I went through, I downloaded the model from Hugging Face. I checked for the presence of a Lambda layer with a little bit of code, and I'll have that coming up here in a sec. And then I would update Dynamo with all of my metadata, like the size of the model format, when it was last updated, if it contains code. And if it did contain code, I would also extract that code and put that as binary into this Dynamo table. So I'm actually holding all of the arbitrary code in that nice little Dynamo table. And then finally, if the model is H5, I'll delete it from disk. And yeah, H5 are they're often extremely large. Many H5 files on Hugging Face are just model weights, which doesn't matter at all for this vector, basically. So I hate H5. For the scripting overview, this is for the assessment of those protobuf files. It's really quite simple. Really, you want to just start with importing TensorFlow, and you want to import this particular object, which is the saved metadata object. And that object has a function parse from string, and you can use that to parse out the metadata from this protobuf file and do a little read. From there, you just need to have the right dictionary key to see, hey, does it have a Lambda layer, and does the Lambda layer have a function? And then, yeah, we're chilling. You can just grab it. It's really quite simple. It's very fast. It's very consistent. It is very easy to use. The data structure is always the same. And for some reason, we're not doing this programmatically across all of Hugging Face. So that's a bit of a question mark, and definitely something we've been thinking a little bit about, how can we push that forward and make that start happening. For H5, it's very, very similar to the protobuf format. It's just that we're going to use H5Py instead of TensorFlow for this because of what I was mentioning earlier, that it's quite easy to execute H5 models unintentionally, and I don't want to do that. So with using H5Py, we can grab the attributes and the keys from these horrible dictionaries, and we'll look for the particular one we care about. So we're looking for model config and a list of attributes. And if it has that, then we know that we can pull out the layer that we care about. So a big thing is that with H5 files, if they are saved using that save_pretrained format with a config file, it's very difficult. This assessment won't work for that. It will not pull back data for you. The only way I've been able to find to get the code out of that is to execute it. So that's not great. That is an older way to save models. It was pre-2022 that folks were kind of doing that. Now the blessed path from Keras is to use just this .save function. And that's fine. We can interrogate that just fine. That will work with H5Py. It's beautiful. It's great. It's more consistent. And when I was looking at all of this, I was in Stack Overflow a lot about trying to find where is this stuff in this model I don't understand. And there is there's just like a ton of ML engineers asking like, how can I get my model to save in H5 format and use it on another machine? So like there's like it's just kind of like a fractured, messy place before this like move to the .save function, which I think is why Keras like implemented that. Yeah, so this assessment process is heavier weight and it's more annoying, but it works as well. Ultimately, I ended up looking at just over 11,000 files. That's not just models, it does include model weights as well. So it's kind of hard to know just from like the model card or the information if it's a weight or if it's a full model. So I just yanked everything and then looked to see, hey, what it doing basically. I ended up assessing 893 protobuf serialized models and 403 H5 models. And that 403 number are ones that I was able to like get the configuration for and look at. So they're the ones like saved with the method that's happy to assess. So interpreting the results. Basically, after I had checked all the models, I went ahead and scanned my Dynamo table and I looked for, okay, tell me about all the models that we found that have code in them. And then go ahead and give me all of that code so that I can take a big look. Then, like the code to analyze, as you can see, is like really complex. Basically, you just import dis and disassemble it. It's not hard. There's no IDA, there's no redair, there's nothing difficult. You can just use plain old dis and decode it and take a big look. So it's great. On the bottom left is some code we found, which is a security researcher friend who is trying to pop calc in his execution layer, which is wonderful because these are almost never going to run in Windows. But he's like, let's pop calc. I love it. It's great. But the thing to note from this that I found is that when I started, I was really worried because I'm like, I'm going to have all of this code and I'm going to need to figure out like how do I detect badness versus goodness. Like there's this like kind of worry that I had about I'm going to have to write some like really killer YAR rules and I'm not going to be good at it. But in fact, if you just take a look at the code, it's very easy to see what's legitimate and what's probably suspicious and what's definitely a threat actor, because the legitimate code in these like execution layers is very small and very simple. It's like, I'm going to take X and I'm going to add 1 to it, or I'm going to do a little tiny adjustment to a photo as it's being processed. So it's the stuff like Adrian's doing is not normal. Like you don't reach out to AWS and download a thing in this layer. That's not the purpose of this layer. So yeah. The other thing that I noticed as I started to look at my results is that a model containing any code execution layer is very unusual. They're very unusual. There's just not many of them. And even more unusual is complex code, like what Adrian is doing that he's like, oh, so simple, like that's complex in this space. So like that's even more rare. It just doesn't happen. So yeah, so here's like kind of like the main results, which is that for the model format that we looked at the time I looked at, there's just really not that much code in these models on Hugging Face, and there's really even less malware. We were able to cleanly like pull out 54 code layers and take a look at them. 21 of those were easy to disassemble with this. The other ones, you couldn't really do that. It didn't give back nice results, but even with those, you can just decode using base 64 decode it and run strings across it, as all of my reverse engineering friends know, like that's the first thing you do, you just run strings. And that would give you like a pretty good indication a lot of times of what it's doing. For example, if I'm pulling out a string that's like a local file path on somebody's machine to a Python script, that's probably like the dev had some local script that was doing a thing. But do I think that's great? Maybe not. Is it gonna work in my environment? No, I probably don't care. So, these kind of things. The only malware that we did find was the security researcher I mentioned on the previous slide. And if you go to his actual repo, it's lovely. It's like, oh, don't execute it, it's bad, it's naughty. So he's doing the right kind of things. For caveats, this assessment was done last year in the fall, and so it's point in time. It hasn't been redone since. Is for a particular model format, it's very scoped. And like this is kind of greenfield space in a way, like Adrian is starting to talk about it and people are going to become aware of it. And as we do that, I think there will be a lot more code in these kind of models. But right now, for this format, it's okay. We also have really good intel that PyTorch space is like a burning dumpster fire, and there's a lot of malware in pickles in that space. And so that's like coming soon TM, very excited to go play with nasty stuff over there.
One thing to note about the PyTorch models is the general method of messing with a PyTorch model affects the accuracy of the model. So there are like detection opportunities there just from an ML engineer like running that and getting popped, but also being like something's very wrong because the results are all jacked up.
So for our last section, I wanted to talk about basically defense and protection and some like mitigations that we can start to think about in this space. And that's our sheriff. He's the possum sheriff. You can tell he's on the blue team because he's wearing a blue hat. So if we're thinking about this kind of from your org perspective, where would be a good place to start to do some analysis over these models? One option is certainly to do some static analysis, like some code scanning. Where can we do that? It makes sense to put that in kind of the ingestion place and say, for all the models you want to ingest, run it through this thing. Then you don't want to create too much friction for the devs. If you create too much friction, then they're not going to use your service to pull the model, so kind of spicy there. But it is an option. I think this is something that if you are working for a company that uses machine learning and should be thinking about like where in this pipeline can we layer on security, because the environment is built, there's no secure by design now, right? We have to kind of bolt stuff on at some point. So there are some great tools available. One thing that you can use is a tool called Model Scan. It's available. It's like I think you can just pip it, I'm pretty sure. And it's from a company called Protect AI. It does a really nice job of scanning TensorFlow and Keras and PyTorch models. It wasn't super effective for me because it would not pull out the code. It'll tell me that a model has a code execution layer. Say, hey, maybe there's some danger here, but it wouldn't tell me what the code is. And I'm like, well, this is useless. And I want to see the malware. So it's a great tool, but it wasn't great for my needs. Yara, which I'm sure everybody knows, would be, I think, a really lovely tool to use if you're able to extract that code layer to be able to see, look for things doing bad things. It shouldn't be execing, it shouldn't be evaling, it shouldn't probably be downloading stuff from AWS. So you could pull the code layer and then run Yara across that and see what it's doing. SemGrep is a tool that I haven't used, but some people that I trust are obsessed with it. And so it's basically just semantic grep for code, and it would certainly be useful here in this space as well, because you could also write some simple rules there to look for these kind of things that we're caring about. One last kind of different tool, which is not anything to do with security, is H5 viewers are really awesome. So if you are wanting to start to look at H5 files, to learn about them, or from a DFIR perspective, think about just grabbing an H5 viewer that will allow you to visualize all of the layers in the file and kind of hunt around and see where things are. There's one that you can build from Java, and then there's one that's actually on a website. You can just upload your H5 and take a look, which is kind of funny because H5s are huge, but follow your heart. One thing that started to give me a lot of heartburn as I was thinking about this and doing this project is just that maybe the biggest risk is not that there's a difficult way to assess these in the pipeline, but the scarier part is that maybe our incident responders are not super well equipped to have an incident in this space. What's our tooling like? What's our gaps like? If a container in this environment is popped, are we going to be able to scoot it to a happy place in Kubernetes and keep it forever? Probably not. You're probably not equipped to do that. The container's probably going to get blown away, and you're going to be blind to what happened. So that's kind of terrifying. And so for me, it feels like as incident responders, which I identify as, even though I'm not right now, we just need to take the time to learn about the ML environment, and that absolutely does not require machine learning knowledge. You do not need to have any machine learning knowledge to know about what that environment looks like and what normal looks like in that environment and what your devs are doing day to day in that environment. And once you know that, you can identify okay, if I were to have malware here, this is what I would do, this is how I would reply. Because we just, machine learning adoption is just, it's on this kind of trajectory, and it's not gonna stop, I don't think. And so we kind of need to catch up. And that's being prepared for an environment here, and also I think there's some like exciting opportunities to build some tooling around in this space for DFIR as well. So one thing that we can do is, like, you talk about malware, and the first thing my manager asked me is, well, are we going to sandbox it? Let's sandbox it. I'm like, you can't sandbox an ML model. Like, if you give this thing to Cuckoo, it's going to laugh at you, like it doesn't know what to do, right? And moreover, it just wouldn't really make sense to sandbox these things. Like for H5 files, they're huge. It's not going to work well. The virtual environment you have for your sandbox is not going to have the right kind of hardware or libraries available to assess these things. But that doesn't mean that we can't like do malware analysis over it, right? Like we love to double click malware, or at least I do. And so why can't we do this here? So I think basically the point of this is to just take like this malware analysis idea of like behavioral analysis and apply it to machine learning. So create your nice little isolated environment in AWS or cloud provider of your choice. Set it up with some nice telemetry gathering stuff so that you can see what's going on, execute the malware and see what happened. Now, of course, Adrian said that if I'm not in the right IP space, it won't download. So you need to take some considerations into that. Like, can you manipulate that so that the model thinks it's in the right IP space, those kind of things. So it is, kind of figuring that out. So in short, like, sandboxing large scale for these things, I don't think is probably ever going to make sense. But if you have an incident or you have a suspect model, yeah, like, let's do it. It's a great path. Yeah, so I think we're kind of both going to talk through this, but current state, what has been done, I just have like some little screenshots here over some like little quiet warnings that everybody likes to give you about the danger of serializing code and how machine learning models serialize code and how maybe there's danger afoot. But it's always kind of an aside on a website, buried in a paragraph somewhere, or Hugging Face will be like, we're scanning all the pickles, it's fine, but it's not fine. And so that's kind of the current state, is like, people know it's a problem, but maybe it's not being super well addressed yet. Model scan is great, like I mentioned earlier. Protect AI also just published a blog with some findings over there, like threat hunt across Hugging Face, which is what found Adrian. So that's a cool blog if you want to go read that. And then of course, safe tensors and ONNX are also like things that come from the model development standpoint are being done to try to make models more resistant to these kind of code execution pathways. So.
Yeah, so beyond improving scanning and understanding on Hugging Face, we have like a general problem with model cards. The model card is effectively the README on the model file. Sometimes they're a formal paper, sometimes they're like one sentence, and often they don't exist. There are 3 competing ideas right now of an open standard of what a model card should have and should look like. And there's actually not a lot of security consideration being put into like what data should we collect about all models to make Mary's life easier. So we've been working a little bit to try and like push PRs into these things of just like, hey, like security's life would be a lot easier if you would collect this kind of information about every model in a standardized format, like in JSON or YAML or whatever. And that would be really, really helpful. But things like malware scanning on Hugging Face, like you can't trust it. They're using Hugging Face. They're using ClamAV, which is a very good for the price that you pay for it, and which is free. And it tends to cap out at about 4 gig file limit, but most ML models blow past that number quite trivially, right? Like the average size of an ML model is probably like 10 gigs, 12 gigs. Yeah. So.
More.
More. Yeah. So the first link we have here is to a playbook that has a bunch of different ML attacks on it, some adversarial attacks. I do some adversarial ML research as well, so there's like techniques being tracked there, and it's only things that work that I have tested in every category. In the supply chain attacks, for instance, there's methods of poisoning internet scale data sets, which sounds really complicated, but it's really not. That's a talk for another time. And then the bottom link is basically like a narrative write-up of what we just spoke about, and also has links to the like all the code, so you can go double-click on my malware if it pleases you. Yeah.
I did want to mention my GitHub is here and it's empty. I'm just waiting for my employer to bless putting out the code, but they have like a very good track record of that, so I expect that it'll be up like within like a week or two. So.
So the offensive code is up, but the defensive code needs a little more
It's
time.
typical. I'm sorry. I'm sorry.
Okay. All right. A couple of acknowledgements here of colleagues, past and present, and people from the internet. We love you. Thank you for your help. Yeah, let's take some questions. We've got a bit of time for questions. Yeah, there's a Discord with questions. Let's go see what we got there.
We're free. No questions.
We're free, no questions. Okay. Okay.
Did you contact any of the companies that you found being spoofed on Hugging Face, or is there a way for them to like get rid of those?
Yeah, the question was, have any of the companies that have been spoofed on Hugging Face been contacted? All the ones that I spoofed have been contacted, typically through their bug bounty programs, because you can submit it like a dependency confusion attack as an RCE, basically. So like it's a good finding to submit to someone. Some of the others, yeah, we've been like working a little with Hugging Face. We need to work more with them on like pulling out these things and getting them taken down, but it's a resource intensive thing, and Hugging Face has a very small team. It's quite a small company, and I think like all this ML stuff just kind of like blew up on their platform kind of overnight. And so yeah, they're coming along, but there's plenty of ways to like use their service for bad things. Yeah, thank you for the question. Okay, great. That's it. Oh, one over here. Hey. No, thank you.
So, is there anywhere else in TensorFlow or Keras, like I know you said that you can insert code into the layers, or is there anywhere else you can insert code into that would run at that level?
Yes. So there is. Oh, I got the tingles. There's a very, very interesting technique that is working, where you basically insert tiny bits of data in the trailing end of a neuron, and in each layer. So like machine learning model is made up of like, say like tens of thousands or millions of neurons, and if you actually just like interdict one neuron, it's like a long string of data, right? But the end part of it is usually junk. So what you can do is you can replace the end part in say like thousands of neurons, and then extract them out and rebuild them during inference. And you can get code execution through that technique. So it's kind of like steganography for ML with code execution at the end. Another technique but that will slightly affect the accuracy of the model, but usually in like fractions of a %. Another way that's really effective is to just like, models are often served as containers, so just stick the malware in the container. Yeah, that site that's listed there actually has details. Some details are beginning to fall into place on there that I'm doing on the neuron-based attack. Yeah, this is freaking awesome. It's a cool attack.
It's not awesome.
It's not awesome. Yeah. Yeah. Okay. That spark anyone have an additional question before we wrap up? Okay, well, thank you for your attention, everyone.
Thanks, guys.
Yep.
Yeah, so that's kind of the idea of this talk, is I want to give you guys a lot of lessons learned, a lot of things that I think are just some of the most valuable things. If you're looking to get started, or if you're like in that mid-journey where you're in incident response, you're kind of looking to establish yourself as an expert. Even if you actually have a lot of experience in incident response, I think you might even have to learn some stuff today. But let me just give you a little background about myself. So I'm married. I have a beautiful wife. I actually have 6 kids, okay? That's not a typo. 1, 2, 3, 4, 5, 6. 2 of them are here, actually. So Anna Marie and Gabriel, they're CactusCon kids officially this year. As I mentioned, I have 3 donkeys. We have, a year and a half ago, I was so sort of tired of always being up to my eyeballs in technology, working all the time, that we bought a 16-acre property so I could be in the middle of nowhere, just unbothered and enjoy nature as much as possible. We got chickens and some animals and stuff like that, and we got donkeys. All right, I'll tell you really quickly why we got donkeys. I never knew I was going to need a donkey. Never in my life thought that a donkey would be a necessary thing. And you get out to a ranch, and I live in Texas. I live in Austin, the Austin area. And we have a lot of coyotes, okay? So we hear them every night howling. Donkeys, believe it or not, are the best livestock guardians. They take care of coyotes, right? They will destroy coyotes. They can kill hyenas. Go look it up on YouTube. You'll see them just taking these dudes out. And it's amazing because they're hilarious. Donkeys are super intelligent. They are very affectionate. They love humans. They're like big dogs. So not like horses. They actually want to be around you. They like affection. But when the time comes to protect their family and their livestock, they jump into action. They know exactly what to do. You know, they don't back down. So in a lot of ways, donkeys are kind of my spirit animal when it comes to cybersecurity. So I actually, cyberdonkey.net is my site, which, by the way, I almost forgot to mention. For anybody, especially in the back, okay, there's going to be some things. I'll zoom in, right, and I'm going to try not to, make you guys throw up by doing that too much. But I will try to zoom in. If you want, the slides are already up there, okay? So, in fact, this entire talk that was recorded today right now is already there. No, I'm kidding, it's not. The slides are already on the website, so cyberdonkey.net. If you go there, you can download the slides. You can go follow along with me. That way, if there's anything that you want to zoom in on, any small text or what have you, that I forget to zoom in on, you can do that throughout the talk, all right? So I'm the director of cybersecurity at a company called Waypoint Analytical. I work with some really great people there, and just, great leadership. Have a lot of love for the people I work with. I am also a certified SANS instructor, so I teach for the SANS Institute, Forensics 508, which is Advanced Threat Hunting and Incident Response. I also was formerly in the Air National Guard, the Texas Air National Guard, which, if you didn't know that, every state has an Air Force and an Army and stuff. So you have the active duty components that are national, and then you have the components that are state level that are run by the governors. So I joined the Air Force in Texas, and I was enlisted. That's where I got my start in cybersecurity, 2011 or something like that. Then I moved into the Coast Guard, all right? I didn't even know, you guys even know, if anybody's from Arizona, you don't even know about the Coast Guard, right? There's no water anywhere. So the Coast Guard, actually, I didn't know either in San Antonio, because there's also no water around there, okay? So the Coast Guard was a lot of fun because the Coast Guard has this, they have a life-saving mission, but they also have authority over all the ports and waterways and stuff like that. So you have a lot of ICS and SCADA type of mission. And so with the Coast Guard, I was helping to build the SOC and IR capabilities. In fact, I was the first named cyber protection team member of the Coast Guard, the CPT. The Coast Guard sent me to DHS for 2 years, and for 2 years at the end of my Coast Guard reign, I was with DHS, and all I did was threat hunting and incident response. So what used to be the US CERT team then was, at the weird time that I was there, the NKIC and Hunt and incident response team, or HURT, turned into now CISA, the Cybersecurity and Infrastructure Security Agency. So many acronyms. All right, so anyway, right before it became CISA, all we did was we had this small deployable team for 2 years. We just go out to water utility, energy plants, and so on and so forth, doing threat hunting and incident response, and that was it. Then I moved on to a company called Recon InfoSec that I recently departed from, but was working with some fantastic people. If anybody's familiar with OpenSOC, OpenSOC is, Recon InfoSec is responsible for OpenSOC at DEF CON. Anyway, so that's been my journey. Now I'm teaching and doing all kinds of stuff and having fun and coming to things like this to, again, help people in their journey. I also am I'm Catholic. I'm somebody who I have a great love for faith and philosophy and stuff, and so I actually even wrote a book on all that stuff. But dad jokes and parenting, okay, this is my reign. Having a lot of kids makes me better in cybersecurity, as you can imagine, right? Lots of chaos, lots of incidents, lots of threats I gotta hunt out. Anyway, so I'm a 90s kid. A lot of my references are late 90s, early 2000s, okay? So sorry, bear with me, Google it. You don't know what I'm talking about. But anyway, as you can see, boys to cactus men will tell you that it's so hard, okay, to get started in incident response. And the reason for that, man, it's so funny. Like 10, 15 years ago, that joke would have killed. It's hard because the reality is that this is a very complex environment, right? This is so much. You got to know, like an incident response, you just feel like you have to know everything about everything. Windows and Linux and Mac, and then there's networking, and there's the endpoint stuff, the endpoint forensics. There's so much out there. And I think the other part of it is that there's a lot of bad advice too, right? There's a lot of junk. There's a lot of tools. There's so many different tools. And there's a lot of people that tools and things that promise to kind of make everything easier. They hide certain things. Like there's a lot of people that get a bad start in incident response, and I think that's part of why, even after years and years of doing it, there's a lot of people who feel like I still don't know how to do it. I still don't feel like I can actually do this job, even though I've been hired as the incident response guy and I've been there for 3 or 4 years at this company. And I still don't know how to do it because I haven't had a major incident. If you did have a major incident, they might get rid of you, okay? If you have a major incident, that's the only way you get to learn how to actually do this stuff, and so that's the problem, right? So you have this weird kind of thing that, like, if you're a consultant, if you work for organizations like Mandiant and CrowdStrike and stuff, then you get to do incident response, and you're not going to get fired because you get paid to do that from the organization that's having the IR. But if you work for a company in a SOC or doing IR, they don't want you doing IR, right? Like, it's kind of a weird backwards thing. But the good news is that, like, while there's great training out there that's very expensive, there are tons of free resources now, like tons. When I started 15 years ago, when I was trying to figure this stuff out, there's a lot of free stuff, but most of that was like malware, but now, like, there's so many free tools, there's so many free resource training, like it's wild. Okay, so what I'm going to do is try to condense a lot of this stuff into I'm probably talking fast because I'm like, there's so much to talk about. I'm like, hope I get through all of it. Okay, so let me just hit you up with really quick the incident response process. If you've not seen this, it's something that SANS developed a long time ago. Sometimes it's called the PICROL process: preparation, identification, scoping, containment, eradication, recovery, lessons learned. We're going to stick with the first two, okay? The first two of this process are the most important for an incident responder, all right? This is where you either do the job and you have something to tell the execs, or you don't do the job because they forced you to get into eradication and recovery right away, right? That weird tension of, like, let's hurry up and get everything back online, let's fix it, let's whatever, is rides against the idea that, yeah, but I need to know how bad it is. If you think about this in terms of somebody gets hurt, like has an injury or car crash or something like that. Let's just say that they have a little bit of blood on their arm or a little cut or whatever. You bring them to the hospital and they say, let's just amputate the arm. Let's get this guy back on his way. We need to get him out in 30 minutes, you know what I mean? That wouldn't work at a hospital, right? Well, sometimes I know that probably does, that kind of weird thing does happen, but it wouldn't work. For whatever reason, that's something that we haven't gotten companies to understand yet, right? Like, we first need to understand how bad it is. If I don't know how bad it is, I don't know what to tell you about what to do about it, right? That's where we're going to live today. That's where most of the resources I'm going to give you are going to be centered around, is like just figuring out how bad it is. Because your job is going to be to figure out how bad it is fast, okay? That's if you are either very good at this job because you can effectively and efficiently quickly get to giving answers, maybe not the entire answer, but answers that are going to help them understand how bad it is, right? Because then again, like, now we need to start figuring out, well, at what point do we make decisions? A lot of that stuff happens before the incident, okay? So this is the preparation stuff. So the ability to identify and scope an incident happens before. You either have a security camera that when the police get called and somebody was killed or something happens, right? They get to the scene. They either have a security camera that lays it all out, that says, okay, let me look at the video. Okay, I can see 2 hours ago, guy got hit over the head, person was wearing a hoodie, ran off into the east direction. Like, either I have that stuff and I can start answering questions, or I got nothing because I didn't put it in place beforehand, right? So anyway, that's where we're going to live. Let me give you what my, not me, the Cyber Donkey's sanity check, all right? Now, this is my personal kind of sanity check. This works for beginners. This works for experts, okay? Anytime that you are doing any kind of SOC analysis, initial investigations, or you're working an IR or what have you, there are 3 things that I kind of lean on. The first one is, at any point, being able to answer the question, what do I know? Like, what do I really know? What am I confident about? Not what do I think, but what do I know, okay? What do I know, and what can I demonstrate with evidence that I know? The second thing is, what do I not know, right? Like, I need to know what I don't know. And again, I might think something, but if I don't know, then I need to really be able to define that as, this is something I don't know, all right? I know how they got in. I don't know how they moved around. Or I know that they were here at some point, but I don't know what they were doing before that. I don't know how they got in, whatever it is, right? You lay out these questions. And then the next thing is like, so what I don't know is a set of questions, all right? Your effectiveness in incident response is the ability to define narrow questions. Either I have a good question that I can answer like quickly, or I have a very vague question that's going to get me spinning my wheels for a very long time. I'll give you an example. So if my question is something like, do I have an admin logging on yesterday, externally, or let's say, do I have anybody leveraging RDP from any system to this system at any point yesterday from 4 to 6 p.m. or something like that, okay? That's a question I can answer by going and looking at something very specific. I can answer that question, right? Did something bad happen last week? That's a really hard question. That's a bad question to try to, you're going to spin your wheels, right? Like there's tons of logs. I don't know what I'm looking for. How do I know if I found it? So I need to know what I don't know, but then I'm going to develop some questions to help me figure out what it is that is going to fill that gap. And that's that third thing, okay? Is developing questions that will make my next part of the journey fruitful, all right? So what I don't know might be, what commands they ran. Now that third question, what do I need in order to be able to fill a gap or to answer the questions of the things that I don't know? It might be that I don't have the right visibility, okay? Maybe I don't have command line auditing. So when I'm trying to answer things for executives, this is the stuff that's going to help me to make sense of it, okay? Here's what I know. I know that they definitely executed something, some malware yesterday at 6 p.m., so on and so forth, okay? What I don't know is, was this the first system in the whole chain of events? What I don't know is how they got to executing that or whatever it is, right? Because what I'm missing is command line auditing. You see what I'm saying? Like that will always that'll always anchor you in a place of sort of comfort and sustainability. As soon as I get away from that and I'm just looking for bad stuff, I'm clicking around, like let me go look for execution stuff, let me go look at event logs, let me go look at this, like you're never gonna find anything unless you know very specifically what you're looking for, okay? So again, you think of it like a detective has to have a string that they're always pulling on. Okay, so that brings me to the next thing, which is DMXDR, all right? Just making a surprise. Yeah, all right. Yeah, that's it. I can always tell who the folks are that are, let's say, over 25 or so by the laughs, the moderate laughs in the audience. So DMXDR, where my log's at, a very famous song from DMXDR, right? This is the thing that's like, okay, well, I can be effective if I have the right type of stuff. All right. The problem is that Windows doesn't come with very good security event logs, okay? Or security logs, let's just say. Windows doesn't really have that built in, which kind of sucks because a lot of times for consultants, you're coming into organizations where they don't have anything. They didn't put anything in place beforehand, right? So there's no security camera, and when you come into a crime scene, there's no security camera, you're resorting to now clunky forensics. No security camera means I got to take blood samples and DNA samples and hair follicles, like I'm crawling on the ground looking for a little piece of hair or something like that. Then I got to send that stuff off to the lab. It's going to take me 2 or 3 weeks or 6 weeks to get anything back, to get any answers. And even then, I'm making assumptions. That person was there I don't know if they were there during the crime scene, or during the crime. I don't know if they were the one that committed the crime. I just know that they were probably there at some point, right? So like, this becomes the rub, is that, you know, part of it is like you need to know how to do some clunky forensics, but then you need to evangelize and figure out how to, especially at your own organization, get the stuff in there that's going to help you to answer those questions, you know, quickly. MITRE ATT&CK, you guys are probably all very familiar with MITRE ATT&CK. This is something that can help you to figure out what do I have visibility over and what do I not have visibility over. So you can drive into any of these things and say, all right, you know, like persistence, execution, lateral movement, or what have you. What are the techniques that are out there? MITRE ATT&CK goes all over the place, right? Like who's doing these things? You know, is it Deep Panda? Is it Black Energy? So on and so forth. What tools are they using? WMI, PowerShell, so on and so forth. But the reality is that for what we're talking about is I need to know what here do I have visibility, like could I even detect something? Again, I go to that command line auditing thing. A lot of people don't have command line auditing in their organization. So if you go to a technique and it says, you know, part of the detection, because MITRE will also tell you, like, here's some detection techniques. Part of the detection techniques is, you know, these commands that might get run. Well, if I don't have command line auditing, I can't hunt for those things. You know what I mean? So you can go to MITRE to look for ideas for things that you may or may not have visibility over. Microsoft actually has really gotten so much better in documentation and just security, period, in all kinds of different ways. But the Microsoft website actually now has a list of all the event logs, and even it'll tell you what the event log is for. It'll also tell you if it's enabled or, you know, not enabled by default. Again, you'll find out that sucks that there's a lot of things that are not enabled by default that if they were, it would be so much more helpful. But then one of the things that it tells you is why you might actually want to enable this or include it or look for it. Like, does it have a security nexus or not, right? Like, it might be like, nah, there's nothing really known that, you know, is useful for security. But if it is, it'll tell you. So here's an example of something that very famous, most people know about, 4624s. Those are successful logons. So it'll tell you, you know, breakdown of what that looks like. Then, you know, there's logon types. I know somebody logged on successfully. How do they log on? They use RDP. They log on over, you know, network, SMB. Anyway, so these are really good resources. But another really good one is the SANS Hunt Evil poster. So this is one where so like, man, there's so many good things going on here. But one of the things is on the right-hand side, it shows you how to track lateral movement for mostly living off the land techniques. Okay, so if you dig into that. You look at lateral movement artifacts that are on the source and on the destination systems when RDP is used for lateral movement, for example. We'll include things like 4624s, of course, you know, successful logon of a particular type. A type 10 is RDP. Then you have other actually custom event logs. You have shimcache and prefetch, which we'll talk about in a second. Things that'll show up. The question is, again, do I have visibility over this stuff? Do I know what this is? Do I know how to go grab it? Okay. Do I know the particulars, the nuances of these artifacts like shimcache? Do I know that shimcache only writes to disk? There's a shimcache on disk. There's one in memory. It only writes to the one on disk on a shutdown or a restart. So if I'm looking at shimcache and I'm only searching over disk, but I'm looking at a server that hasn't been restarted in 2 or 4 months, I'm missing some stuff, right? Like I need to know that kind of stuff. And so what I can do is I can go to these things, these resources, and look for ideas, right? What is shimcache? What is, you know, what are the logon types of 4624s? Like, do I know how to go grab these? Do I have tools that would help me to because you can't just, some of these you can't just go grab, like you can't go grab a prefetch file and just start looking at it. You need tools to do that. We'll talk about that in a little bit. And then again, you know, there's services, there's WMI, there's PowerShell logs, all of these things. Like, this poster will introduce you to a ton of valuable things. If you don't know they exist, get familiar with them, right? Whoops. Okay, so, oh, by the way, the slides that are already on the website, on cyberdonkey.net, every single thing that I show up here is a link to the resources as well. So, like, these pictures are also linked to the poster, so you can go grab the poster. This is linked to an article so that you can go and check out, like, if I don't have PowerShell logging on, and it's horrible, right? That there's a lot of PowerShell logging that's not enabled by default in Windows. wild. It just is what it is, okay? So if you have not enabled these, you need to go, like, you're going to want PowerShell logs, okay? You're going to want these, you're going to need them. You got to enable them before you have an incident. Okay, so here's a great article that will kind of walk you through what's available out there and how to enable them. And this is an example of something that PowerShell has called transcript logs. PowerShell transcript logs are phenomenal. PowerShell transcript logs will show you, kind of like if you're familiar with Linux, standard in, standard out, it'll show you what the user typed into a PowerShell terminal, and it's based on the user, okay? It tracks these as text files for every user. It'll create a text file with what the user typed in, but also the output that they got back. So what they saw. If they screwed something up and they made a mistake and they got an error, you'll see the error. If they ran something and the executable gives feedback to say like, hey, malware successfully implanted, you'll see that in the PowerShell transcript, right? As long as they're using PowerShell. So here's an example of a lot of the stuff before this is just meta information. So the transcript started. By the way, if you want to try this, test it out on your own system, open up PowerShell, type start-transcript, and then do whatever you want. It'll actually tell you where it's saving that file to, and then you can go look at the file. It's a great way to just kind of play around and get used to it. Okay, so I did a couple of things. I don't know what I did. I don't remember exactly, but I did a few things that caused an error. Here you can see that it actually is telling you that like, oh, okay, I don't think I did this on purpose. I think I was actually, and then I was like, I'll capture it because, cool, it's an error. I tried to run a tool out of the directory that it was not in. There was an error. And then eventually I ran it, and it successfully runs at the bottom, and you can see that again, like, this is the cool feedback. Like, there's really not many places where you get the back and forth interactions of an attacker, okay? This is the super, super valuable thing. Dang, there's no way that we're already at 3:54. I'm ridiculous. I swear I was talking like super fast. I think too many jokes. Okay, so the red poster from SANS is also one that will introduce you to a lot of artifacts that are used in forensics. Things like shim cache, like I mentioned before, and prefetch. Shell bags that shows you what folders people open. Prefetch is one of those. This is one of the best artifacts when you don't have it elsewhere. That will show you when something is executed. A prefetch file for the thing that gets executed is actually recorded. All right. So this is great for evidence of execution. And this is just an example of opening, using a tool called PE command, written by a guy named Eric Zimmerman. It's a free tool, by the way. And I'm looking at the prefetch for PowerShell. So this will show me a lot of the things that PowerShell loaded, where it was executed from. So if I'm dealing with malware, this will tell me, and malware's gone. If I still have the prefetch file, this will tell me where the thing was executed from. It'll also give me, what DLLs and stuff were loaded. It's all kinds of really valuable stuff, again, during an IR. The reality is that Sysmon is, if you can implement Sysmon, a much, much better option for things like evidence of execution and all kinds of things, actually, rather. Sysmon is a Microsoft tool, okay? Signed by Microsoft, developed by Microsoft guys, but it doesn't come with Microsoft, or it doesn't come with Windows, right? Sucks. You got to go download it. You have to install it. But it does all kinds of things like logging process creation. So every time a thing is executed, logged. Every time a file is created, logged. It also logs deleted files now. It logs DLL injection or network connections, and so from a process. So opening up a socket, process opens a connection, goes out to the internet, or receives a connection, incoming. Now that's so valuable, okay? That's so valuable to know what program, what process is actually responsible for that network connection. I'm not talking about stuff at the perimeter. I'm not talking about firewall. I'm talking about at the endpoint on the system, notepad.exe. I can see it opening a connection, all right, going out. Right? That's not good. Probably not good, right, unless somebody's doing something just goofy. So Sysmon has its own event IDs. It's its own custom event log that has, again, a whole host of really, really valuable artifacts. And the problem with Sysmon, unfortunately, is that it could be a beast. If you let it, just go Super Saiyan, it could destroy the whole, enterprise. All right, I'm kidding. No, it's a lot to configure, manage, and if you let's say do something wrong, you can have it overload some systems, and it could end up not being good. So this is where you're like, you got to partner with an engineer, because like I might not have the let's say qualities and capabilities to set up, maintain, configure, and whatever. I just know how to use it. This is where you got to be careful. So I'm just giving you guys a little bit of caution there. Don't go to an enterprise environment in your production environment and just start rolling out Sysmon and like getting everything. Instead, I got some really good resources for you. A guy named Carlos, who has a whole list of videos on how to kind of get this set up, how to manage it, and do that in a way that's, again, appropriate and effective. Also, a guy named Olaf Hartong, who makes a modular Sysmon config. These are great places to start, okay? These are great places to start small and then eventually go from there. And then here's another totally different, so somebody who has a little bit more expertise. JONMON is a tool that allows you to kind of play with creating your own telemetry. It's like creating your own Sysmon in a sense, all right? I'm going to roll through a couple of these because I'm out of time here in a couple of minutes. So the last thing you need is analysis, okay? You just need one, so you need analysis. You know what I'm saying? All right, analysis. All right, to analyze all of these things, there's a whole host of phenomenal resources and tools. This is a list of event logs that have just nothing but attacks, okay? So part of the problem with us who live in an area where we live in an organization where we don't get attacked all the time, we don't get to see what it looks like, we don't know what it really looks like. This is just a whole ton of event logs that have a bunch of attacks in them, so you can see exactly what it might look like in an event log let's say again for persistence or credential dumping, that's not a word, it could be, credential dumping and so on and so forth, right? It's a great resource. Here's an article, I'm going to brush through these. Here's an article that actually uses those to show you how to kind of do a little threat hunting, leveraging this resource that I just mentioned here a second ago. Eric Zimmerman has a whole host of free tools for looking through prefetch or parsing through prefetch for event log. If you want a free tool that will pull event logs, extract out event logs, and put them into a format that allows you to kind of just play with them in a much more easy format, like Event Viewer, horrible, okay? EVTX eCommand is a great example of that. So this is just an example of me leveraging EVTX eCommand to process event logs, an event log, and then it puts it into a CSV format. Then I can use a tool also created by Eric Zimmerman called Timeline Explorer to pull open that event log in a CSV format, okay? And at first it's going to look a little bit odd because it's kind of just all sort of out there. But it allows me to, I can group on columns in this tool, and I can start to kind of pull out different sections to show that, like, all right, so for example, here I have process creation event, okay? So looking at, I don't know why I highlighted that, process creation event for Internet Explorer or iexplore.exe, okay? The command line for that is this right here, all right? So this is how it was started, which is not really all that special. But the parent of that is command.exe, right? I'm sorry, I'm backwards here. So command.exe is the executable. The parent process of command.exe is Internet Explorer. That's weird, okay? That's very weird. Internet Explorer spawning command line, command.exe. That's odd, right? Like, and the only way that I could sort of, or the way that I made this all come together was just kind of pulling, grouping by the command line, or sorry, the executable name, and then the parent process name and the parent command line, and like suddenly it's like, oh, well, duh, that doesn't look right. You know what I mean? Like, this shouldn't come from that. Okay, so I know I'm over time. Give me 2 minutes and I'm just going to breeze through. This is just more of the same. All right, a couple of tools I'm going to hit in rapid succession. Hayabusa, a tool that automates a lot of the threat hunting through event logs, okay? Phenomenal tool. A couple other tools I heard about recently that I haven't had a chance to play with.
You have until 4:20.
What the heck? Right. Dang, man. Dude, thank you. Thank you. Somebody. You know what? It's because I was like, there's no way, dude. Like, it's because I thought I thought the thing started at 3 and ended at 4. Man, dude, now we got time to play. The jokes are coming now. Dude, I appreciate that so much. anyway, it's probably good that I did that though, because honestly, I mess around a lot. So it might have actually been in my head that I was like, oh, you got to be done by 4, so that I would put myself into this like, all right, man, don't mess around. Actually, give these people what they want. All right. But now that I know what you want. You want the jokes because you're like, relax, dude. You don't have to go so fast. Okay, I got it. Okay, so Hayabusa. All right, so well then, yeah. To go back here really quickly, the goal here is that like event logs are something that everybody hates. Like if you're in a, by the way, I'm like thinking like these. I was wondering why the organizers didn't give me like a 15-minute, 10-minute, and 5-minute thing, and now I'm just realizing like I'm such a dummy. So anyway, event logs. A lot of people look at event logs and they're like, man, like, yeah, you know, this is child's play, and like, yeah, event logs suck, right? The reality is that most people think that because you don't know what the goal that is in event logs. Okay, that's number one. Number two, it's because a lot of the event logs that are super valuable are not enabled by default. Right? It sucks, but it's true. Like there are event logs, okay? There's process creation event logs built into Windows. You can just turn it on. You don't have to install Sysmon for this. You can turn on process tracking. In the security event log, it will track every time a program is started, okay? It will tell you that. It'll tell you the command line that it was started with. It'll tell you the parent process that is responsible for that. So we just looked at right now, Internet Explorer launching command.exe. That doesn't make sense. It doesn't look good or whatever, right? That's something that you could have, like, you don't have to go and buy anything, do anything fancy. You just turn on process tracking, okay? So there's that. There's also 5140s for share mapping. You know what I mean? Like stuff that, for lateral movement, duh, like this is exactly what I want, right? The attacker is like, you know, setting up a share, or rather mapping an admin share, moving malware over somewhere, executing that remotely, getting onto that system, like setting up a web shop. Like, there are so many things that I would be missing just not knowing that they're available to me and ignoring event logs, right? Okay, so I need to get really aware. Okay, yeah, thanks. 15 minutes now, yeah. So let me hurry up. No, I'm kidding. Okay, so there's so many things that in event logs would be wildly valuable to me. I don't know about them. They're not enabled by default, and so what I would recommend is that you go and you do a little searching on what is available and what's normal, okay? Forget for just a moment about trying to watch red teamers attack and like, reading blog posts about how they pivoted and did this and, what commands they executed or whatever. What is available naturally in a Windows environment, okay? Like what do I have? What event logs do I have, okay? What event logs are available to enable that I don't have enabled? What would that provide me? Share mapping, process tracking, creation of files. Like, what are things that I don't even know exist? The log journal that tracks every thing that the volume, or rather the file system, is doing. New files, created files, renaming. Did you know that there's something that tracks rename events? Okay, there's a journal that tracks when a file is renamed. All right, okay, if I don't know that those things exist, I can't make use of them. If I know that they exist, then I can make sure that they're either enabled or there's capacity to retain those things, or that they're being forwarded off somewhere or whatever it is. Then I can use these tools to go and analyze them. Then I can, once I understand what's out there, what I can look for, then I can automate it, okay? The next thing would be automating through things like Hayabusa. Okay, so I'm glad that you hit me right here, because these are some really, really phenomenal tools that I don't want to breeze through. Hayabusa being one where this is using something called Sigma, so Sigma signatures, okay, if you're not familiar with that, this is like an open source community of people basically writing signatures for you, helping you to find badness, okay? So then there's tools like Hayabusa that will ingest those, or already have them. You can write your own, you can customize it. And then you breeze through event logs and just do automated threat hunting, catching things like looking for lateral movement, looking for potentially persistence or weird user behavior and stuff like that. Okay, Hayabusa is one of the best ones out there for that kind of thing. I've not played with these, but within the last month or two, I saw somebody talking about they released something called Threat Seeker, which essentially does the same thing. They all kind of do it in a different way, so there might be different values there. And then Chainsaw is another one that does that as well. Okay, so these are great these are great ways for, at the beginning stages, for you to run them and, one, maybe quickly find something that you might not have found otherwise, or two, figure out what it's looking for, all right? How do you find out how to hunt? Well, you look at what the tools are doing, what they're looking for, what they would call evil, potentially, and then you go and figure out, like, how do I go do that manually, right? I'm a fan of that, the manual, scrappy method or whatever. Okay. Then there's a tool called Echo Trail that would be useful for you. Like, I don't even know if this is a normal Windows binary. Okay, well, how would you know that? There are some resources out there like Echo Trail. Echo Trail used to provide a lot more free. It used to be a lot more free. Now only like a line of it is free, which is essentially I can go and look at things that are normal Windows binaries that are doing weird things and figure out, like, are they normal, okay? SVC host, bits admin, certutil, all these Windows binaries that might be abused, and it could be malware, but it's malware that's named after, it's trying to masquerade and hide as a Windows binary, right? It's SVC host, it's named SVC host, but it's not the real SVC host. Well, how would I know if it's the real one or not, okay? Again, it's that ability to know what is normal, what's it supposed to look like. Echo Trail is a great resource for saying, okay, it's supposed to be running out of System 32. It's supposed to, it's either supposed to be connecting and opening, listening on a port or not, or what have you. It has a parent process of services, for example. So if SVC host has a parent process of command.exe, that might be the thing that tells me that something's wrong here, right? So knowing what's normal and then knowing the abnormal is where you're going to become effective, right? Like, I can tell when my kids are not feeling good or when something's wrong with them, or they're upset or whatever, because I know what they normally look like, okay? I know their normal facial expressions. I know what they normally sound like when they talk. I know how they normally respond to me when I ask a question. When I see something that deviates from that, that's how I know something's wrong. I might not know what's wrong yet, but that's how I know when something is wrong, and I got to dig in a little further. Yeah?
I'm not an IR guy, so this might be a dumb question.
No, go ahead.
If you can hash the application, why wouldn't you just do that as opposed to
Question is, if you can hash the application and then do a quick search on VirusTotal or whatever, why wouldn't you do that? Well, you could, so you could do that. Few things. One, it's very easy to change a hash, so like you might not find anything, and that might, you know what I mean? Like you don't know, right? Like I don't know that this is a core Windows binary. I don't know that this is something that should be a Windows binary, so if I hash it and find nothing, then I might just be like, okay, well, there's probably nothing. That also could be that it's malware that just hasn't been uploaded yet, right? The other reason is because I can't, it's hard for me to, that's a intensive process too, right? Like taking hashes and like running hashes for every single thing. But I can go and I can do a sweep across everything that's running, let's say that is in the System32 folder or not in the System32 folder or whatever, and look for markers of things. Like I can do, for example, a sweep across 5,000 systems looking for SVC host, not in System32. I'm not going to take hashes of 5,000 different SVC hosts and try to upload every single one of those. You know what I mean? So that's a good question though. All right, so anyway, so all of this is going to tell me, like, again, the parent process that should come up and the path that I should see it. I need to become very familiar with what is normal, right? I need to know my kids before I end up, figuring out if something's wrong. Lolbass is another really cool project that will categorize all of the Windows binaries that are very commonly abused for living off the land. So these are where it's like, it's not malware, it's actually the Windows binary that's being abused by a malicious actor. And so how they're abused, which ones are commonly abused, is all categorized in here. Phenomenal resource. So again, going back to bits admin, for example, this is, that, and then also the detection signatures and stuff to help you actually look for this kind of stuff. Same thing, living off the land drivers. Same thing, just a bunch of vulnerable drivers that are often used, things to look for if you are a defender. Going back to the Hunt Evil poster, the Hunt Evil poster on the left-hand side has a bunch of common Windows, some of the core Windows binaries, CSRSS, SMSS, SVCOS, and all that kind of stuff. And it'll tell you for each one of those, what's the parent process expected, how many instances should you have, where should it be running from, what kind of command line arguments should you expect. Again, know the normal stuff. Then you can see where the deviations occur. But more power is always obviously the answer, and I know that because one of my favorite shows Okay, it was tool time. And all right, so anyway, yeah. Oh, this is a ninja donkey, all right, riding a velociraptor hunting gigantic spiders. Okay, and that's because one of my favorite tools is called Velociraptor. Velociraptor is an open source tool that is so powerful, it can do so much, all right? We just talked about, like, the thing I just said, like, I can look for the instances of SVC host running on 5,000 systems across my environment, and then say, like, show me any of them that are not running out of the path I expect them to run out of, you know, system 32, for example. So it can do that. It can pull artifacts. It can run binaries. I can go get a whole triage collection of artifacts. I can interact with live memory. Velociraptor is phenomenal. So here's an example of me running PS list in Velociraptor, just listing out processes. I can do that for a single system. I can do that for 5,000 systems if I want to do that. I can also run PS tree, where I can look at parent and child relationships for processes. And if you want to get more familiar with that, here's another resource for you from a guy that's a very good long-term friend of mine, Eric Capuano. Super smart, has a whole video on just doing instant response with Velociraptor. But power is not the only thing I need. I need speed, okay? So CAPE is another tool that is a tool that will go get me all the greatest hits of forensics, okay? It'll triage, or rather, it will get a triage set of artifacts for me, okay? So if I think that I have a compromised system, I run CAPE against that compromised system. Go get me all the things that I want to look at that'll help me answer questions fast. I don't want a forensic disk image, right? Like, get me the blood samples and the hair follicles and all just that stuff, right? Cut me out a piece of the carpet. I don't want the whole house. I just need the things that are going to help me start answering questions fast. So CAPE will get me all of those artifacts, and then Plazo, along the timeline, will create a timeline from those artifacts and just put it all in all of the artifacts that I'm going to use for forensics into a timeline, so that I can look for, like, point by point, right? Time by time, step by step, type of analysis. TimeSketch is another open source tool that will allow you to ingest the timeline and make a more efficient process of bringing in a bunch of different timelines. 15 different systems. I can bring that all into TimeSketch, for example, for free, and then have, things that I just ultimately can browse through, tag, and I can make my own miniature timeline. Okay, so here's another great talk from again, Eric Capuano, Whitney Champion, two great friends of mine who I used to work with at Recon InfoSec, called Breaches Be Crazy. And so anyway, this is all about kind of making that process a lot more efficient by bringing in a bunch of different timelines and some of the back end things that you need to kind of engineer to do that right. Then, of course, there are also open source and free things that can help you to get trained up in doing all of this stuff in a way that's going to not lose everything that you just found, right? So, in other words, case management. So, the Hive is an open source project that allows you to implement a case management system to take notes, to correlate events and alerts and cases and stuff like that, right? So, like, I can now make sense of a case that I'm working right now because it has a lot of things that are in common with a case I worked 6 months ago. I don't remember that case, right? I don't remember the findings and all that stuff. But if I did my job right and I took notes and I pulled all that data out and whatnot, then this will do that for me automatically, right? It'll call back to, hey, 6 months ago you had a file with that same name, or something like that, right? Differ-Iris is another open source platform for collaboration and case notes and things like that. Now, if you want to get really advanced, okay, you get into cassette tapes. I'm just kidding. All right, so to get more advanced, right, like now we're talking about, I got visibility, I can do analysis, and I can scale collection and triage and all that stuff, right? Like I've now got capabilities, a lot of tools and things under my belt. Now the next step is to automate this stuff, right? Now, if I can figure out how to automate it well, I can save myself time on the things that a computer can do for me that I don't need to do, so that I can get to the next thing, right? If the computer can go grab me all the stuff that I want, put it in the place that I want it to be in, now I can start the analysis. Now I'm an hour ahead of where I would have been on schedule, right? And then, of course, memory forensics, and then creating your own lab to do all this stuff. This is probably not as good as many of the commercial applications out there, but it's phenomenal for a free tool for for automating all of the sort of use cases of incident response. Man, I'm super blanking on SOAR. Okay, there you go. So this is a free and open source tool for implementing SOAR. Okay, if you're not familiar with that, security orchestration, automation, and response. So in other words, bringing in a bunch of different areas of your logs and alert correlations and things like that into automation, playbooking. What do I do about that, right? If this thing pops, I want to go get a triage system, I can automate a lot of that stuff. Or go get an event log, or go get a very specific event, so for example, something pops in, like a weird network alert, and I go say, hey, go look for outlook.exe, spawning that, Internet Explorer, whatever, I can playbook things to go look for very specific things that'll help me to figure out, oh yeah, this is definitely something I'm super concerned about. Here's a great video for, why you would do that, how you would do that, using Shuffler. MemProcFS is a phenomenal open source tool for breaking down memory images and putting them into essentially a virtual file system. So extracting a bunch of memory artifacts out for analysis. Volatility is a more manual way to do that. So MemProcFS and Volatility do the same thing. Volatility has you run the plugins yourself. MemProcFS does everything for you. There's reasons why you might look to both. And then there's a great talk from last year's CactusCon, actually. CactusCon 11, called Scaling Incident Response with Live Memory Analysis, all right? So that's, again, every one of these things is a link to either a resource or a video. This full video is out on YouTube, as will this one here. And then the last things here are Lima Charlie is a commercial tool, okay? It's a commercial EDR, but anybody can go sign up to get 2 free instances of Lima Charlie. It will blow your mind, okay? It's basically, security operations infrastructure in a, cloud service, essentially, right? A lot of the things that we're talking about doing, this just put in Lima Charlie and it's done, okay? So again, a great way to play with it because you can get 2 free agents. Eric Capuano, again, great friend of mine, has a phenomenal blog with a very, very detailed walkthrough leveraging Lima Charlie, in fact, and some of the other tools that we talked about to set up the detailed walkthrough and setting up a lab, actually implementing a basic attack, and then doing some IR and forensics on that, the whole gambit of everything, right? I could have literally just got up, gave you this resource, or we could have walked through it, and I could have read some stuff to you, and it would have been as good as this talk. Not as funny, but as helpful. Kidding. And then I forget why. Oh yeah, okay. So also make sure that you're mixing with some of the organizations and the resources out there, keeping yourself kind of up to date. Darknet Diaries. If you're not familiar with this, you will love Darknet Diaries. All stories about attacks, phenomenal dramatized stories, very very informational. Also, Simply Cyber. Gerald Ogier is a guy who does a lot of work with people who are getting into incident response, or just getting into security, actually, period. And then Zach Allen has a great blog on detection engineering. Detection Challenging Paradigms is a great podcast. Thursday Defensive was mentioned yesterday in another talk. A great webcast that happens every Thursday. And then Lima Charlie has also Defender Fridays. Again, every one of these things has a link on cyberdonkey.net if you're interested in checking those out. That's it. So appreciate it. Thank you for not letting me end super early like a nut job. Appreciate you guys. Cool. I think we have a few minutes for questions, right? Or are we? Do we have a few minutes for questions, or is it? Okay, I'm good, unless anybody has a question. Wait, and I can stand out to the side too, and we can. Okay.
How does Lima Charlie compare to CrowdStrike?
How does Lima Charlie compare? Well, Lima Charlie and CrowdStrike are different. One of them is more for, again, the whole security operations infrastructure, EDR agent. The other one is more of an EDR agent that's AV and all of those things, like proactively blocking stuff. You could do that with Lima Charlie. It's just more on you. CrowdStrike's kind of more packaged. Yeah.
What one would you recommend for someone who is just starting out in this field, like someone who is a novice, or not really novice, beginner?
What's something I would recommend?
Like what service / application do you recommend the most for
You mean for learning or for like actually? Oh man, I mean any of the things that I threw up here, I would just like dive into it but Eric's blog, that one that I mentioned, back here, that's probably the best thing to start off with, and then like listening to like Darknet Diaries and just staying motivated. Yeah.
Thoughts or opinions or preferences for incident response on non-Windows systems?
Oh man, thoughts on non-Windows IR. Yes. Okay. So one, really quickly, Linux and Mac are out there. Okay, they're like I don't even know 1% of the things that you're ever going to deal with. So there's, unfortunately, because of that, there's a lot less resources, knowledge, and training, and so on and so forth. But it's becoming more popular. So like, I would say that I would dominate the Windows area first, and then move into those cases because it's easier to get a job. Let's say, for example, when you have Windows skills, and then you can be more valuable when you add Linux and Mac skills to it. Unless you work at like Apple, then right? Like, then you need to know Mac. All right, cool. I'll hang around in case anybody has any questions. But hey, guys, I appreciate you all so much. Have a good one. Yeah. I'm gonna come over here so that because I know they have to load up with.
Thank you. Does it look better now?
I like to have this much video. It's representative of your organization. Okay. Can I say it?
All right, I'm getting started. Hold on just a sec. I don't know.
Check yeah.
This is not working how I want it to work. Oh well. All right, how's everybody doing? We made it through. We made it through to the other side, right? I apologize in advance. I know some of you are expecting the cactus costume to come back. the fan broke, but it'll be back next year. So I've got the blanket this year. So we're good. Welcome back. If those of you who are here at opening, if not, welcome. Happy to see everybody. This is amazing. This is the most people I think we've ever had stay all the way to closing. So super excited. We had, what was it, over 400 people check in just today alone, which is the biggest second day new check-ins that we've ever had as well. So that's been great. I always like to go through some photos, some of the candid shots we took, some shots that I found on Twitter, just some of the things we saw. This was our CISO track for the first time. We did a CISO track this year, and everyone's really popular. Some photos of people presenting. This Arby's sandwich, people were talking about it on Twitter. I'm not 100% sure why, but this was a big topic of conversation. Someone made it clear that CactusCon has the meats. So, yeah. It was left in the career village, this sandwich. Raise your hand if you left the Arby's sandwich in the career village, please. Anybody? We want to get it back to you. We have a lost and found up here. There's actually a bunch, seriously though, lost and found for real. I've got some sunglasses, AirPod Pros, a pocket knife, some other stuff. So if you're missing something, please come let us know. What else we got? This cake looks really good. It's a Tres Leches cake from somewhere near here, I think. Tres Leches carrot cake. It's supposed to be good. I don't know what's up with the tentacle, but it's been seen in various places. Yeah, the tentacle made its way to the greenhouse, so that was cool. Badges. The badges looked awesome this year. They glowed up at night. I got this photo here of Snow Talks. We had a great event last night. Who came out last night to the arcade? That was awesome. And thanks to Sober and Cyber for doing some mocktails as well, so that was really cool to see as well. Yeah, so it was a great year. I want to talk through some attendance numbers. This is a recap of previous year's attendance. The first CactusCon was actually 2013 was the first CactusCon. The year before that was B-Sides Phoenix 2012. But the first CactusCon was at Dave & Buster's and had 205 attendees. So I won't read all of these, but I'll just cycle through these. You can see every year's getting bigger. 2021, just on Discord. That was an interesting year, right? Who attended 2021 just on Discord? 2020, I thought it was 20. Yeah, it's 2021. Yeah, the Discord online only year. That was fun. Who remembers in 2022 when we moved to the Delta Hotel? Last year we had 1,435 in-person attendees, so that was pretty great. So let's talk about some stats from 2024. We had 609 attendees on Discord. So hey, Discord people, awesome, happy you're out there. So thank you. The bots in Discord was 20,753 lines of code. The badge had 13,325 lines of code. There was one AA battery where it shouldn't have been. Raise your hand if you let the smoke out of the badge. Thank you. There were 2 hard hats. I don't know if they're still here, but I saw 2 hard hats walking. They're back there. One random child's sock was found at registration. Even better, it was found in the stuff we packed up from last year. So somebody must have saved it in case someone came back this year, came up to the counter and said, "Excuse me, I was here last year. My kid left one sock. Do you happen to still have it?" So, one mildly explicit-looking tentacle. Which brings us, we had 2,790 tickets sold or claimed. That's pretty great. And our total in-person check-ins from yesterday and today is 1,791, which is amazing. I don't math good, so I think that's about 500 more in person than last year, right? I think I said 1,400 last year.
About 300 then.
I don't math. Oh yeah, 300. Thank you. I don't math good.
He doesn't handle the financials.
Yes. I'm not in charge of money for good. What happened to the slides? I think this box down here keeps flickering out. Hold on. Whatever you did, you just took my slides down.
Took your slides?
Oh, the back. Okay, good. So Discord stats. We had 826 users in the Discord server. Stop moving. We had 9 volunteer moderators, so thank you to our online team. 609 users checked in with Hacktar, our bot. A total of 1,288 messages sent in the Discord. 42 help tickets were opened in the Discord, handled by our volunteer team. 10 people tried to send the example ticket to the bot. So those who don't know, when you sign a Discord, the bot asks you to send it your Eventbrite ticket to check you in. And it shows a sample saying, like, this is what it should look like. And 10 people, it sends a message back that says, really? 4 people try to send a link to the bot. And the bot responds, I ain't clicking that. So yeah, Discord was really great this year. Yeah, so let's talk about our speaker stats. We had 144 total submissions to our CFP, which is amazing. That was freaking awesome. So great job, everybody who submitted. Even if your talk didn't get picked, that doesn't mean it wasn't good. Like, awesome. It was really cool. 66-hour long. I think these numbers might be wrong because those don't add up to 100. Those don't, right? I don't math good. Okay. 41 accepted talks or workshops. I think it was more than that. That number doesn't seem right. But 90 total speakers. So big thank you to all our speakers. Nice work. I was told last year this went on too long, so I'm trying to not get in trouble. So. Yeah, I'm looking for the person in the back holding up the "You have 5 minutes" sign. Where are you at? Okay. There it is. Thank you. I got 15 minutes. I don't know if that's accurate or not, but yeah. And the submissions were pretty evenly split between introductory and intermediate level talks. It's really awesome to see all the introductory talks and all the higher level talks. So it was really great to see that nice spread. We use sessionize.com for our call for papers and scheduling, and it's been awesome. So big thanks to them. They hook us up as a nonprofit with a free setup every year. So really big thanks to Sessionize. Big actually round of applause for Sessionize if they're watching. We use it extensively. The schedule on our website pulls right from Sessionize. The script that we use to put the titles on the overlays on the streams are all direct from Sessionize. So really cool. All right, let's bring up the badge team. Come on over. Here we go.
So it was a long journey to get to this place. For those of you who don't know, we started talking last year right after the conference about the badges for this year. We're starting the same now for next year. It's a lot to pull us all together. But I first and foremost just want to give a massive thanks to Kevin, who's down over there. Yep. He is the incredible hardware guru that takes art and makes it into these beautiful PCB things and routes all the stuff around the artwork, which is just an incredible skill that I am it's just awesome. And then Randall, who's online, helped a lot with the back-end code and some of the badge code as well. That was doing all the hard work of computing your scores and running the whole game. And there was many, many late nights that he put in and a lot of hard work there too. So thank you, Randall. And we've also got Car, who helped write some of the code. If anyone, who got their badge tampered with? Via IR with the add-on. Everyone? He helped, if you saw the hacking device, that was all his code. And so he helped write about that. Carter, you want to say a little bit about what you learned? Just very quickly?
So I learned how to use a repeating loop, like the ones where like 14 times it repeats, and also I learned how to like show texts on screen. And also, if you haven't heard from Merch about the like stations, I hid one positive station behind a Coke machine and then another behind another Coke machine.
So I'll briefly explain how many of you guys got a low conformance score this year?
Yeah.
All right. Do we have a slide of the
Oh no, but I can pull it up. I forgot.
You can pull it up on the screen. So, we were hoping people would not conform to Big Hacktar, If you guys attended Naomi's talk, she talked about all the data collection, and she mentioned Bluetooth. Bluetooth was what powered all this year. The stations that Car helped hide were beaconing. There are stations that looked like this hidden throughout the conference. Some were beaking negative conformance scores, so if you were in this room, you were getting your score decreased. And then the ones by the Coke machines and in the hallway. Did anyone see the propaganda posters? If you hung out in that hallway and was wondering why your score was going up, it's because you were conforming to Big Cactar around the propaganda posters. And so, but at the end of the conference, we had an overall, this was the average conformance score, a very low conformance score. So good job, everybody.
Way to non-conform.
And two last things that I'll mention, some of the interesting stats. The one that I find really incredibly interesting, the citizen interactions, was anytime there was a Bluetooth beacon between badges, exchange. So if you saw someone else, your badge saw another person, they beaconed, they reported to the back end, that affected your score. There were 43,000 interactions between the badges throughout the 2 days in the conference.
Y'all are friends, huh?
A lot of good networking. Good job. But the last thing I'll mention, these are all ESP32s. They have USB-C ports on them. So I would very much encourage you guys to take this home, play with it. We have a tutorial from last year. We're going to get another tutorial up for this year, but it tells you how to use Platform IO and use how you can write your own code for this badge. Couple of challenges to throw out there. There's an SD card reader on it. It can monitor Bluetooth, so make it so you can go war driving with your badge and capture all the BLE beacons that you see everywhere around you, and there's a lot of them. So yeah, that's one thing. Or if anyone wants to do a really cool Etch-a-Sketch app, these are great knobs. And with that, I will hand it to whatever's next.
Big round
Back
of
to
applause
Alex.
for that. The slides back up. There we go. All right, CTF. Where's our CTF team? Barrett and Wes. Every time someone walks up on the stage, it flickers the screen.
Try not to move too much. I'm Wes, this is Barrett. So we ran the CTF. We just want to say thanks for CactusCon having us out every year, and thanks to all the players for playing. It was an amazing event, and I know everyone wants to get to who the winners are, but just give us a few minutes. So we had a great showing. Every year we get more and more people playing. This year is great just to see everyone out there at all the different tables, all the interactions coming up. There's just a lot of good vibes. So with that, we have some of the stats up here for all the teams that played and the challenges. A lot of back and forth with everyone, and definitely with the top three. We had a lot of switches that really the top five just kept on moving around back and forth. So I think this will be a little bit of a surprise to see who actually won. But before we get to the actual winners, let me turn over to Barry.
If you think you're in the top three, please get ready to come up. We're going to announce the winners. First, I just want to thank our prize sponsors. So we've got patches. I think quite a few people have patches here from the Red Team Village. That's a nonprofit. We have a big show at DEF CON every year. Definitely want to thank Pen Tester Toolkit for some lockpicks as well as a land tap for the prizes. And then, of course, Kevin and the Badge Pirates for a couple of badges. So without further ado, here's our scoreboard. So I think we know who the runner-up was Brain Dead in fourth. In third place, Subterranean Satellite. If you could come on up, just right up front here, we'll get you your prizes.
One-person team?
Four, I think.
One-person team?
6 of us.
Oh.
Yeah.
All right.
Who's the rest of your team?
They were online today.
All right. And I think there's at least 30 people that are really interested to see how this turned out. But in second place was Purple Drink. Congratulations. Come on up. I believe you won second place last year as well. You came in strong this year. Next year we will be back, and let's see if you can take that first place. You
You solved 30 challenges out of 37. Wes is going to give you your prizes. Can we take a picture? Kevin, will you take a picture of? You take a picture of us? Super quick. But great job. This team, they did it so well. They locked down a table, and they made sure to have people who go out to talks and come back, and they were taking shifts, and they worked pretty hard the entire time, and just barely missed first place. All right, thank you, folks. Thank you very much. And then if I can have the Deep Fonts team come on up. They got first place. You can see they also solved 30 challenges, but they solved a couple of the harder ones to get a few more extra points. So come on up here, and we've got some prizes. Yeah. All right, one last round of applause. Thank you, everybody. The last thing I wanted to say, I'm all the way up in Washington State. He's in the Washington, D.C. area. We come here. This is our 4th time doing the CTF. Like, you know, we don't live here, but this feels like a hometown con for us. We love coming out here. Love seeing it get bigger and better every single year. We'll see you next year.
Yeah, throughout.
I was just told I should throw these at people, so. Oh, sorry.
Please don't poke an eye out.
Here's working a little bit better.
Protect your eyes.
Oh, no.
Yeah, pretty much.
I'm out. All right. Next year, we're getting a T-shirt cannon.
I might as well get a Nerf gun and just start shooting everybody.
All right, next up, I'd like to call up Andrew. Where's Andrew? Andrew's going to talk financials.
He told me to throw them out, so I did. I was just doing what I was told.
Okay. Yeah, so every year we try to take a minute to actually share money details, things that we've earned, things that we've got from the community, sponsors, et cetera, in order to make all this happen. For the folks, this is your first time here, I'll just say we are not nonprofit. We don't make any money off of this. Everything that comes in goes back to the conference, right? So no one gets a salary. Everything is all volunteer. I think the only services we pay for are some accounting things, and the rest is really just all volunteer, sort of homegrown sort of stuff. This year was the first year we had charge for tickets. So part of what I wanted to come up here to talk about was that, you know, as we've grown up over the last 11 years, we've been free for everybody. That's been our motto, our mentality, and we've tried really hard to continue to make that experience available for as many people as we could. The reality, of course, is at $64,000 to rent a venue, not including all of the other expenses and all the other pieces that go into it. You know, we get more and more to this point where we have to look at the tension between how do we get to that dollar, and how do we continue to be sort of independent, how do we continue to make this something that we want to come to, that we want to continue to drive, you know, because we could do less, which isn't an option, or we could do more with other types of opportunities, and this is the compromise we came up with, right? For the folks who didn't know, we've offered free tickets to students for the entirety of the year. We had definitely several hundred students show up this year and take advantage of that, and we're going to try to continue to offer as many free tickets every single year that we can in order to continue to push it forward. From a total income perspective, we exceeded anything we've ever done from revenue ever in the entirety of our conference. First, and obviously a really big shout out to our sponsors. We had 3 partners this year, and I think 3 partners and then 8 sponsors who brought it in, and through just that, it was a $70,000 increase to what we were doing. It's just a fantastic opportunity for us to continue to move forward. And then with the ticket sales alone, just with badges and the $25, et cetera, $60,000 all in order to do that, which is fantastic. This is from the community to make this a community event and grow it. So all in, about $140,000 in total income. We had some left over from last year that we used to offset some of the initial startup costs, and that's what we'll do with sort of the remaining difference. But as you can see, the venue is still the biggest piece. But I love this venue. For the people who are pretty old school DEF CON folks, it reminds me of the Riviera, and ever since I walked in here, I was like, this feels like my house, and I never want to leave. I just love it. And so we love the Mesa Convention Center, so thanks to them as well for everything that they've ever done. And then the rest of the costs are really what you'd expense: swag and merch, some of the T-shirts and things of that sort, the art that you saw around the venue, operations being the cost to get everybody out here, tickets, hotels, bringing in some of the keynotes, et cetera, and then the regular accounting, badges, and whatnot. I think with everything we've got, we'll take it and reinvest it like we always do back in the conference. I think some of the projectors would probably do a refresh if you were in certain rooms. And so, we use that as an opportunity to improve. In fact, this year, Alex, last minute, actually took on and rebuilt the entire AV streaming system in order to save costs, basically from the ground up. And this is the first year we had a full homegrown live stream recording situation happening. So thanks to Alex for that.
And I'm sorry for all the issues we had yesterday on the stream. My bad.
He said he's sorry for something.
Sorry, we had stream issues yesterday. The quality wasn't great. Today was better. We'll be better next year.
Cool. That's all I have on the financials.
Cool.
Unless you want to talk about my whale campaign? No?
Did you end up registering that domain?
No.
I'll put the QR code for you to GoFundMe at the end. How about that? Weren't you going to register killallthewhales.com? .org, sorry, .org. Am I allowed to talk about killallthewhales.org? Okay. No Starch Press gave everybody a 30% off coupon code, so take a minute to write that down. CactusCon 2024, 30% off, no starch. Give you all a minute. We good? Okay. Is Ryan here? Did he leave?
Meow Mix comes in two varieties.
Right back there. There he is.
A medley of mackerel, tuna, and crunchy centers bursting with seafood flavor. Meow Mix tastes so good, cats ask for it by name.
I made a promise that would go in every single closing slide that I lead. So, Ryan was our lead organizer, and that was from the virtual year. I don't remember what has happened, but you got so flustered, you're like, meow, and someone turned it into that video, and it was brilliant. So it's always going to be there. And yeah, I'm going to turn it over to Christine now.
Do I have to hit the button?
I'll hit the button.
All right. Hi, everybody. I'm Christine Wilson. I refer to myself as the person that corrals all the cats that make this conference happen. So I'd like to take a moment, although it's a lot, but I'd like to take a moment to recognize and thank key people that make this happen. It is a lot, and it happens all year round. First and foremost, especially since I forgot to do this last year, I'd like to thank my family. That includes Andrew Wilson, my husband. Otherwise known as, are you Christine's husband? And my 2 kiddos, you might have seen them wandering around, but they deal with the madness of eating, breathing, drinking CactusCon, especially like the month before. It's crazy. So thank you, family, Wilson family. Also, I'd like to thank the volunteers. As Andrew mentioned before, we're all volunteers. That's the board of directors, the staff that leads all of these sections of the conference, all of the green shirt volunteers, the orange, yellow, I don't know what you call it, mango color.
Goldenrod.
Technically goldenrod volunteers, our speakers. You know, I appreciate that. Like, people say, thanks, Christine, you do a great job. And I'm like, it's not me. I am honored to get to herd and corral all of this, because if one part is missing, none of this happens. If you guys weren't sitting there in the audience as our attendees in our community, it wouldn't happen. If our sponsors didn't show up, we're done. We're a nonprofit, volunteer-driven. These guys on staff, which I am going to call out by name. Oh, sorry, out of order. Keynotes. Thank you.
We'll go back later.
Our board of directors, Andrew, Jessica, Skylar. Our staffers, we meet all year round. Sometimes it's more intense and other times it isn't. Yeah. Alex, Brandon, that's me, Haley, Matt, Jamie, Mark, and Mike. We meet maybe more often than they prefer, but it's an all-year thing, and it's a lot of fun. We have fun. Our team leads, Eden, Richard, Tim, and then our village leads. Like, these guys I pester. I'm like, hey, you want to come back? All right, great. So that's Barrett and Wes with our CTF crew, Drew with our physical security, Eli with DC 480 and Snow Talks, who also put together the level 1 after party last night. Gavin and Rachel at AI Village, amazing job. Rachel Harpley with the Career Village. Yes, Russ with the Greenhouse. Oh my gosh, that dude. Andy with the CISO track, our first year doing the CISO, and Mizan from Chandler Gilbert Community College, and Paul Hickey for CactusCon Kids. This year we brought it back. It's going to grow next year, so stay tuned, but I'd like to recognize those people. Andrew already stole some of my thunder, so I'm not going to repeat a whole lot, but thank you, sponsors. I'd like to go back to thank our keynotes. Keynotes, Rhiannon and Naomi, thank you very much for coming out and amazing. But I'm doing the Mexican thank you. I'm so sorry. I know. We live in Mexico. The thank you is this. And so it's very different. And I keep finding myself doing this. And I'm like, oh my gosh, everybody's probably thinking I'm cussing them out. So really, for me, it means thank you. Sponsors. Our partners, Axon. Axon's been with us for years. Finally, thank you for becoming a partner. Early Warning, New Genesis Solutions, our gold sponsors, Avertium, Data Theorem, High Tech, Godalski, Panther, PlexTrack, Red Canary, Staffing Science. Thank you. We also have our in-kind sponsors, Chandler Gilbert Community College, EFF, No Starch Press, and OWASP. OWASP, we're going to be doing a raffle for 2 OWASP San Francisco tickets. We're going to be raffling off some more stuff, but I'd like to thank OWASP for donating those to us. And I think that's it for thank yous. Thank you, yes. Oh, no, wait. I have 2 more. I'd like to thank Jack Resider for doing a giveaway. Oh, another t-shirt. Thank you. Just 1 second. And Pen Tester's Toolkit. Our first year having somebody come out and sell some stuff. So thank you, Pen Tester's Toolkit, for coming out. We hope you'll join us next year. And I think that's the end of my thank yous. Thank you.
Are we trying to lower people's scores? Is that why that's here?
Yes.
More conformance scores lowering? Cool. The art. Let's talk real quick about how amazing that art is this year. It turned out amazing. So Every year we get a different artist, and this year's art is just unbelievable. The theme has been great. Big Hector's eyes will haunt me in my dreams. So, yeah, let's give some stuff away. What do you think? Did everybody get a ticket? Did we end up giving those tickets out? Did we forget to give the tickets out? Raise your hand if you do not have a ticket but want one. Do we have volunteers with the tickets who can go drop these out real quick? Yep. All right, give us just a minute. We'll give away some tickets. Oh, I'm told to tell jokes. So a guy goes into a doctor's office, says, "Doctor, I don't know what's wrong with me. Last night I dreamed I was an A-frame. The night before that I dreamed I was a wigwam. What do you think the problem is?" Doctor says, "Well, you're too tense." No? No? I'm trying to think. I see all these hands, and I'm sure you want tickets, but hopefully maybe y'all want jokes. But no. Raise your hand if you love my jokes and want. Okay, thank you. Thank you, everybody. Okay. Anyone know any good jokes? How did the hamburger introduce his girlfriend? Meet Patty. Wonderful. We have a joke in the front row. What do we got? Why did 8 stay away from 7? 7, 8, 9. Good one. Good one. Nice. All right, we're almost ready to give some stuff away. What do y'all think of these? How many noticed that they changed last night? I was just seeing who did not notice that they changed?
Where are the rest of my raffle tickets? Huh? Yeah, we're putting them all in here. He's got.
Here's an example of them changing. So on day 1, this poster was up. And on day 2, we replaced it with
Okay, this is it?
that.
Okay.
And so each of them changed to something slightly different. I know there's been a lot of questions about where you can buy these. We're going to try and put them up on store.cactuscon.com tonight. So if anyone's interested in these, they should be up there tonight. And we're going to give some of them away, the ones that were in the hallways. So does everybody who wants a ticket have one at this point? Can I have 2? No?
Careful them.
I could sing a song. I mean, you don't. No, no.